Hello learners, in this lecture we will see the sequence of a construction project. Who is a client? Who is the architect? What is the role of a civil engineer? What is the role of a structural engineer? And what all subjects we are studying in the engineering? What is the practical application of those subjects? Where we are actually going to utilize or where we are actually putting our knowledge into applications. We'll try to see that everything in this one lecture. Now, let us consider you are a client to me. You have a plot with you and you have a plan to construct a big bungalow for you, right? So how do you proceed with that? So I'm a structural engineer and you have come to me that you have a certain land. Let us say you have a plot of 30 feet by 40 feet and you have a plan of constructing a big bungalow over that. So how do you proceed with that? So that is what I've written it here. So it's a client requirement. So the client requirement can be a 1 BHK house, it can be a 2 BHK house, it can be a 3 BHK house, it can be a bungalow, or let us say you want to put a big residential building in your plot, or let us say you want to put up a big commercial building. Let us say you want to put up a big hotel or a mall. Then how do you do all these things, right? So before that, 1 BHK stands for the B stands for bedroom, H stands for hall, and K stands for kitchen. When I say 1 BHK, it's a 1 bedroom, 1 hall, and 1 kitchen. When I say 2 BHK, it's a 2 bedroom, but 1 hall and 1 kitchen. If I say 3 BHK, again it is 3 bedroom, 1 hall, and 1 kitchen, right? Now let us say you have a plan of constructing a bungalow. Done. So once you have finished that, you're going to come to me, and what I'm going to do, I'm going to give a architectural plan. So what is architectural plan, how it looks, we'll see that. So to prepare an architectural plan, we require certain softwares. The first software that you can use for preparing any architectural drawing is a AutoCAD software, right? After that, you can make use of a one more software called Revit. Revit is also a good software where you get the 2D and the 3D plan and you can do all the quantity estimations and all. Similarly, you have a Google SketchUp. Google SketchUp is for you to get a 3D elevations, the interior parts and all. Then you have a AutoCAD 3D as well, right? So let us say you come to me for the plan. So what I'm going to do, I'm going to prepare a plan for you of a bungalow. I'll show it. Okay, let us say you have a plan of a 1 BHK. I'm taking a random thing here. So if you come for me for a 1 BHK plan, so this is how a plan that I'm going to give you, right? You're making an entry to your home from here. You have a small hall here. I'll be giving a toilet here, which is a 5 feet by 6 feet 1 inch. Then I'm going to give a bedroom here, which is again 10 feet by 9 feet 9 inch. Then you have a kitchen here. So it's a small 1 BHK plan. So you can see here one bedroom, one kitchen, and a hall is given here, right? Yeah, forget about this. Think that you want to construct a bungalow, so you come to me. So this is a kind of a plan that I have given you. Okay, so it's a ground floor plan what I'm showing you, and this is the option one. You're coming from here, you're making an entry to the house from here. It's a foyer here, a small place where you can sit. From here you're making an entry to a formal or a living room. Again from here you come out, you go to this kitchen. You have a kitchen here. From this kitchen you have a small storeroom here. You have a utility here, and there is a wash basin here. You're going to keep a stove here. Then this is a dining hall what you have. From here you'll go to the master bedroom. Similarly, you have a small puja room here. Then you have another bedroom here, and from here you are going to take the staircase, and adjacent to the staircase you have a one common toilet here, and then you have a rear entry here. So when I'm going to give a plan, I'm not going to give you only one single plan, because each of us have a different view, and each of us have a different thinking. So that is the reason whenever you approach to me, I'm going to give 2 3 different plans, so that at least anyone you are going to like it. So that is the reason you can see here option 4. Okay, you can see option 4 written here. It's okay. Okay, give me a minute, I'm gonna do it correctly. So this is the option 4 what we had seen. Similarly, we'll try to see the option 1. I should have shown this option 1 first, then the option 4. It's okay. So this is another option he has given, right? So again, you're making an entry from here. You're going to park your vehicle here. You're making an entry from here. You have a living room here. You have a kitchen here. Then there is a small puja room here. You have a dining here. You have a staircase here. From here you make an entry to the bedroom. Then you have a attached dresser and a attached washroom. Similarly, from here you make an entry to the bedroom. You have a attached dresser and a toilet. This is a option 1 now. Similarly, I'm going to give you another option. You can see here it's option 2 here. Again, you're going to make entry from here. From here you're going to make entry. You have a foyer here. You have a living room here. Then you have a bedroom here. Then you have a dresser here for this particular bedroom. You have a dining here. The staircase is given here. You have a dresser here, and then you have a toilet here. So here you have a bedroom. You have a puja room here, a kitchen here. So this is the option 2 you are given. Now coming to the last option, or let us say option 3. So in this you have make an entry from here. We enter here. You have a foyer here, right? From here, this is a living room what you have. Then you have a staircase here. You have a master bedroom here, puja room here, and so on. So in this way I'm going to give you different plans, so that at least one you're going to like it. Similarly, I'll show you for other thing, like if it is a, yeah, this is option 4 which we already seen, right? So this is the option 4 what we had seen. Yeah. So in the same way, let us say you have a 2 BHK plan. So this is how a 2 BHK plan looks. This is how a 3 BHK plan looks, right? So again, this is another 3 BHK plan. Fine. So once this is done, let us say this is a plan what you had liked. Out of the 4 different plans what I had shown to you, this is a plan which you liked, and you told me that you're going to go with this particular plan. So then what we are going to do, I'll go back to the PPT again. Yeah. So once I prepare the architectural plan, like option 1, option 2, option 3, after that I'm going to send the drawings back to the client. So once you are a client to me, now you have liked one of the plan which I had told. So let us say the option 4 is a plan which you liked. So you are saying that this is a final plan I would like to go. So once you say that that is a final plan that you like, what I'm going to do after that, I'm going to do the analysis and the design. Let me keep it here. Yeah. So I'm going to do the analysis and the design. So what do you mean by analysis and the design? So far what I've shown you, it's only just a plan and the column locations has been shown. But this building is not designed, right? I don't know what kind of load is coming on that. For that particular loading, what should be the thickness of my slab? What should be the dimension of my column? What should be the dimension of my beam? What should be the size of the foundation? All these things is not yet decided. For that, we need to do the analysis, and then we have to do the design, and then we have to do the detailing of that. For that we have other softwares like etabs. You have a software like stad pro. You have other software if you want to do the foundation designs. Then you have a software called safe. So far what we were telling is about the residential buildings or the commercial buildings. Let us say you're working on a project for some government projects. You want to design a bridge. So in that case, etabs will not help you. You can make use of a stadpro software and design a bridge, or there is a company called CSI. They have their own software called CSI bridge. Similarly, in this way we have different softwares and all, right? So again, once the analysis and designing is done, what I'm going to do, I'm going to make use of these softwares like etabs and stradipro, and I'm going to design it. So before that, now let us say whatever plan I had shown you, that is a 2D plan. Let us say you're interested to know more about your home, like how the interior is going to look, how the 3D elevation of your house is going to look. In that case, what you can do, you can make use of the softwares like Google SketchUp, 3D Max and all, and you can do that. For example, I'll show you one of the image of that. Yeah. So even in this way, you can prepare it. Even before you enter into your home, you can get an idea or a look how your house is going to look, right? So this is a kitchen area. This is a dining area. This is how your bed is going to look. This is a washroom area. We have another bedroom here, right? In this way, you're going to get a interiors of your home. So this is another elevation, a 3D elevation of your house, how your house is going to look. Similarly, this is another. So far what we saw was a ground floor. Again, let us say you want to see how your first floor is going to look. So you can see a staircase here, right? Then again you have a bedroom here, you have a bedroom here. So in this way you're going to get. So for the same plan what I had shown you, the 5 BHK plan, for that if you want to have a 3D elevation, so this is how a 3D is going to look, right? So this is from here you make an entry, you had to park your vehicle here, this was your kitchen area, and this is how the elevation is going to look. So in this way if you're ready to spend the money, uh, these people are there are people, those are architects and all, they're going to give you the 3D elevations, the interiors and everything, right? So in this way we have different categories, based on that we are going to release the drawings and all these elevations. Done. So this was all about the architect. This is how the architect and this interior designer, this is what their role is all about. Now from here whatever I'm going to explain you, it's a role of a structural engineer and a civil engineer. So like I mentioned, I'll go back to the PPT again. Like I mentioned, you can make use of the softwares like ETABS, STAD Pro, Safe and all. So I'll show you the ETABS software, how it looks and how we are going to do the designing and all. Yeah. So this is how we try to model the buildings with the help of a ETAB software. Whatever we saw was just a plan, right? Now here really we try to model the same building with the help of a ETAB software. We try to apply all the loads on this. We try to size the column. What should be the size of the column? What should be the size of the beam? What should be the thickness of the slab and all? And this is how we try to prepare it. Let me show you the 3D view of this. Right, so this is how your building looks, you can see it here. So this is how your building looks. So we are going to design this. Yeah, similarly I show you to, this is one software called ETABS. Similarly let us say you have another different building. Again this is how we have modeled the building. We are going to model the beams, the columns, the slabs and all, right? So once we do the modeling and all, we do the analysis and all, finally we get the answer. Like after this after the analysis we say that for this particular building I want to provide a 230 by 450 sizes of the beam, 300 by 450 dimensions of the column. The size of the footing has to be like 2 meter by 3 meter. The depth of the footing has to be 300 mm. This much steel has to be provided. All those things we are going to prepare, and once we prepare that we are going to release the drawings to the client. So those drawings which you are going to release, they are called as GFC drawings, that is good for construction drawings. Let me show it again, you can see it here. Release the drawings to the client for the construction. GFC stand for good for construction. I'll show you the AutoCAD software as well. I did not show it. Whatever drawing whatever ETABS model I had shown you, this is a architectural plan for that. So this is how it is planned with help of a AutoCAD softwares, right? Let me show you one more plan as well. So this is a big bungalow plan what they have prepared. Again with the help of AutoCAD we are going to prepare all these things, right? You can see here it's a bedroom here, the kitchen portion, another bedroom, the entry, then we have a car parking here, and everything will be shown here. Then this is a just a architectural plan. Similarly you can see one more yeah, so this is one more plan. So different plans, different architect, based on the requirement of the client we are going to do all these things. Yeah, so once all these things are done we are going to we are going to release the drawings to the client, right? So we'll see that how those drawings are going to look. Give me a minute, I'll try to show those structural drawings. Yeah, so let us consider this is a plan. Now for this plan you have done a model with help of ETAB software, then you are going to release the drawings. So this is the first drawing that you are going to release. So in these drawings you are going to mention what should be the size of your footing. Let me try to zoom in. You can see it here. This is a footing schedule. What grade of concrete you have to use, then what is the size of your footing, the length of your footing, the breadth of your footing, the depth of your footing, what reinforcement you have to use, whether you have to use 8 bar, 10 bar, 12, 16, what should be spacing between the bar, how a typical cross section of a building is going to look. All these things you are going to put it in the form of a drawing, right? In this way you're going to prepare the drawing for what should be the size of your column, what should be the size of the column, what reinforcement you need to use in the column. All these things you're going to release the drawings. Similarly, how your plinth beam layout is going to look. Similarly, how your ground floor layout is going to look. You can see it here, right? Ground floor beam layout. Similarly, if you're putting up a beam, what kind of reinforcement you want to put in the beam, what should be this, diameter of the bar that you need to put, right? You can see it here, that is in this particular beam of 230 by 380 size, you need to provide 12 diameter 3 bar at the top, 12 diameter 3 bar in the bottom, and this is the stirrups that you need to place, and all these things you may find it bit difficult to understand now since it's an initial lecture. So in this way we have to prepare. In the same way, how a slab details is going to look, what should be the thickness of a slab. You can see here 150 thick slab is written here. What is the diameter of the bar you are going to use, how, what kind of slab it is, all those things will be mentioned in the structural drawings. So in this way we are going to release the drawings. So I'll go back to that PPT again. Yeah. So once the first drawing we already seen is the footing layout. Then we see, when we see in the column layout, the plinth beam layout, ground floor's column reinforcement, first floor beam details, first floor slab details, overhead tank details. Then if you have some miscellaneous drawings in this way, as a structural consultant, I'll try to release all the drawings. Once the drawings are released, now we have to do the actual execution of the work, right? So far what we have seen the models, we had seen the drawings and all. Now it's up once we finish this, these drawings will be sent back to the client. Since you are a client, I'll be sending this drawing back to you. Now you have to get this building constructed. So now what you're going to do, the client will give work of execution to whomever he wants. That is a contractor. Let us say you know some contractor, so you give a work to him, you award this work to him. If it is a government projects and all, they call for the tenders, and different big companies, they come, they bid for the tender, and based on that, based on their experience, based on the price they have quoted, we are going to offer the project for them, right? Yeah. So let us say you are given a work for some a local contractor whom you know. So what the contractor is going to do, the contractor is going to do the execution of the project. So how he is going to do the execution? First he's going to come to the site. Let us say if it is a very big site and all, we'll try to do the soil testing and all, because we need to make sure that your soil is capable of taking the load and all. Anyway, the soil testing will be done, and only then these things will be carried out. Okay. So only after the soil testing is done, the footing layout and all will be given, because it all completely depends on what is the capacity of the soil, right? And after that we are going to do the marking on the site, right? Then after that you are going to put the laying of a PCC. Then you are going to do the shuttering works, the reinforcement work, the concreting of the footing, the column, beam, slab, and everything, whatever is the finishing activities, like the painting, the plastering, the painting, the woodwork, the interior work, everything will be executed by this contractor. And once that is done, finally is going to hand over that particular project to the client, that you are a client, he is going to give, and then you are going to make him the payment. Anyhow, this payment is not done at the end of a project. We'll have certain agreements with the contractor, that let us say after 20% of the work I'll be releasing the uh, money to you. Or let us say first floor, if the slab is casted, I'm going to give you money. In that way you'll be having a mutual agreement with the contractor. So in this way the entire project sequence is going to happen. Now the biggest question is that whatever you're studying in engineering in the college, where do you find the application of that? So if you are learning the AutoCAD, the Revit and all, the application comes in the architectural plan, right? So if you are very good at AutoCAD software, if you are very good at Revit software, then what you can do, you can prepare all this architectural plan. That is, you can prepare a plan something like this, what I was showing it here. So all these plans you can prepare with help of AutoCAD software. If you are very good at AutoCAD, you can prepare all these softwares and all, right? I mean, you can prepare all these plans and all. The second question is that where do you find the application of this analysis and designing? Whatever you study in engineering, like the subjects called strength of materials, structural analysis, RCC, reinforcement concrete, then steel structures, and whatever most of the subjects that we study in engineering, they find their application in this particular part, that is analysis and designing, especially in terms of ETAP software, StatPro software, safe. Because if I take you to the software, whatever we have studied in the engineering is the bending moment, the shear forces and all. Let me try to show one video. Let me try to run this. Yeah, okay, I'll try to run this. Yeah, you can see all these things we studied in the engineering days. That is a bending moment. At the support you get negative bending moment. You did something like fixed end moments, then you get a sagging moment here, that is a positive bending moment. Again you get a negative bending moment. These things we manually did in engineering. Whatever we did in our engineering, the same practical things we are seeing it here, how these things are applied in the practical projects. Similarly for the shear force, then everything we studied, those things comes in the designing and the analysis part. Right now again going back to the same thing. Now these things whatever we have, like the footing layout, the column layout here, whatever we studied, like the subjects like concrete technology, then building materials and constructions, right, geotechnical engineering, those subjects will find their applications once we start doing the execution of the work. That is, when we go to the executing of the work, we are going to, whatever in surveying, whatever we learned, everything will put that application when we start to work on the real projects, right? So that means, let us say, see, these are the construction methodology course that we are going to take up, right? So in this way, here we will be learning all these things. Whatever surveying you are learned, those things we are going to do it here. This is how the foundation marking is done, right? You can see it here. So these are the foundation marking, how we have to do it. Then similarly, this is how the excavations will be done. So excavations, how we are going to do all those things we studied in uh, quantity estimation classes. So whatever we are learning in quantity estimation classes, that applications will put it here. Similarly, we have a lot of things, PCCs and all, right? So this entire thing here in the construction methodology course, we'll be learning all these things, how these entire things are put up, how to understand this, the structural drawings, how the footing mesh is put up, how the column is kept, how the concreting is done, what is cover blocks, what are the importance of that, and how the concreting is done. These things we are going to find the applications in the entire course of construction methodology. And whatever we studied in the engineering, those things we find the applications once we start working. And here we find the applications of concrete technology and BMC subjects and all, right? Yeah. Yeah. So this was a complete sequence of construction project. I hope this is understood up to here. We'll see you back in the next lecture. Thank you. Hello, civil engineers. Welcome back to this lecture. In this lecture, we will understand the basics of civil engineering, like what is cement, what is concrete, what is RCC, and why we need to understand this. And once we understand this, our basics will be set, and then we are good enough to understand the sequence of the construction, right? So we'll start with what is cement all about. You might be knowing, but still, since we have taken this course, we are going to start from the very basics. Now you can see it's a cement here, right? So what is cement all about? See, cement is a binder which binds any two materials. If I ask you to bind any two material, right, if I give you some construction items, and if I ask you to bind any two material, the first thing that you're going to ask me is for the cement. So cement, it is a binder which binds the coarse aggregate and the fine aggregate, right? So coarse aggregate, in the local language we call it as a jelly or the stones, what you can call. and the fine aggregate is a sand, right? So the technical name for the sand is fine aggregate, but in local construction people call it as sand. But when we speak technically, we call it as a fine aggregate, right? So we understood what is cement. Next, we'll try to understand what is concrete. So what is concrete all about? So concrete, it is a mixture of a coarse aggregate, fine aggregate, cement, and you add water to that. That entire mixture, what you're going to get, right? So that is called as a concrete. You can see it here. So I've taken a cement here, I've taken a sand here, I've taken an aggregate here. I'm going to mix all these three ingredients. Then I'm going to pour in the water. That entire mixture, what is going to come, no, that is called as concrete. You can see it here as well. So I have a cement here, stone aggregate, then I have a sand, and I'm going to add water. That entire mixture, this is called as concrete, right? So this is how the concrete is formed. Now, next we'll try to understand what is RCC, right? RCC stands for reinforced cement concrete. So before understanding what is RCC, we need to understand why is that only we are not constructing the concrete structures. If you have observed it carefully, whenever you see any construction, you can see the rebar. Rebar in the sense, see, we call this as a steel, isn't it? So this is called a steel. Most of the construction, how we do, we put this kind of reinforcement, and then we are going to pour the concrete, right? In the same way, you can see it here. A lot of rebar, they have placed it here, and they have placed the concrete. Why is that only the concrete is not being placed, and why we are making use of steel? We'll try to understand that. See, everyone has certain good qualities and bad qualities in us, right? Like I have some good qualities and I have certain bad qualities. In the same way, you also have a certain good qualities in you where people appreciate that, and there are certain bad qualities in you where people don't like it. In the same way, this concrete what I have, right? So it has the same characteristic, like it has certain good qualities and bad qualities. So we'll try to concentrate on the good qualities always. So what is the good qualities of a concrete? So if I take, now let us consider this as a piece of my concrete. Okay, I've taken eraser just to make you understand. Imagine that this is a piece of a concrete, and I'm going to apply a load on this, right? So I'm going to apply a load on this. So this is my concrete, and I'm going to apply a point load on this. So the moment I apply a point load, you can see it here. Yeah. So I've written something here, right? What I have written, I have drawn one particular line here. Let me show it. So this particular line in the center, it is called as neutral axis. The same you can see it here. Like you can see this particular dotted line, what you can see here, right? So it's a neutral axis. And over the neutral axis, this is compression. And below the neutral axis, this is tension. You can see it here. If I try to, yeah. So you can see I've written C here and I've written T here. The line, this neutral axis, above this, we have certain thing called as compression, and we have certain thing called as tension. Now, one good property of a concrete is that it is strong in compression. That means if I take this concrete piece and if I try to apply load in this direction, see, this is compression for me, and if I pull something, it is called as tension. It's very simple. Now, if I take this as a piece of a concrete, and if I try to apply compressive load, I'm compressing it from both the side. Okay, so it is strong enough to take your load. It's not going to break. But the moment I try to pull it, no, the moment I try to pull, that means if I'm trying to reverse the load, if I try to apply the tension load, it's going to crack. So I'll put it in a better way. Imagine this as a piece of a concrete. Now, if I'm applying a compressive, I'm applying it, okay, nothing is happening, isn't it? It's not breaking. It's able to resist that force. The moment I reverse the force, if I try to pull the tension force, now see, I'm putting a tension force. What happened? Suddenly it got broke, right? Again, let me do it. Let us say this is a piece of a concrete. I'm pulling it now. It's a tensile force. See, it got broke, isn't it? So that means my concrete is strong in compression. One thing we learned from this, my concrete is strong in compression, but it is weak in tension, right? So practically when we put any structure, we get different kind of load coming on that. The load can be a compressive in nature. The load will be tension in nature. So if I use only concrete, my concrete will be strong in compression, but it is weak in tension. So put it in a better way. Now, like I mentioned, you just concentrate here. So if this is a piece of a beam, whenever we try to put a load on that particular structure, it may be any element, what will happen? The top portion will be in compression, the bottom will be in tension. So if it is in a compression, my concrete is strong, nothing is going to happen there. But the moment wherever there is a tension, and we saw it practically now, the concrete is very weak in tension, what will happen? You can see the cracks, isn't it? The cracks are going to come. So these cracks are going to come. So what will happen? There's a failure of your structure. So to put it in a very better way, see it here. Okay. So this is a piece of eraser what I've taken. I'll apply a load here. The one which I've shaded, isn't it? The upper part where I've done the shading. We can see this shade here. So this entire portion is in compression and this is in tension. Now you can see it here. No, look at the curve here. So here it has got compressed. This particular portion it has got compressed. Whereas you look in the bottom portion, it has got elongated, isn't it? That means there's a tension. And if I further increase the load, what will happen? Slowly the cracks are going to form in this direction. Here, the cracks are going to form. And once, what kind of cracks are these? They're tension cracks. And once the tension cracks generates, this particular eraser or this particular concrete is going to break. But as a civil engineer, I don't want that to happen. I'm not putting my structure to break it, right? So that is why I'm going to make a combination of something. So what is that? Now you might have heard of this rebar, isn't it? So this is called as steel, but usually technically we call this as rebar. That is, I'll write it here. Yeah, it's called as rebar. Rebar, that is called as reinforcement bar. Okay, so this particular rebar, no, it is strong in compression. If I try to put a compressive load, I'm putting, it's very strong, it's able to resist. But if I try to reverse the load, that is, if I try to put the tension load, I'm applying a tension. That means pulling is called as tension. I'm pulling, nothing is happening here. That means it is strong in compression and it is strong in tension as well. So I'll put my engineering things into this. That is, I'll make a combination now. I'll make use of concrete and I'll make use of steel also. And I'm going to make a combination out of this, which is called as RCC, which stands for reinforced cement concrete. So now I hope you have got an idea what exactly RCC is all about. Now to put it in a better way, so check it here. What is RCC? The process of embedding. That means embedding is inserting the reinforcing bar into the concrete. Let us say this is a concrete what I have. Just imagine, and I'm taking a rebar. I'm inserting into this. The process of embedding the reinforcing bar into the concrete to make it strong in tension. Usually we call it as RCC. Now what will happen? Now imagine a situation. You have both. That is, you have a concrete, you have a steel. The moment you apply the load, compression will be taken by the concrete. We know that the concrete is strong in compression. You can see it here. No, see, this is concrete is strong in compression. The moment the tension comes, concrete is very weak. Concrete will say, I cannot take that. Then steel will come like a hero. It will say, don't have to worry, I'll take the tension. So this combination is called as RCC. So that is why whenever we construct any RCC building, that is like a footing, column, beam, slab, you see this rebar, right? So these rebars are put to take care of the tension forces, and that is how the RCC structures are put up, right? So I hope you have got an idea up to here. Now I'll play a small video, uh, so you'll get an idea what exactly it's trying to do. The video may pause here and there. If that happens in this lecture, I'll upload in the next lecture I'll upload the same video. But as of now, just go through the video, and if there's a problem in the video, I'll upload a separate video in the next lecture. So before that, I'll explain what exactly is trying to do. First, we have taken a small beam. We are applying a load on that. So we know that it is strong in compression, but it is weak in tension. That particular beam is going to break. So immediately it's going to break. Next, in next experiment, for the same beam, he's going to insert this rebar, and then he's going to apply the load. Obviously, two things are going to happen. Since we added this, whatever load it was taking before, only with the concrete, it will take more load when you add the rebar, because here concrete is also taking the load, the steel is also taking the load. And second is that something, the failure pattern, how it's going to fail, that is also very important, and I'll explain what exactly is a failure pattern. Just concentrate on this lecture once. Yeah, so you can see it here, right? So this guy is preparing that. This is a kind of a beam what we prepare in the laboratories whenever we want to do the testing. And now he's applying a load on that. Now you just observe the way the cracks are developed. Now here only concrete is there. Now let me put it in a very better way. So I'll draw a neutral axis here. Now you know. So neutral axis will be somewhere here. So this is my neutral axis. Okay. And above this, what will happen? Above this, it is a compression, and below this is a tension. So where the cracks are supposed to happen? Yeah. Yeah. So this is tension, and this is compression. This is compression and this is tension. Now where the crack is supposed to happen? In this particular region. So in this particular region, your cracks are supposed to happen, and you can see it practically now when it's trying to apply the load. No, the cracks are going to appear there, and we'll try to see that. Yeah, so it's applying the load. Now you can see it's a compression. This is tension now. Okay, so tension, it will try to go apart, go away from each other, and compression will try to come closer. So you can't immediately, it got broke, right? So you can see the cracks. See, so this is how the crack is going to appear. So what happened there exactly? Let me put it in a very better way now. See, this was my the moment I tried to apply the load, no, sudden failure happened. It did not even give you warning that it's going to fail. Now I don't want that. So that particular failure is called as brittle. Brittle in the sense immediately it's going to fail. It's not going to give any warning. Now we'll make a combination. We'll make use of a concrete and the RCC. And now you see the failure pattern. Of course, it's going to fail. But the way it's going to fail is not an immediate failure. It's called as ductile failure. So check it here. So now you look into the failure of this. You can see the rebar, isn't it? See, here they have put a rebar here. So he has inserted that. Now this has become my RCC now. Now you can see a small crack has happened here, but it has not broken, isn't it? You can see the cracks forming here. So since it's a tension in region, crack will form. Okay. If you exceed the load, cracks are going to form. But look at the way the failure is happening. Immediately did not break. It is giving you kind of a warning. That is, I'm going to fail. Take care of me. That means reduce the load that is coming on that. Okay. So a small crack was formed, isn't it? So that is giving you a warning. And now if the failure happens, it is called as ductile in failure. Why we want ductile failure? Because let us say tomorrow you have constructed a building, and if there is a cracks and all, you get enough time to move out of the building. Now, if you compare that with your ductile, if you compare that with a brittle failure, now let us consider you have constructed only a concrete structure. You have not used a rebar into that. So the moment the load increases, let us say, if the failure happen, what will happen? It's going to fail suddenly. You don't even have a time to run out of the building. So it's a brittle failure. As a civil engineer, I don't want that. I want a ductile failure. So in ductile failure, what will happen? Cracks are going to form. Slightly the cracks are going to form. So when the cracks are going to form, you got an idea that maybe after a few days, or maybe in another 1 or 2 days, my building is going to fail. It's giving you a warning, so you can come out of the building, right? So that is the main idea of putting the structure. That is why most of the building we make it as ductile in nature, and this is how it has to be done. I mean, this is the main idea behind that. So he's comparing. See, this is the first failure is called as brittle failure, and the second failure is called as ductile. You see the ductile cracks are formed, but suddenly did not break. And now it's going to break, isn't it? So this is the main idea behind using RCC structure. And from here onwards, we are completely involved, or we are going to completely see the lectures in comparison to the RCC, right? So it's something like this. So if I try to pull, no, see something, let us say this is like rebar. If I try to pull, it's not failing. But what will happen here? Elongation is going to happen. That means it's going to stretch. Okay. And then it's going to fail. So the moment this cross section is going to come down, I'm getting a warning, and then I can take care of this, right? So I hope you have got an idea regarding what is cement, what is concrete, what is RCC, and what is the fundamentals behind all these things, something called as compression and tension. And now we have set up our base to understand this. And in the next lecture, we'll try to see the other parts of this. So I hope you have enjoyed the lecture. So we'll see you in the next lecture. Thank you. Hello, civil engineers. Welcome back to the lecture. In this lecture, we will see why is that we are using a steel and the concrete as a reinforcement only. Why is that only the steel is being used? Why don't we use any other material? And also in the previous lecture, if you are just concentrated on my lecture, I told you that cement is a binder, isn't it? But what exactly makes cement is a binder? That is the main question, right? There should be something in the cement. You can see the cement here. There should be something in the cement which actually makes it act like a binder. We'll try to understand that, right? So for that, there's a concrete technology course of mine on the same Udemy platform. If you are interested to learn all that thing, you can buy the course. So let me not get completely into that, but I'll give a certain, basic idea what exactly I want to tell about the binder. So see, when we prepare the cement, right? Because cement you have to manufacture. So when you prepare the cement, you have two ways. Either you can do with the help of a dry mixing or a wet mixing. So wet mixing, we don't use it. We usually make cement with the help of a dry method. So, and this is how that dry method is made and all. I'll not explain it here. It's already explained in one of my concrete technology course, but I'll give you an idea. Okay, this is how the dry method is done, and it is a modern and a widely used method. Whereas the wet mix, no, we don't use it anymore. And why we don't use it anymore? There are certain reasons behind that. Because the fuel consumption is more and all. So that is why we don't use the wet method. Now, when you prepare the cement, right, there are certain compounds which will come once the cement is manufactured. What I'm trying to tell is, see, so this is how the cement is manufactured. Once you manufacture the cement and you have a cement with you, in that cement, there are certain compounds which are called as box compound. So you can see it here, box I have written it here. So box was the person who identified these compounds. And which are those compounds? So it is one is C3S, the other is C2S, the other is C3A, then we have C4AF. What is this C3S? C3S stands for tricalcium silicate, C2S stands for dicalcium silicate, C3A stands for tricalcium aluminate, and C4AF stands for tetracalcium aluminoferrate. And these are the percentage, by how much percentage they are present in the cement. Like C3S, we have 30 to 50% in the cement. C2S, it occupies 20 to 45% in the cement. C3A, it occupies 8 to 12%. C4AF, it occupies 6 to 10%. So based on the types of a cement, like we have rapid hardening cement, we have slow setting cement, we have extra rapid hardening cement. So based on the cement, we try to proportionate this, right? So that is how we do. Again, all those things, it is explained there. Now, why did I come to this particular slide is that how that binding property will come. So this C3S and C2S, no, when they react with water, like I say, I have a cement here, right? Now I'm going to say I have water, I'm going to pour the water. So the moment I pour the water in this, so the hydration is going to happen. That means there's a chemical action happening between the cement particles and the water. So because of that, what will happen? Because of that, this C3S and C2S compound, no, they'll react with water. So I'll show you what exactly I want to tell. Yeah. Yeah. So this C3S, it's called tricalcium silicate, right? So the C3S, you can see it here, it will react with water and it's going to form CSH gel. So this CSH gel is called as tobermarite gel. Okay. And this gel itself will act as a binder. So that is why I told cement is a binder. So who is actually responsible? This particular compound called as C3S, when it reacts with water, it will form CSH gel, and that CSH gel will have that binding property in it. So because of that reason, no, we call cement as a binder. That's C3S. And in the same way, there's one more compound which is called as C2S, that is dicalcium silicate. Even the dicalcium silicate will react with water. Again, the CSH gel is formed. So because of this reason, we get that binding action, right? So again, there's a lot of things you need to understand. I've given a small overview, but exactly how is that the word binder is all about. So because of this tobermarite gel, no, so we'll go back to that. So this is a tobermarite gel, and because of that gel, the binding action is formed. Again, there are many things that you need to understand, which we are not going to take up in this particular course. You can learn from there, right? So we'll go back to the main agenda again. Now again, so I hope that is why I used the word, it is a binder here. And why is that binder? Because of C3S and C2S, which will give the binding action to the cement. And that is why it can hold any material. When you put cement, coarse aggregate, fine aggregate, you're going to get that hard mass, and that binding action is because of this particular C3S and C2S. Yeah. Now we'll go to the most interesting part. Now I took rebar, isn't it? Directly I showed you rebar. Why is that? Well, we are using only steel. Why not the other components? I mean, why not the other materials, like we have bronze, we have gold, we have silver and all? Why don't we use those materials, and why we go with only steel? So we'll try to see the reason behind that. So there's something called coefficient of thermal expansion of steel and concrete is almost same and nearby values. What is trying to tell? Suppose, let me consider, Let me consider this as my concrete. Okay, let me consider this as my concrete. Now the room temperature is 27 degrees Celsius for me. Let us say I'm going to increase the temperature. Instead of 27 degrees Celsius, I'll make the temperature of this room to 35 degrees Celsius. Since there's a change in the temperature, this particular concrete is going to expand. So initially it was of this length. Okay, you can see the length. Initially this is of this much length. Let us say due to increase in the temperature, even the materials are going to expand. So here what will happen? Let us say this is going to expand by 5 mm. So if you don't understand in mm, we'll speak in terms of centimeter. Let us say it's going to increase by 50 centimeter when I'm increasing the temperature. In the same way, right now the room temperature is 27 degrees Celsius. Let us say I'm completely cooling down my room and I'll bring the temperature somewhere close to 18 or let us say 15 degrees Celsius. Since there is decrease in the temperature, this particular concrete it's going to shrink. So originally this was the length. Now due to the shrinkage, let us say it has got shrink by let us say 20 centimeter. So what is happening? If I'm increasing the temperature, it is increasing, that is there's an elongation, and if there is a decrease in the temperature, it is going to shrink. So this is how the concrete is going to behave. In the same way, if I take a steel, even now let us say I'm increasing temperature again. Now again the steel is also, if I increase the temperature from 27 degrees Celsius to let us say 35 degrees Celsius, like I did it for the concrete, even the steel is going to expand. Let us say even the steel is also going to expand by let us say 45 to 46 centimeter. Concrete was expanding by 50 centimeter. Let us say this is expanding by 45 centimeter. In the same way, if I decrease the temperature of the room and if I bring it down to 15 to let us say 18 degrees Celsius from 27 degrees Celsius, even this is going to shrink, and let us say it will shrink by let us say some 20 centimeter or let us say 25 centimeter. Concrete was shrinking by 20 centimeter, whereas steel is going to shrink by 20 centimeter. Concrete is 25, this is 20, right? So both the materials are going to expand and shrink. Now what will happen if you make a combination of this both? That is, a concrete is one material, steel is other material. Now if there is an increase in the temperature, what will happen? Concrete is going to shrink. Sorry, if there is increase in the temperature, concrete is going to increase, elongation is going to happen. Even in the steel is elongation is going to happen. So in between them, what will happen? That proper bonding will not be there. But one advantage what we have is there's something called coefficient of thermal expansion. So that means if you look here, the steel, it has got 1.1 into 10 to the power of minus 5, whereas concrete has got 1.2 into 10 to the power of minus 5. So the coefficient of thermal expansion between the steel and the concrete is almost same. So that means even there is increase in the temperature, concrete and steel both will be held together and there is no much variation between them. Let us say my concrete got expanded by 50 centimeter. This steel will get expanded by 45 centimeter. There's no huge difference. Like concrete will not, concrete let us say got expanded by 50 centimeter, and if steel get expanded by 20 centimeter, there's a huge difference between 20 to 50. But 45 to 50 is not a huge variation, right? So there's a, even though there is an increase in the temperature, the bonding is good. In the same way, when there's a decrease in the temperature, concrete got shrink by 25 centimeter, whereas steel got shrink by 20 centimeter. That difference what we have from 25 to 20, it's not a huge difference. So again, even though there's a decrease in the temperature, there will be a good bonding between them. That is the reason we go with the concrete and steel as a RCC member and not with other material. In other material, what will happen? Let us consider, I'm taking gold for example. So in gold, what will happen? Maybe the, like I mentioned, concrete got expanded by 50 centimeter. Maybe gold will get elongated by only 10 centimeter. From 50 to 10, there's a huge difference, right? In the same way, if there is a decrease in the temperature, my concrete got shrink by 25 centimeter, whereas gold will get shrink only by let us say 2 centimeter. Again, from 25 to 2, there's a huge variation. Then what will happen if you make gold and concrete has a reinforcement? Let us consider. Of course, it's quite costly. Let us consider. Then what will happen? There won't be a good bonding between them. The moment you increase the temperature, concrete will try to go this way. It want to expand by 25 centimeter, whereas this gold will not allow because it will expand only by let us say 5 centimeter. So again, what will happen? There won't be a good bonding. So as a result of that, there's a cracks and all. So that is why I don't want that to happen. That is why most of the RCC structure we use steel as an reinforcement and not the any other material. What is the main reason behind that? There's something called coefficient of thermal expansion. You see here 1.1 and 1.2, there's no much huge variation, right? So that is why that's the main idea behind that. There's a one reason. Second is concrete is weak in tension, we know that, and it is strong in compression. Whereas steel, it is strong in compression tension, both it is strong. Whereas concrete, it is weak in tension, but it is strong in compression. Again, this is the second reason we make a combination, because concrete cannot take tension. It will give up. It cannot take tension. So somebody has to come and save the concrete. So steel will come like a hero, and that is how their bonding is going to happen. So one will take concrete, the concrete will take the compression, and the steel is going to take the tension. Of course, steel will take your compression, but that is not what it is meant for. The concrete will take care of that. That's the second reason. Third, the bond between the concrete and the steel becomes strong due to the ribs present on the rebar. That means if you look to the rebar, if you look into the rebar, you can see a small ribs here, right? See, it's a kind of a ribs here. So this ribs, since it is rough in surface, and concrete, once it start to get coated on the surface of a rebar, there's a good bonding between them, and it's very difficult for you to pull it out because of the ribs present here. So that is the third reason why there is a good bond between the concrete and the steel. The next is the steel being ductile in nature makes it a perfect combination with the concrete, and hence steel is widely used material along with the concrete. Again, we know that this steel is very ductile in nature, isn't it? So moment if you pull, it will break, but it's going to elongate, and you're going to get that warning. So again, that is another reason why we take steel and the concrete as a combination, right? So all these were the fundamentals where we wanted to know what is the reason behind all these things, and why we should make use of steel and concrete as a reinforcement, or why do we use them as a RCC member, right? So in the next lecture, we'll try to understand what are the different types of cement, different diameters of the rebar, and all those things in the next lecture. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. In this lecture, we will see what are the different grades of concrete, and also we'll try to see what are the different grades of cement we have, and we'll try to see what are different diameters of the rebar that is available in the market, which will set all the basics for us, which is required to continue with the course. Now, coming to this, the basics of civil engineering, we'll see what are the different grades of concrete. We understood what is concrete. Now we'll try to see what are the different grades of concrete. So before that, now let us say there's some 60 kg of a load which is kept in front of me. And if you ask me to pick it up, I can easily pick it up. So that is my capacity. So you may pick up like 70 or 80 or 90 kg of the load based on your capacity. There may be few other people who can pick max to max 40 kg of the load. Above 40, if you ask them to pick, it's quite difficult for them. So that is their capacity. In the same way, when we put any structure, concrete structure, it will have certain capacity, and it depends on the grade of a concrete, what exactly grade you're preparing. So we'll try to see that. So we have M7.5 grade of a concrete. Forget about this number, that is 1:4:8. We'll come back to that later. Then we have M10 grade of a concrete. We have even forget this thing. We have M15 grade of concrete. We have M20 grade of concrete. We have M25 grade of concrete. Beyond M25, we have like M30, M35, M40, we have grades up to M100. But usually in the most of the construction practices, we usually start with M20 grade of concrete, normal structure. Again, depends on the conditions. You can make use of M25, M30, 35, 40 based on the requirements. We'll not try to get into that. Just understand we have grade up to M100 also. Okay. Yeah. Now, first we'll understand what is this letter M indicates. And we'll try to say what is this number 7.5, 10, 15 indicates. Let me write it here. So the letter M indicates mix, whereas the number like 7.5, number like 10, 15, and 20 and 25, they indicates the characteristic compressive strength of the concrete. Just remember that. It's quite a big sentence, but that's how you have to remember. Characteristic compressive strength of the concrete, right? So this much is understood. Now we'll try to see what is this number 148 indicate. What is this number 136 indicates? Now first always remember the first number what is shown here, no, that is 1, 1, 1, 1 and 1. They represent cement. The second number like 4, 3, 2, 1.5 and 1. They indicate the amount of sand, that is a fine aggregate. And the last number like 8, 6, 4, 3 and 2, they indicate the amount of coarse aggregate. Now let us say I told what is concrete. It's a mixture of coarse aggregate, fine aggregate, cement, add water to that, your concrete is ready. Now if I tell you prepare a M20 grade of concrete, then how you are going to prepare it? Of course you'll use cement, sand and coarse aggregate, but how much proportion you need to mix, that you don't know. So that is what it's indicating. If you want to prepare M20 grade of a concrete, you have to mix your proportions. You have to proportions the ingredients like coarse aggregate, fine aggregate and cement in the ratio of 1 is to 1.5 is to 3. So how exactly you're going to do? Just concentrate here. What exactly this, what do you mean by this? Now if I put it in a very simple way, he has taken a cement here and it is on a shovel. Shovel is a tool where we have taken a cement. So how many shovel you can see? One. So can I write one part of shovel was taken here? I'll write it here, one. Okay, done. Next, look here, how much sand is taken? 1 and 2. So 2 parts of sand was taken. I'll write it here as 2. Now look here, look at the aggregate, 1, 2 and 3. That means 3 parts of coarse aggregate was taken. I'll write it here, 1 is to 2 is to 3. So this is how we have to do. Okay, I hope this much things are clear. Yeah, now let me erase everything. I hope your fundamentals are clear up to here, right? Yeah. So now the question is that why there are so much grades of concrete? Why is that we couldn't have kept only one grade of concrete? Let us say M15 done. Why is that we have 15, 20, 25 and all? So based, like I mentioned, based on the requirement of your structure, we have taken different grades of concrete, but just concentrate here, the M7.5, M10 and M15. We call this particular concrete as lean mix, or usually we use them in the PCC. Now what is PCC? PCC stands for plain cement concrete. We'll try to understand this in the due course of a time, what exactly PCC is. As of now, try to understand PCC stands for plain cement concrete. So whenever you want to do some inferior quality of a work, that means normally if you want to put some bed concrete and all, in that case we can go with this grade of concrete like M7.5, 10 or M15. But when you put RCC structures, like you're putting a concreting for the footing, for the column you're doing, for the beams you're doing, for the slabs you're doing, retaining wall or water tank, whatever may be, in that case our IS code book says that is Indian standard 456 2000 code book says that minimum you have to use M20 grade of concrete, right? So if somebody asks you what is a minimum grade that you're supposed to use in a structure, it has to be M20. That is a minimum. You can use M25, 30, 35 based on the requirement of your structure, but M20 has to be the minimum grade. Okay, so that is why we are bifurcating all these different grades of the concrete. Yeah, so this M20, M25, we call this as a rich mix. This is called as lean mix and this is called as rich mix. Why it is called as rich mix and why this is called as lean mix? If you observe it carefully, in the M7.5, you can see 1 is to 4 is to 8. That means 1 part of cement, 4 part of sand and 8 part of coarse aggregate. That means the coarse aggregate content is more because it's 8 part, right? When I say 1 is to 4 is to 8, I'll take 1 part of cement, done. And it is 4 mentioned here. I'll take 1, 2, 3 and 4 parts of sand, and it's written 8 parts. So I'll take 8 parts, 1, 2, 3, 4, 5, 6, 7, 8, 8 parts of coarse aggregate. So here the amount of coarse aggregate is more. So hence this particular mix will become lean mix. Lean in the sense the cement quantity is very less than, but whereas the coarse aggregate quantity is more. So it becomes a lean. Lean is a very rough mix. But if you observe to M25, if you come to M20 and M25, see here, it is 1 is to 1.5 is to 3. That is 1 part of cement, 1.5, that is 1 part I'll put sand, then another half I'm going to take 1.5 and 3 parts. So 1, 2 and 3 part of coarse aggregate. Now in comparison to M7.5, this is a bit richer mix because here the coarse aggregate content is like here it was 8 parts, here it is only 3 parts. But if you come to M25, this you see here it is 1 is to 8, 1 part of cement, 1 part of sand and 2 parts of coarse aggregate. So it's a richer mix. So that is a difference. So that is why we have written it as lean mix and richer mix. Here your cement quantity will be more, right? So there will be a good binding. Whereas here your cement quantity will be very less because since you're putting a lot of coarse aggregate, all the coarse aggregate, there will be a lot of voids. Voids in the sense in between two aggregate, there will be voids, and all the voids will be filled by this cement paste. So you will not have any cement paste to lubricate. That means there is no more amount of cement paste. Whereas here, since your aggregate quantity itself is less, the voids will be less. If voids are less, then less amount of cement paste will go in filling the voids. If less amount of cement paste goes in filling the voids, more amount of cement paste will be there for the lubricating, right? So that is why this is called as a rich mix and this is called as lean mix, right? I hope up to here your fundamentals are clear. Next, we'll go to grades of cement. Now coming to the grades of cement, now we were discussing grades of concrete. Coming to the grades of cement, we have OPC 33 grade cement, we have OPC 43 grade of cement, and we have OPC 53 grade of cement. What is this OPC? So OPC stand for ordinary, OPC. Yeah. So it is called ordinary Portland cement. So the word Portland is a place where the color of that stone was first observed. So hence we are given the name as Portland. So it's a cement. We have kept the name as ordinary Portland cement. Okay. Now what does this 33, 43 and 53 indicates? In the same way, I didn't explain you what is this 7.5, 10, 15. How do you measure that 7.5, 10, 15, 20, and how do you measure this 33, 43 and 53? So for both of this, the answer remains the same. This is a concrete. So what we do usually, all these things are explained in my concrete technology course in a more detailed way. I've explained you. Here is quite difficult for me to explain each and everything. So that is why whatever is important pertaining to this particular lecture, I'm explaining you, right? So we'll understand what is this 7.5, 10, 15, how do you get that number? So usually, whenever we want to prepare a concrete, first I'll speak for the concrete. We have certain cubes. So this is called as a cube for me. Now let us say I want to prepare M20 grade of concrete. So we know that for M20 grade of concrete, we know for M20 grade of concrete, what is the ratio? It is 1 is to 1.5 is to 3. That means I need 1 part of cement, 1.5 part of sand, and 3 parts of coarse aggregate. I'll take that much part. I'll add water to that, and I'll prepare the concrete. And once I prepare the concrete, I fill that concrete in this particular mold. So in this particular mold, I'm going to fill that particular concrete. After that, next day, that is now, right now it is 3:30 p.m. Tomorrow 3:30 p.m. in the evening, I'll demold it. Demold in the sense I'll remove this mold, so that what will happen? You'll get this particular cube. We'll get a cube something like this. Then I'm going to place this particular cube in the water. That is called as curing, right? I'm going to do the curing of my cube mold for 28 days. Now, one question that may come in your mind. So why is that why you are doing it for 28 days? Because it has been found through experience. It has been found through research. The concrete is going to gain that complete strength. What is that complete strength? This M20 means it has to gain 20 Newton per mm square strength. So this 20 Newton per mm square strength will be gained only at the end of 28 days. So that is why we are supposed to do the curing till 28 days. Curing in the sense, you will take this cube. I'll show it here. You're going to place it in the water tank. So this is a water tank. You're going to place it in this water tank for 28 days. And after 28 days, you're taking the cube out. And then we are going to load that into this compressive testing machine. You can see your cube here. And this is my compressive testing machine. And in this compressive testing machine, I'll apply the load on that. I'll apply the load on that. And at one particular load, this cube is going to fail. So once it fails, this is how the failure pattern will happen. You can see it has failed here, right? So when that failure happens, this is called as dial gauge. So this dial gauge will show you certain reading. That particular reading is a load at which this particular cube has failed. So now from simple mathematics, that is, we know that stress is equal to force upon area. I'll write it here. Stress is equal to force. So force, or I can say load upon, let me write in this way. Yeah, force upon area. Okay, so I know I want to find the stress, that is 20 Newton per mm square. Newton per mm square is a stress actually. Okay, that's a unit of a stress. So force I will come to know through this dial gauge. Area, how do you find? It's again very simple, because I know the size of my specimen is 150 mm by 150 mm by 150. Can I not find the area from here? If I multiply 150 into 150, 150 is my length and 150 is my breadth. If I multiply 150 by 150, it will come out to 22,500, I guess. Yeah. Okay. So I got the area. So multiply the force, multiply by the, take the force and divide it by the area, you'll get the stress. So in this way, we have to prepare 3 specimens, because with the help of 1 specimen, it's quite difficult to come to a conclusion, because concrete is not a homogeneous mixture. It is a heterogeneous mixture. Heterogeneous means it is made up of cement, it is made up of coarse aggregate, it is made up of sand. We are adding a water to that. So all these are the different materials. So with one particular testing, I cannot come to a conclusion and say this is the strength of this. So I'm taking an average of that. To take an average of that, I'll take 1, 2, and 3. I'll take 3 different specimens. For the same mix, I'll prepare 3 such specimens. Okay, and then I'll do a testing on all the 3 specimens, and I'll find the average value of that. and that average value what you are getting, it's called as characteristic compressive strength. And if I'm preparing it for M20 grade of concrete, I need to get the strength greater than 20 Newton per mm square at the end of 28 days. That is why I've written it as 7.5, 10, 15, 20, 25, 30, and so on, right? I hope you got an idea. Now, the same test we are going to do for the cement also. Right now, I was speaking for the concrete. Even in the cement, I told you about 33 grade and all, right? So if you just observe it here, it is written 33, 43, and 53. How do you get this? Again, whatever procedure I explained you, same thing you have to do. Only the two changes are going to happen. So there, your size of a specimen is different. Here you have to make use of specimen which is having a size of 7.07 by 7.07 centimeter by 7.07 by 7.07 by 7.07. Okay, this is the size. So you can see three here, right? Three sample, you'll fill it once here, second here, three here. So you'll take three specimen. And again, same testing you have to do, provided here you are making use of only the cement and the sand because you're doing the test on the cement. So we'll make use of only cement and sand in case of testing for the cement. If you're doing for the cube, that is for the concrete, then you have to make use of cement, sand, and aggregate. Of course, water we need to add. That is how it has to be done, right? So I hope you got an idea up to here. Yeah, right. So for that, I'll give you a small understanding how it has to be done. You can see it here, no, 7.06 mm by 7.06 centimeter by 7. It is centimeter. Okay, 7.06 by 7.06 by 7.06. That comes out to be 70.7 mm, 70.7 mm, and 70.7. This is 70, 70.7, and this is also 70.7 for the cement. Then you can see compressive strength of the concrete will be the maximum load divided by the top surface area. Top surface area we get it from here, and then we have to follow this procedure. You can see it here, no? See, he has taken, since I mentioned you that we have to take three sample. You can see this is first sample, this is second sample, this is third sample, and this is a compressive strength that is 37.04, 35.04, 38, and I've taken an average of this. Average I got 36.70. So in this way we have to do, and finally whatever answer you get, it should be more, right? If I'm doing for M25, how much ton should I get at the end of 20 days? I should get more than 25. It can be 26, it can be 27, it can be 28. We don't have issue with that, but it should not fall less than 25. If it is falling less than 25, that means the proportion what you added is not correct, or maybe you're not done proper curing. All these are the different reasons. But always remember, at the end of 28 days, I need to get a strength greater than the grade of that particular concrete, right? That is how you have to do this cube testing and all, right? So I hope you got an idea up to here. It's explained in my course in a more depth, but still I have tried my level best to explain it here. So because that is how our basics are going to, work for us in the upcoming lectures. Yeah, so this is clear up to here. Next we'll come to this part. Yeah, next we'll understand the different diameters of the rebar, right? Different grades of rebar. This was a rebar. For concrete, we had like M7.5, M10, M15, M20, 25. In the same way, this rebar, what you get in the market, no? Even this also has certain grades in that. So first is Fe250, where the letter Fe denotes that it is made up of iron. I'll write it here. Fe indicates it is made up of iron. Okay, so that is why it's written Fe. Okay, yeah. Then we have Fe415. Then we have Fe500. Then we have Fe550. We have Fe550D as well. We have where the letter D indicates a ductile. I'll come to this word ductile a bit later. Then we have Fe600 and we have Fe600D as well. We understood what is this Fe. It stands for iron. Now what is this 250, 415, 500, 550, 600 and all? So it indicates the minimum yield strength of the rebar in Newton per mm square. The number like 250, 415, 500, 550, 600, it indicates the minimum yield strength of the rebar. That means if I take this rebar and if I try to pull it, how much load this particular rebar can take Newton per mm square, that is the capacity of this rebar. If I say I want to make use of Fe500, 550 grade of steel, it can take 550 Newton per mm square of the tensile load which comes on this. Okay, so because why I'm saying the word tensile, because we know this is very strong intention. That is why we are making use of this, right? So that is why the number indicates the tensile strength, that is the minimum yield strength of the rebar. Okay. Now practically, if you have seen it in the market, or if you have seen in any construction site, this number what I have written, 250, 415, 500, it will be written here. You can see 500 is written here. You see 500D. D is called as ductile and ductile, right? Up to here our things are clear. Two things we did not understand. Why is this D written here? Usually when we do the earthquake resistant structure, that means if you're constructing your house or buildings in the earthquake zone, the code says that, which is that code? The Indian standard IS 13920 2016 is a code book what we have. This code book says that you have to make use of those bar where D is written. So this is called as ductile. So when earthquake comes, I want my building, to vibrate in the sense I want my building to be ductile in nature. It has to, what you call sway in this way, but there should not be a sudden collapse to that. So this way in my building will happen. Why is that? If earthquake comes, right, I don't want my building to suddenly collapse. It has to, sway in this way and then come to its original position when the intensity of the earthquake is going to come down. So this can happen only when we make use of this bar like ductile in nature. So these bars will have enough ductility in that. Even if you pull, no, they'll have enough ductility in that. So that is why the code says that. So now most of the people make use of this D only. Even if you go and ask in the market, give us FE 500 bar, they'll directly give you FE 500D only, and there's no much variation in the price. Okay. And it is so. But main intention of using this D bar is wherever there's an earthquake zone, it will be mentioned. Otherwise, you can make use of FE 500. There is no issue with that, right? These things got clear, and we also understood FE 500, 550, 4 and 5. Another thing, right now in the market, at least in the Indian market, we don't have FE 250 bar available in the market. We don't even have FE 4 and 5 available in the market. Whatever is available in the market, we have FE 500, 550, 550, 600, 650. I don't know about 650. We have up to 600. 250 and 415 is not available because the minimum yield strength what we are getting, it is very less for us. So we usually get a 500 Newton per mm square is a minimum yield strength of the bar. So if you go to the market, usually you get a 500 written on that. This 4 and 5 and 250 we don't get it in the market, right? So this was all about the different grades of rebar and different grades of concrete. Now we'll try to understand one more part, right? Like I mentioned, it's written here 4 and 5, 500, 550 and so on. Now see, these are the different bar what is available in the market. Okay, we now coming to the main point. What are the different diameters of the bar? So I've taken a bar here, it has got certain diameter. Okay, so this is the diameter of that. So we have different diameters of the bar. We have 8 mm bar, we have 10 mm bar, we have 16 mm bar, we have 12 mm bar, we have 16, we have 20, 25, 32, even 36 is also available. So most of the construction we start from 8 to 25. 32, 36 diameter bar we usually use in the construction of the heavy structures like bridges, the tunnels, the metro construction and all, right? So these are the different diameters of the bar, and on the diameter of the bar, on the bar, all these things will be written. TMT is thermomechanically treated. It's a treatment what you give to the bar. And 550 to 550, 600, 4 and 5 are the different grades of the bar. And another thing is that whatever bar is available in the market, the entire length of one particular bar is 12 meter or 40 feet. That means what I'm trying to tell is, you can see this bar, isn't it? This is the entire length of one bar. Okay, so this entire length of one bar is how much? It is 12 meter. This is 12 meter or 40 feet. How did you get this 40 feet? It's very simple. See, all this conversion as a civil engineer you should know. We know that 1 meter is equal to 3.28 feet. So how much is my meter? It is 12 meter. So 12 multiplied by 3.28. Try to do it manually. You'll get answer somewhere close to 39 point something. So I've taken it as 40 feet here. You should be knowing both the things from here. Yeah. Now, why is that it is only 12 meter? Why it is not 13 meter? So usually most of the time when these bars were manufactured, this is how the bar will be manufactured. If you see if you have gone to any of the place where this hardware shop where these bars are available, they're going to keep the bar somewhere like this. These bars will be kept in this way. You can see it in this way. They are going to bend. Okay. This is how the bar will be available in the market. This is the shape. Okay, they are going to give a small curve to that, and this is how it will be kept. And also, how do you carry this bar? These bars we usually carry with help of a truck. Now if I try to draw a truck here, okay, let me draw a small truck here. Yeah, so this is a small truck what I have drawn. Okay, so this truck what was available back those days, the length of the truck was like 6 meters. This is the capacity, this length was 6 meters. This was only 6 meters. Okay, but the bar available is 12 meters. That is why we bend the bar and we keep it in this way. That is why we are restricted the length to the 12 meter. That is the one reason. So that is why you can get in the market a 12-meter bar. Okay, 12 meter. If somebody asks you in terms of feet, you can say 40 feet. Yeah. So, and now coming to the different diameters and how do you find the area of the bar? See, we, like I mentioned, we have 8 mm, 10, 12, 16, 20, 25, 28 diameter of the bar is also available. But usually in the normal construction, we don't use it. Then we have 32, 36 and 40 diameters of the bar. How do you find the area of one single bar? We know this bar, it is circular in shape. So we know that from the mathematics, area of circle is pi by 4 into d square. So pi divide by 4 into d square. In place of d, you put 8 mm here. So you do it manually, you'll get 50, somewhere close to 49. I have taken 50. In the same way, for the 10, how do you find pi? Pi is 3.142. I'll write it here. So this pi is 3.142. You divide this by 4. Whatever answer you get, no? So that answer, I'll write here, answer, you multiply that by d square. D in the sense, whatever diameter you want to find. If I want to find it for 10 mm, for 10 diameter bar, multiply this by d square. So 10 into 10. Suppose, okay, 10 into 10. Suppose if you want to do it for 12, 16, same procedure you have to adopt, and whatever answers I've written it here, the same answers you're going to get it here. Now coming to find the weight of the bar. Weight of the bar means, let us consider this is 1 meter. Yeah, let us consider from here to here, this is 1 meter. So if I weigh, and this is let me see what diameter of the bar is this. Yeah, this is 8 mm bar. Okay, all these things will be written here. Okay, if you can see, it will be written here. It's written 550 and it is written 8 mm bar. Yeah, now you can see it. See, it is 8 mm and it is 550. So let us say this length from here to here, it is 1 meter. And if I weigh this 8 mm bar of 1 meter length on a weighing machine, it's going to weight how much? It's going to weight 0.39 kg. Okay, 0.39 kg. Suppose if I take a 10 mm bar of 1 meter length, it's going to weight 0.615 kg. If I take a 12 mm bar of 1 meter length, it will weight 0.88 kg. So in this way, all these are the weight of my bar. How do you find it? The simple formula what you can apply is d square by 162.5. So it's a very raw formula. What is that? It's d square. I'll write here d square divided by 162.5. That means if I want to find the area of a 8 mm bar, if I want to find the area of 8 mm bar, how do I do it? 8 square. 8 square is 64. That is 8 into 8 is 64. And 64 you divide it by 162.5. You're going to get 0.39. So this is kg per meter. Per meter, this much is a weight. Now, what is the total length of your bar? It's a 12-meter bar. So 12 meter is a total length, 12 meter total length. So if I want to find the weight of a total 12-meter bar of 8 mm diameter, what is the total weight I'm going to get? Very simple, 0.39. You multiply this by 12, and if you do it, you're going to get the answer. Let me do it. 0.39 into 12. So 4.68. So 4.68 is kg, right? So if you take a 12-meter bar of 8 mm dia, and if you weigh it on the weighing machine, you're going to get 4.68 kg is the weight of that particular 12-meter 8 mm bar. So now why I'm trying to explain you all these things, why it is needed? Tomorrow, if you're working as a site engineer, you need to do bar bending schedule. Anyhow, I'll try to explain what exactly bar bending schedule is when I explain in the footing calculations. There you should be knowing how much steel you require on that particular footing, how much steel you require, because we require a steel for the construction, right? It's not that the moment you're doing it here, you will place the order for the steel. That cannot happen. You need to do all these calculations, and previously, even before the start of the project, you have to get all this rebar steel in your site. So that is why that is the place where all these things comes into play. So that is why I explained in the beginning of the course. So later when I try to explain you all those bar bending schedule, so it will be easy for you to understand, right? So I hope you understood the concepts up to here. We'll see you back in the next lecture. Thank you. Hello students, welcome back to this lecture. In this lecture we will see what is the difference between a nominal mix and also what do you mean by a design mix. So before we understand that, in the previous lecture, I told you that there are different grades of concrete, right? And also told you that M20 is a minimum grade of a concrete that we are supposed to use. So we'll try to see where exactly it is written in the Indian Standard Codebook, and we'll try to understand that. So if I go to this codebook of Indian Standard, and I'll show you here where it is exactly written. Yeah. So if you go to the table number 5, it's written page 20, and it is IS 456-2000. So it is written here. One is plain concrete, which is usually plain PCC, what we call plain cement concrete. The other one, what we have is a RCC, which is called as reinforced concrete. Now here you can see something written. It is an exposure condition, whether it is a mild exposure, moderate exposure, severe, very severe, or extreme conditions. So we'll try to understand what exactly this severe, what exactly these conditions are. But now you see here under the mild condition, if I go to the reinforced concrete, and if I check here, if I go to the mild, and under the mild, if I go to the minimum grade of concrete, so this is my minimum grade. So this is my minimum grade, right? So what you can see here, M20 is written. So this M20, what it is written for the mild exposure. So according to IS 456, M20 is a minimum grade of concrete that we are supposed to use in the RCC structure. That's the first thing we understood from here, right? And also it will indicate us, suppose if you're preparing a mild exposure and if you're preparing a M20 grade of concrete, what has to be the minimum cement content? So it has to be minimum 300 kg per cubic meter, and maximum water cement ratio what you can maintain is 0.55. Suppose if you're using M25 grade of concrete, the minimum cement content should be 300 kg per cubic meter, and the maximum water cement ratio what you can allow is 0.5. We'll try to see what exactly this water cement ratio and all, how it's going to help us, but try to understand all these things will be given in this particular table, right? So this thing is clear. Now we'll go back to this about the exposure condition. Yeah, now coming to the exposure condition, what exactly this exposure condition are? Let me put it in a very simple way. Let us say I'm constructing a house which is somewhere close to the coastal region. Since my house is very close to the coastal region, it is most of the time subjected to the sea waves, and the temperature will be very hot there, right? So that exposure is my building. What will happen? It is subjected to this sea waves. So the exposure condition is different there, right? Now let us consider I'm constructing a house somewhere where out of 1 year, that is out of 12 months, let us say 7 to 8 months is going to rain, and it is going to rain heavily. So in that case, what will happen? 8 months, my entire building will be subjected to the rain. That means there is a frequent wetting of my building. Again, that exposure condition is different, right? Now let us consider I'm constructing a bridge, and if there is a pier, right? Pier in the sense the middle part is called as pier, the ends are called as abutments. Now, since you're constructing a pier, it is in contact with the water. If I have a pier here, it's contact in the water. So throughout the lifetime of this particular bridge, this particular pier is going to be in contact with the water. So that means the exposure condition is different because all the time it is contact with water. So it's a different exposure condition. Now, based on the exposure condition, we are going to decide whether it is mild, moderate, severe, very severe, or extreme condition, right? Now, if you're putting up a nuclear power plant, or if you're putting an underground water tank, in that case, again, that water tank is constantly in contact with the water. There the exposure condition is different, right? I hope you got an idea what exactly this exposure condition is. Now to speak in terms of technical, they have written it here, environment, you can see it here, environmental exposure condition, and it is clause 8.2.2.1 and 35.3.2. So it is written mild, moderate, severe, very severe, and extreme condition. So what are these exposure conditions? If you're going for a severe, in that case, your concrete surfaces exposed to the severe rain, alternate wetting and drying, or occasional freezing, or severe condensation, and concrete completely immersed in the seawater, and concrete exposed to the coastal environment, right? In that case, your condition is a severe condition. And if this is a severe condition you're building, then you have to come here, and under the severe condition, what your code says, what should be the minimum grade under the severe condition. So this is my severe condition. And under the severe condition, what is the minimum grade of concrete I'm supposed to use? I'm supposed to use M30 grade of concrete. So I'm going to say I'm going to use M30 grade of concrete, right? From here, we are going to identify what grade of concrete we are supposed to use. But usually most of the construction in a normal area and all, if you're constructing a small house and all, mild and moderate condition is that which usually prevails, like M20 and M25 grade of concrete. But again, the code says that if you're putting up your structure in the coastal region, you can see it here. Just observe in this part. Yeah, concrete in seawater. Concrete in seawater or exposed directly along the sea coast shall be at least M20 grade in case of PCC, that is plain concrete, and M30 in case of reinforced concrete. That means if you're putting up a RCC structure near the coastal region, the code says that you have to use M30 grade of concrete if it is a coastal region. Otherwise, all the normal building has to be M20. Again, the code says all these things. So based on it, we are going to decide which grade we are supposed to use, right? I hope these concepts are clear for you. Now, one thing might have come in your mind, that I told for M7.5, M10, M15, M20, M25, we have those ratios like proportions, 1:1.5:3, or 1:2:4. But if I say M30 grade of concrete, if I say M30 grade of concrete, you have to put, then where is the ratio? We don't have any ratio, right? So now that is where the concept of nominal mixed design and mixed design comes into play, and we'll try to see that. So I'll take you to that particular slide now. First, we'll try to understand what is nominal mix, and then we'll try to understand what is design mix. Yeah. So coming to the nominal mix, these are those mixes whose proportion of ingredients are fixed, like 7.5, 10, 15, 20 we had, right? For M15, it is 1:2:4. For M20, it is 1:1.5:3. For M25, is to 1:1:2. So this is fixed. No one can change it. Now, for example, right now I'm in Karnataka, a place in India, right? So if someone tells me prepare a M20 grade of concrete, I won't ask you any questions. The moment you say me M20 grade of concrete, I know the ratio. It has to be how much? I'll write it here. Someone told me prepare a M20 grade of concrete. So the moment he says M20, I know that I have to add 1 part of cement. I have to add a 1.5 part of sand, and I have to add 3 parts of coarse aggregate. Done. Now, let us say one of my friend, he's in Delhi. I'll write it here. Right, Delhi is the capital of India. So if somebody says him prepare M20 grade of concrete, again he is not going to ask you any question. So directly even he also knows that it has to be 1:1.5:3. Good. So this is constant throughout the country. Now when we go for the mixed design, it is completely different, and we'll try to understand that. I hope this concept is clear about nominal mix. When I say M20 or M15 or M10, it is same throughout the country. There is no change in that fixed ratio. Yeah. So the ingredients are mixed based on the volumetric basic. That means when I say 1:1.5:3, how do I measure that? This is that measuring volume what we have. Suppose if I say 1:2:4, how do you prepare that? In that case, what you're supposed to do, you have to fill this entire container with cement 1 time, that is called as 1. 2 in the sense it is for sand, so you have to fill this entire cylinder, container 2 times with the sand. 1 time you'll fill and you'll put it again. You're going to put again you're going to fill and you're going to put. And when I say 4, you have to fill this particular container 4 times. Only then this will become my 1:2:4 ratio. But here what is happening, based on the volume you're doing, not on the weight. It's not like I'm not telling you take 50 kg of sand, take 100 kg of coarse aggregate. I'm not speaking in terms of weight. I'm speaking in terms of volume. So this is the volume. So that is why most of the nominal mixes, we use nominal mixes in terms of volume batching. Okay, that is the first thing you need to understand. Now we'll come to the design mix. So what is this design mix? These are those mixes whose proportions of ingredients are not fixed. That means For M30, we don't have ratios. For M35, we don't have ratios. So these are called as design mixes. So in this, what we do, we will take individual materials. Like if I want to prepare M30 grade of concrete, I'll take a cement, I'll take sand, I'll take coarse aggregate, right? And I'm going to individually do the testing on that. I'm going to do the specific gravity test on that. I'm going to check the I'm going to do the sieve analysis for that. And then there's a code book called IS 10262 2019 code book. I'll show you that. So this is that code book. Yeah, you can see it here, no? It's written IS 10262. Okay, from this code book, you have to do all these manual calculations. Like, see, I won't explain all these things here. It's already explained in my concrete technology course, but I'll give you an idea. So all these formulas you need to apply. That is F dash CK is equal to FCK plus 1.65. Like that means if I want to prepare M30 grade of concrete, then I have to put 30 plus 1.65 into S I need to do, and all these manual calculations I need to do. Okay, once I do all these manual calculations, finally I'll get that my cement will be 350 kg per cubic meter, water will be 140 kg per cubic meter, fine aggregate will be 896 kg per cubic meter, coarse aggregate will be 1140 kg per cubic meter. Forget about the chemical admixtures, and water cement ratio will be 0.4. So from this I'm going to get that ratio for M30. How do you get the ratio? It's very simple. Write down the answer directly here. Say I got 350 here. I got 350 for cement. For fine aggregate, it is 896, right? And for coarse aggregate, it is 1140. So for ratio, what you have to do? 350 by 350, because for ratio, I'll divide it by cement quantity. So 350 by 350 will come out to be 1. Okay. And now 896 divided by 350. 350. And for coarse aggregate 1140, you divide it by 350. Now, if I do it manually, let me do it. Yeah. So 896 divided by 350 will be 2.56. I'll write it here. Text. So my ratio will be 1 always for the cement. It is 2.56 is 2. And for aggregate, it will be 1140 divided by 350. So it is 3.25. So this is my ratio for this particular M30 grade of concrete or whatever it may be. Now another question will come in mind, whether this ratio is constant, that if I say M30, then you will take 1 is to 2.56 is to 3.25. This is not constant. Why? Because right now, let us say this particular ratio, what I've got, no, like 1 is to 2.56 is to 3.25. This is the place where I'm staying. Right now I'm staying in Bangalore. So this is a ratio what I got based on the quality of the cement I'm getting, based on the quality of the fine aggregate I'm getting, based on the quality of the coarse aggregate I'm getting, and based on the quality of the water, I got this answer, right? So that is why if you go back here in the question, all these things will be written here. What is a, you can see it here, no? What is the grade you're putting up? It's a M40 grade of concrete. What is the grade of the cement? Here they have taken 43 grade. If they had taken 53 grade, they would have got a different answer. What is the nominal size of aggregate you have taken? It's a 20 mm size. What is the maximum water cement ratio you have taken? 0.45. What is the slump that you wanted? And what is the specific gravity of the cement? What is the specific gravity of the coarse aggregate? What is the specific gravity of the fine aggregate? Right? All these things you need to understand. Of course, it's a completely a different chapter. Concrete mix design is not that easy, like I'm explaining. You have to do trial and error, and finally you have to get a value, whether it is satisfying the criteria or not. But I'm giving you an idea how we are getting that ratio, right? So in Bangalore, I'm now whatever sand I'm getting in Bangalore, suppose whatever answer I got, right? If I go back, see, this is a ratio what I got. 1 is to 2.56 is to 3.25. This is what I'm getting in Bangalore. Now let us say I'm going to Kolkata, and if I ask you to prepare the same M30 grade of concrete with the help of mixed design, you're not going to get the same ratio. Why? Because the sand, the quality of the sand what I'm getting in Bangalore may not be the same quality of the sand what I'm getting in Kolkata. The quality of the coarse aggregate what I'm getting in Bangalore may not be the same quality of the coarse aggregate what I will be getting in Kolkata. The quality of water what I'm getting in Bangalore may not be the same what you're going to get in Kolkata. So from place to place, there's a variation, and also the quality of the cement. And if there is a variation, obviously this ratio is not going to remain same. So it may change. It may come out like 1 is to, let us say 2.4 is to, let us say 3.6. So that is a variation you're going to get. So always remember, mixed design, you're not going to get same answer, whereas in nominal mix, you're going to get, like if I go back. Yeah. So that is why you can see it here. The ratio of proportion varies from place to place depending upon the quality of the materials, grade, and company of the cement available. Here, the tests are conducted on each and every ingredients, and only after that the ingredients are used. Like you're going to check the specific gravity of cement for fine aggregate, for the coarse aggregate, even for the water. You are going to do the quality testing. Because we want the pH of the water in between 7 to 7.5, right? Again, that is mentioned in the code book, like what should be the pH. Also, you have to check the organic matter, what is present. Let me give you a small idea. If I go back to the code book again. Yeah. Yeah. You can see it here. What is written in the code book? The pH of a water shall not be less than 6. It is written in the code book that pH of the value should not be less than 6. Other than that, these are the permissible limit for the solids. Okay, in the water, all these limits, what you can see, organic, inorganic, sulfates, chlorides, all these things should be within this permissible limits of 200 milligram per liter, 3000 milligram. So all these things you don't have to. They are called as, we have third party consultants. If you give the water to them, they are going to do all the testing, and finally they are going to tell you that this particular water is good. So you can see it here. Water found satisfactory for mixing is also suitable for curing of concrete, right? So water which we drink, no, that is good for making the concrete. So all these things you need to consider, and only then you can prepare a mixed design. So that is why you don't get a what you call constant answer for the mixed design. It will vary from place to place, right? So I hope you have got an idea, at least a basic idea, how exactly all these things are prepared. Yeah. So again, the grade of a concrete from M25, M30, 40 and above, all are this mixed design. Okay. Even M20 also you can do mixed design, but usually we don't do, because whatever we are getting, like 1 is to 1.5 is to 3 for M20, that is good enough, and it's going to give you a good strength. But above M25, like even M25, we don't go with a nominal mix, even though we have this 1 is to 1 is to 2. We don't do that. For M25, we usually go with the mixed design. We are going to do the manual calculation, and we are going to do the mixed design. For high-rise structure, it is always mandatory to use the mixed design. When you're putting up a structure like G plus 10, G plus 11, 12-story building, 13, 14, 15, whatever it may be, always it is recommended to make use of mixed design. The ingredients are weighed here, and the concrete is designed using IS 10262 code book. That means, again, one more thing, what is the difference between a nominal mix and the design mix is, in nominal mix, it is mostly based on the volumetric basic. That is, we have seen that container, right? With the help of the container, we try to measure the quantity of the cement, fine aggregate and coarse aggregate. Here you are not going to make use of that particular container. Here what will happen, based on the weight, if I say 50 kg, 50 kg of cement I'm going to take. If I say 200 kg of fine aggregate, I'm going to make use of 200 kg of fine aggregate. If I say 500 kg of coarse aggregate, I'm going to take 500 kg of coarse aggregate, right? So here there won't be any changes, but in nominal mixed design, there is a changes. So that is why when you go for the, anyhow, I'll show you a practical video of how this mixed design is actually prepared. You can see this is how that batching plant is kept ready. So here you have different ingredients, like you have fine aggregate and you have coarse aggregate, and through the conveyor belt they are going to come. The cement is stored here. These are called as silos, and through this, with the help of the weight, there is one person sitting inside. He'll operate all these things. This, yeah, you can see a small cabin here, right? Through this, he's going to do the operation, like how much cement should come, how much fine aggregate should come, how much coarse aggregate should come, how much water should come. Based on that, based on the way batching, all these mixed designs are prepared. Okay. In a volumetric batching, that is in a nominal mix, we don't have such system. Directly on the site, with the help of labels, we do that. But if it is a design mix, we have to do something like this. Anyhow, we'll see the practical video of this, how exactly all these things are done. Yeah. Now uh, yeah. So now I put it in terms of chart, like one is nominal mix, other is a design mix. We'll quickly try to understand this. So coming to the nominal mix, the ratio of ingredients are fixed, like cement, fine aggregate and coarse aggregate and plus water, everything is fixed here. The ratio of ingredients are not fixed, but they are got with the help of a mixed design using the codebook IS 10262 2019 is a new codebook what we have. The mix is obtained by volumetric batching, but here the mix is obtained by wave batching. Here no quality control is followed here, and no individual testing of materials is done here. That is, in volumetric batching, usually there is no quality testing. Whatever aggregate you are getting, whatever fine aggregate you're getting, directly are making use of it. We are not going to do the testing of even the water there. But in case of design mix, usually we will do the uh, uh, testing of the fine aggregate, coarse aggregate. We are going to do the testing on the water as well. Next, no slump test and cube testing is done here. We'll try to understand what is this slump test and cube test in the upcoming lectures. But here we are going to do the slump test and cube testing so that we can get an idea whatever grade we are prepared, whether the same grade is achieved in the concrete structure or not. So that is the importance of doing the cube test here. Next is, here it is assumed that the required strength is obtained. When we do the nominal mix design, we achieve that whatever mix we are preparing, that much amount of strength is we are going to achieve. We are not going to verify that. But here what will happen, we are going to justify that whatever concrete we have prepared and whatever concrete we have put it in the structure, the same strength is achieved with the help of a cube test. And we are going to do the proper lab testing of this cube. We are going to prepare the cube, we are going to put the compressive strength on that, and after the 28 days we are going to check whether M30 grade of concrete what we prepared exactly is getting a strength greater than 30 Newton per mm square or not. All those things we do in the mixed design. Next is, materials used here is cement plus fine aggregate plus coarse aggregate and water. These are the usual material that you are going to use. But when it comes to the mixed design, you are going to make use of cement, fine aggregate, coarse aggregate. Along with that, of course, the water. We make use of certain plasticizers, and also we make use of certain pozzolaners like fly ash and GGBS, right? Next, use for the concrete of grade up to M20 and less. Like if you want to prepare a grade of M20 or even less than that, like M15 and all, then usually we go with the nominal mix. But here you can make use of this for any grade, but usually for M25 and above that, we are going to make use of this mixed design, right? So this is a basic difference between the nominal mix and the design mix. Now to put everything in a very crude way, it's very simple. Now you go to any market, okay? What is I'll put it in one line, the difference between a nominal mix and the design mix, okay? In nominal mix, what will happen? There is no bargaining. You go to any shop, you can see they are going to put certain sale, right? Sale 50 rupees, and this is a fixed rate, no bargaining, right? Sale 100 rupees, no bargaining. In a mix, in the nominal mix, what will happen? If I say M20 grade of concrete, the ratio is 1 is to 2 is 1 is to 1.5 is to 3. If it is M20, if it is M15, it is 1 is to 2 is to 4. There is no changes in that. Throughout the world, this ratio remains the same. So it's same throughout this shop. You look into any cloth, the rate is fixed. You cannot bargain here. But if it is a mixed design, what will happen here? Based on your bargaining skills, based on your experience, you can bring down the rate of this particular cloth to the lower price. Let us say you went and asked for this particular top, and the shopkeeper told it is like 200 rupees. Now you know that by now you took that particular cloth, and just by looking at the cloth, you came to a conclusion this cloth is not worth for 200. You can bring down the rate by bargaining, and let us say you got it for 150. How did you get it for 150? Based on your bargaining skills, based on experience, you got it. In the same way, when we go for the mixed design, what we do the individual testing on the materials like cement, fine aggregate, and sand and water. And through my experience, through the mixed design, I'll do the calculation, and finally I'll prepare a very good mix for that, right? So that will come through experience, and that is how the difference between the nominal mix and the design mix is all about. So I hope yeah, so I hope you understood the concept up to here. We'll see you back in the next lecture. Thank you. Hello learners, welcome back to the course on construction methodology. In this lecture, we'll try to see a bit more about a nominal mix design and a design mix. So far what we saw in the previous lecture was only about the theory, right? we actually did not see it practically how those things are done. So now with the help of a video, I'll try to make you guys understand how practically a nominal mix and how a design mix is done. So we'll quickly get into that. So I'll try to play a video of a nominal mix. So right now a concreting is happening. So the concrete, what is happening here, that is a nominal mix. So we'll try to see that practically now. So that is a nominal mix. Let us say I'm making use of M20 grade. It's M20 written here. And we know that for M20, this is a ratio we need to follow. That is 1 part of cement, 1.5 part of fine aggregate, that is sand, and 3 parts of coarse aggregate, right? So this is a ratio what I have. Based on this ratio, I'm going to prepare my concrete here. So we'll try to see that. Right, so now observe it carefully. You have your coarse aggregate stored here, you have a cement bag stored here, and then on the this side we have our sand stored here, and then we have cement bag stored on the other side. So what these people are doing, if you observe it carefully, they don't have any batching plant or they don't have any weighing machine. If you can remember in the previous lecture that I told you that if we are doing a nominal mix, then always it is a volumetric, right? What we do, volumetric batching we are going to do. So here, based on the volume, we are going to prepare the mix. So we'll go forward and we'll try to see that. You can see we call this as buttis. Now let us, now when I, from here onwards, whenever I say I'm making use of a word called butti, I'll write it here. If you're not able to get my word, yeah, I'll change the color of the ink. Yeah. So I'm calling a word called butti, B-U-T-T and Y, butti, or you can say it as bucket. So one, what you can see here, right? So this is a butti. So you can remember whenever from now onwards, when I say, when I utter a word butti, I'm trying to tell this is what it is, right? So I'll erase it again. Yeah, so now you can see the butti there. Yeah, and see, so same butti is kept there, and this guy is making use of a bucket, right? This is a bucket now. So these guys have cement stored here. Now this yeah, we'll try to see that video again, then I'll explain it. So now entire cement bag. So this guy is, emptying all the cement bag, right? I mean, see, one cement bag is 50 kg. If you know that this entire bag of cement, I'll make use of pen itself. Yeah. So whatever cement bag you have, no, it is 50 kg. This is 50 kg. I mean that there is 50 kg of cement in this bag. So what this guy is doing, he has a bucket here. He has one more bucket here. So if he's trying to empty this entire bag, then he need to put one complete bucket of cement. Along with that, there is one more bucket he's going to add. So this will come almost to this level. So this is what they're practicing. Yeah. So we'll go ahead again. Yeah. So this is what they're practicing. They're adding one full bag, and then another half is coming here. So as I mentioned, it's a nominal mix. So volumetric, based on the volume, they're mixing it. Along with that, this guy is preparing a sand here. Again, they're making use of this butti, and based on that, he's adding sand. So this is how they're doing. So all this is volumetric basis. So that means they have to add one part of cement. For that 1.5 part of sand they have to add, and they have to add 3 part of coarse aggregate. But no, but usually what happens, they don't practice that. They have their own way of measuring the things. I'll tell that. And you can see here, right? There's a woman standing here, and she's adding water into that concrete mixer. We'll try to see that. See, this is a concrete what we have prepared now. So this is a bucket what we have, and the guy is standing on the other side. He's going to lift it so that this bucket will go to the top floor where the concrete is happening, right? So this will go to the top floor. So right now we are not concerned with those things. We're just concerned how the nominal mix design practically happens at the site. So we'll try to see that again. Yeah. So this is how they are mixing. They are coming. These guys are coming with the help of coarse aggregate, and they are putting it in this concrete mixer, right? All these are the coarse aggregate, and he is adding cement also. And there is one more. Yeah. This woman is adding coarse aggregate, and they'll add sand. So this is what they're practicing. So one thing we need to understand here, as I always mentioned you, in the nominal mix, you don't have any quality test here. So whatever these labors are doing, that is a final concrete. Now let us say I need to prepare M20 grade of concrete. This is the ratio I need to work out. And what these guys practice, they'll add one full bag of, I'll make use of pen again. Yeah. So what these guys are practicing, if they want to prepare M20 grade of concrete, they're going to add one bag of cement that is 50 kg, one bag of cement that is 50 kg they are going to add. Along with that, they're going to add four buttis. Okay. Now you know the word butti, right? Four buttis of sand, whatever sand is stored here, they're going to add four buttis of that sand, and they're going to add five buttis of coarse aggregate, right? Whatever stone chips you have here, they're going to add five buttis of coarse aggregate. I'll write it like this. And the water is stored here. What they're going to do, they're going to add two and a half bucket of water. So this is the ratio what they follow. So what actually happens, there is no quality test happening here. Sometimes this one bag may contain full 50 kg of cement. Sometimes this may come out to be like 49.5 kg, because 500 grams may remain in the bag itself. Whereas look at this guy, he is putting the sand. So every time he doesn't make full buttis. I mean, if you have a butti here, I'll draw it butti here. So right, every time you cannot expect that guy to fill this butti completely, right? Sometimes he may fill up to this layer. Sometimes the full butti gets filled. So what is happening? There is no quality. I mean, sometimes you're getting more amount. Sometimes you're going to get less amount. The same thing with a coarse aggregate. We'll try to play. We'll try to see the video again. So look at this coarse aggregate, what they're putting. See, someone is bringing the bucket full, I mean the butti full. Some has little less quantity of aggregate. I'll remove that. Yeah, right. So they are waiting for their turn. So this is how they have seen. Now look at this. Here they've added more and more water, because there is no limit to the water to be added. Whatever they have in their mind, they're going to add water. And look at the quality of the concrete here. This is, I mean, there is a lot of slump here. I don't find this concrete will work out. But since we consider a lot of factor of safety in our structure, so usually the structure doesn't fail. I mean, immediately. It may take time, but look at the quality of the cement here, right? It's completely it's like water here, right? You have added more water here. So this is how it's happening. So that is why always we tell, in the nominal mix design, we don't get the right quantity and we don't get the exact mixture. If I'm saying M20 is happening here, I don't think so exactly M20 grade of concrete is happening here. This may be like M15 or M20, but everything, it's left to the god, I would say. And also we consider a lot of factor of safety. That is why nothing is going to happen. But yeah, we'll try to understand it again, right? So they're coming and putting it in the concrete mixer. And actually, according to the, see, now look at her, she's adding water, right? So yeah, adding it full again. Now she's adding half of the water is wasted here, right? Again she's adding half. So every time she's adding the water, sometimes she may add complete water. Sometimes what is happening, half of the water is wasted here, right? So every time when you're preparing the mix here, you're not going to get a same amount of I mean ingredients, right? Sometimes she may add more water, sometimes she may add less water. Based on that, what is happening, a mixture is getting ready. But anyhow, that is fine, because when we add the thing is that uh, yeah, when we add cement, and when we add sand, and when we add coarse aggregate to that, I mean, yeah, and when we add water to that, at least this concrete will gain some strength. That we know that. So anyhow, when you mix all this coarse aggregate, cement, water and all, some strength is achieved in your concrete. So that is why it's fine, your concrete is going to get pass and the structure will remain there. But if it is a small structure, then it is fine. We don't have to worry a lot. But let us consider you're constructing a big structure like G+10. In that case, you have heavy load coming on your structure. In that case, we cannot allow a concrete to be casted in this way. This is a very crude way of casting. For the small building, it is fine, it works good. But for the big buildings, this method will fail. I mean, if you're preparing a concrete by this method, we are not going to achieve that M20 grade of the strength. Okay, so I hope this is cleared up to here, right? And there is no if you observe it here, what they're doing, they're casting the concrete and they're pouring it to the wherever the floor they require. There is no cube testing is happening, right? As I mentioned you, in the mixed design, what we do, if not, I'll explain in the next slide. I mean, in the same lecture. Here there is no quality, there is no quality engineer. Whatever these guys are doing, that is the final thing. There is no cube test happening, there is no slump test is happening, right? They're not going to check whether the I mean, right amount of water is added or not. They're not even checking the quality of the water. You can see here, right? I'll make use of a pointer. Yeah, see, this is a bucket what what they have kept here, and they have a pipe here, and no one is concerned about the quality of the water. Actually, when we do the construction, we need to have a 6.5 to 7.5 is a good amount of pH that we need to have in the water. So no one is concerned about what is the quality of the water and all. So whatever water they are getting from the nearby area, they are putting it in the concrete, right? So there is no, a quality test happening. And even the cement, of course this cement come from good company, don't have to test with the cement. But look at the sand and the aggregate what is stored here. Now, yeah, I'll take another 1 minute, which is a very important point. Now let us say they are doing the casting of the concreting. So right now the sand looks good and the aggregate looks good. Now imagine it started to rain now. Imagine it started to rain here, and after 5 minutes the rain has stopped. So that 5 minutes of rain might have made this entire sand wet, and also might have made this coarse aggregate wet, right? So since now when we do the concreting, now let us say after 5 minutes I started the concreting again. So what has happened, in this sand there is already moisture content, and in this coarse aggregate there is already moisture content, and over that we are going to mix the same amount of water, whatever 2.5 liter of water this women was adding, same water is we are going to add. So what is happening again, the quality of your concrete is going to come down, because already there is water in the sand, already there is a water in the coarse aggregate due to the rain. Now again over that we are going to add water. And in one of my lecture I've explained you, if water cement ratio increases, if water by cement ratio increases, what will happen? The strength of the concrete, strength of the concrete will come down, right? If you want to achieve M20, you may achieve some M15 grade on the side. So again, if water cement ratio increases, the strength is going to come down. Now since it started to rain here, and after 5 or 10 minutes the rain stopped, these people again started their work. So this sand and this particular aggregate has come in contact with the water. Along with that we are going to add the same amount of water, that is 2.5 bucket of water. So if water increases, then what will happen? Your strength is going to come down. But when again, as I told you, if you're working for a small project and all, this change will be not so significant, but not a right way to do, but it works out well, so people are not much concerned about it, right? Now so far what I discussed was only about the nominal mix. You can see the nominal mix here. Now I'll explain you how the design mix is done. Yeah, so yeah, this is how a design mix is done. You can observe it here. I have written here design mix. I'll make use of pointer now. Yeah, so this is how a design mix is going to happen. Now let us say I want to prepare M25 grade of concrete, which is a design mix, or let us say M30. Okay, we'll take M30 as an example now. So what I'm going to do, so this is how the process starts. Yeah, so this is how the process starts. You have a batching plant fixed. So these are the water tank, this is the concrete mixer, and all these are the place. Now what will happen, with the help of this excavator, we'll lift the cement bag. We lift the cement bag and we are going to pour it inside this, and this guy will take it to the will store it inside the silos. Now what is happening, this is a quality testing happening here, right? People are more concerned about the quality. They're going to check the fineness of the cement, the everything they are going to test. And now look at this guy is lifting the aggregates, and these aggregates will be checked. Okay, before that I want to add few points. So whatever aggregate you saw, those aggregate testing will be done. We'll be checking the moisture content of the aggregate, we'll be checking the moisture content of the sand. Then you're going to test, you're going to do the sieve analysis. You're going to see whether the aggregates are of good qualities. All this testing will happen. Only after the testing we are going to store our raw materials here. But whereas in the nominal mix what we saw is no testing and all, whatever material they got they have started to prepare the concrete. But here proper procedure we are going to follow, right? Now with this we are going to store it in the bin. These are called as storage bin. We call this as cold bin. So in this what will happen, we are going to store the aggregates and sand. So every time he's adding, there's certain amount. I mean, they have calculated the amount that is required. Based on that, they are going to add it. So there's a lot of quality process happening. And all this is weight batching. With the help of weight, we are doing that. There it was volumetric batching, right? But here it is weight batching. Each and every ingredients are weighted here. So from here we are going to pump it. The cement will come, right? And from here this is water. This is water. Whatever, how much amount of water is now. Now look here. Whatever amount of water is required, the same amount of water will be gone. Every time we do this, let us say I want to add Let us say I want to add some 500 liters of water. I'm taking it random number. Let us say I want to add 500 liters of water. Every time I pump in, 500 liters of water only will come. It's not like 501 liter will come or 499 liter of water will come. Every time I want to prepare this mix, 500 liter only of water will come. But whereas in the nominal mix, what happened? Sometimes she's adding 2.5 bucket of water. Sometimes she may add 2.5, but in that half of that will be wasted, right? So there is no quality happening. But here everything, what is happening, we are in from quality point of view, we are following everything. Yeah, so these are the admixtures what we use. We'll speak about the admixture later, what is admixture and all. Okay, so once that is done, from there we are going to take it all this. So these are the aggregates what they are going to weigh with the, all these are hydraulic machines what we have. So see, everything, no, everything is weighted here. Only on that they are going to release the raw materials. So this is how they're loading the, raw materials. From there it will be taken to the top side, and here they are going to do the mixing. Now look at the mixing. Look how the mixing is happening. Uniform mixing is happening here, right? You have this mixer running, and this is doing a uniform mixing. Whereas in the nominal mix, what happened, the mixing was there, but sometimes you may rotate that mixer for 1 minute, sometimes you rotate it for 2 minutes. According to IS 456, we have to rotate it for 2 minutes. But if you saw in the previous lecture, I mean, yeah, when I was explaining nominal mix, there the machine was, I mean, it was running, but there was no proper mixing and all. But here such things won't happen. Uniform mixing will happen. And then what happens, this RMC, this is called as transit mixer. Now this transit mixer will come. From there what will happen, whatever amount is required, with the help of this hopper, you can see here, right? So the concrete will go into this, and from this, wherever the site the construction is happening, we'll go and dump it over there. Now we'll try to see how the quality tests are done at the site. Now let us say is one site happening here. Let me take an example. Yeah, let us say there's one construction site happening here, and I need to pour the concrete. So I'll order this transit mixer. So this transit mixer will come here, and wherever I need to do the casting of that, with the help of this transit mixer, I'll do the concreting work here. So the moment this transit mixer come to the site, directly I'm not going to pour the concrete. I'm going to do two tests. One is the cube test, and second is I'm going to do the slump test. So with this, what will happen, cube test we are going to do, so that I want to make sure that M30 of grade only I'm going to cast. And slum test, I want to see what is the water cement ratio and how much slum is happening. Because I already have mentioned you, right? If you're adding more water, the strength is going to come down. So here we have already done a way batching and all. But same has to be done at the site. The same mixture, I mean the same concrete, the same quality of the concrete should be achieved at the site. That is why we do this test. One is the cube test. I mean, we do the casting of a cube, and after 20 days we are going to test to make sure whatever concreting we have done, that is M30 grade only we have done or not. Slum test will give us an indication whether my concrete is workable or not, and whether I can make use of that concrete in a better way or not. Okay, we'll try to see that in the next lecture. Yeah, I'll erase it now. Yeah, we'll try to see that. So once the that mixer reaches the site, so this is from a different site. Yeah. So these are the transit mixer. Here we are going to, store the concrete, and from there, what will happen? This vehicle is reach to my site, the place where I ordered my concrete. This vehicle is going to reach there, and once it reaches there, what we are going to do? We'll take some amount of the concrete from this particular vehicle, and we'll do the cube. We are going to do the casting of a cube. So these are the cube. Already these things I've explained you when I've explained you the slab casting. So I will not go in depth. So this is 150 by 150 by 150 of the cube. Okay, it's written here 150 mm. So what we'll do, we'll make use of that concrete, and we are going to place it in this particular cube. And after that, what will happen, next day we'll try to remove this, and we'll do the testing on that, so that I have to make sure if I'm doing, if this is my M30 grade of concrete, the same strength I need to achieve once I do the testing on this. So in the design mix, all these are the parameters and all these are the quality that we need to follow. Now you try to relate nominal mix with the design mix. In nominal mix, we never did all these things. We just did the concrete and we started to cast the concrete. We never did the cube testing and all, right? But here there are a lot of, you know, quality checks that we need to do. Only then we can make sure that M30 grade of concrete is happening. I mean, exact M30 grade of concrete, the strength of, I mean, the 30 Newton per mm square is the strength that I require. The same has been achieved at the site. So this is how the, you know, cube testing will happen. So this is how it is done. We are going to cast the cube. Once the cube is casted, this is how it looks, and we have to do the curing of this. So this curing and the slab curing, what we saw, I mean the normal curing is done from that point of view. Again, we are going to do the curing, and after 28 days, what I'm going to do, I'm going to do the testing on that to make sure that M30 grade has been achieved at the site. Yeah, I hope all these things are clear. So we'll take another 1 or 2 minutes and we'll try to see all the whatever I explained so far. We'll try to see it in a table format. So I have a nominal mix here and I have a design mix here. We'll try to understand nominal mix. The ratio of ingredients are fixed, like the cement, the fine aggregate, the coarse aggregate, and the water is fixed here. So let us say if I want to prepare M10, it is 1 is to 3 is to 6. If it is M15, it is 1 is to 2 is to 4. If it is M20, it is 1 is to 1.5 is to 3. Whereas in the design mix, the ratio of ingredients are not fixed, but they are designed based on testing each materials, and by using, we have a code book of Indian standard 10262 2019 is a new release code book. So with the help of this code book, I'm going to do the testing on each and every material. Here I'm not going to test any material. I'm not going to see what is the quality of my cement. I'm not going to see what is the quality of my fine aggregate. I'm not going to see what is the quality of my coarse aggregate. I'm not even seeing what is the, you know, pH value of the water. Like if you listen to me carefully, while she was adding water, you saw that, right? I mean, there is no testing of the water happening. But when we do the design mix, if I'm taking cement, I'm going to test the cement. I'm going to check the initial setting time. I'm going to check the final setting time of the cement. I'm going to do each and every test on the cement. In the same way, if I'm taking a fine aggregate and the coarse aggregate, I'm going to do the sieve analysis to that. I'm going to see the moisture content that is present in that. Along with that, when I take water, I'm going to see the pH value of a water, whether my water, I mean whether the pH value of a water is from 6.5 to 7.5 or not, because the water that we use for concreting should be the same water what we use for the consumption. So that is why all these checks are done. Once all these checks are done, with the help of this code book, I'm going to design the ratio. That is why here ratios are not fixed. That ratio will try to derive, I mean we'll try to find out with the help of a code book and based on our knowledge and all. The second point is the mix is obtained, the mix is obtained by volumetric batching. You saw there, right? They used buttis and they used the bucket. So that is the measurement what they follow. So as I mentioned, sometimes they may fill entire bucket of the cement. Sometimes half of that cement may remain in the bag itself. Sometimes they may fill 4 full buttis of sand, or sometimes they may not fill the entire butti. So that where there's a lot of changes happening in every batch what they prepare. So that is why it is a volume. Based on the volume, they are preparing the mix for the nominal mix. But whereas in design mix, it is obtained by wave batching. You saw it in the video, right? Every time they were adding coarse aggregate and fine aggregate and cement, there was a proper, weighing done before. Like if I want to add 1 kg of cement, then only 1 kg of cement will go. It's not like 1.1 kg of cement will be added or 0.99 kg of cement will be added. Every time I say 1 kg, exactly 1 kg of cement will come. If I say 5 kg of coarse aggregate, exactly 5 kg of coarse aggregate will come. But here if I say 5 bucket of coarse aggregate, sometimes that may be a full 5 bucket, or sometimes it may be 4.5, or let us say not I mean you will add 3 full bucket, and the next 2 bucket may be half of that. So you don't have anyone watching all those things. So there is a lot of variation. Here there is no variation. If it is 5 kg, exactly 5 kg we are going to get. Next, no quality control is followed here, and no individual testing of material is done, right? Again, if you can remember, there's no quality test and all. They did not do any slump test, or they did not do any cube testing there. And they did not even test what kind of materials they are using, what quality of materials they are using. But whereas in the design mix, we saw that each and every materials will be tested, and after that, based on the Indian specification, we are going to allow the material to use, right? And next is no slump test and cube testing is done here, right? If you saw there, we did not do any test in the nominal mix, whereas in the design mix, the moment the concrete RMC, I mean the concrete entered the site with through a transit mixer, we did the cube casting, and all this quality test will be done at the site if you're working for a bigger projects. Next, here what is done, here it is assumed that the required strength is obtained. We assume that if I'm preparing M20 grade of concrete, I assume that that M20 grade will be achieved. Now whether the M20 grade exactly it's going to achieve or not, it's left to God, and it all depends. But whereas when it come of design mix, if I'm saying I'm preparing M30 grade of concrete in a design mix, let us say I'm prepare M30 grade of concrete, then I'll make sure that is here the required strength is justified with a proper lab test. What I'm going to do, I'm doing the cube testing, right? I'm going to cast a cube, and these cubes will be casted, and after 28 days I'm going to do the compressive strength on that to make sure that exactly 30 newton per mm square of the strength is achieved on the structure, right? So that is why it's written. That is why here what will happen, the proper tests are justified with the help of lab test. Here there is no justification, it's just we assume that yeah, M20 is achieved, that's it. The rest is left to God and depends on the contractor who is doing that. Next is, this is used for small constructions, like if you're constructing a small house, or if you're constructing a small G+1, that is ground floor and the first floor building, or let us say if you're constructing G+2, or if you're constructing a small commercial building of G+1 or G+2, then you can make use of the nominal mix. And it has been found through experience that if you add with this proportion, you're going to achieve you're going to get the strength. But here you cannot make use of here what will happen, yeah, design mix you can make use for the small construction, but that requires lot of money, right? Because if you're ordering a transit mixer, you need to pay for the transit mixer and all. So in the small construction, what we feel is, instead of making it expensive, we make use of the concrete mixer what we did in the nominal mix, and we try to do it. But if it is a big projects, like if it is a G+5 construction, or some high rise buildings you have, like G+10, G+15, G+20, or if you have some important structures like the government buildings, like the thermal power plant and all, they all are very important structure, right? There we cannot take the risk and all. In that case, what we go for a design mix only. We go to some big consultancies, and also even a lot of IITs, colleges, they do all this mixed design and all. We approach them, they give a mixed design, and after that we do the testing of them at the in the lab. And once we feel that this proper, once we feel that this ratio will work out at the site, we are going to do the real construction. So till then we'll do all the trial and basis, whether this much amount of cement has to be added or not, how much amount of sand has to be added. So all those trial and error will be done in the lab, and those testing will be done by some reputed agencies. And also most of the IIT colleges, they do all this testing, they do the design mix and give. And the last one is, the what are the materials that we use in the nominal mix. If you saw that video, in the nominal mix we made use of cement, we made use of sand, we made use of coarse aggregate and water, right? Other than that we did not use anything. Whereas in the design mix, what we do, we make use of cement. That is common, you have to add cement. Along with that, we had made use of sand also, we made use of coarse aggregate also. Along with that, water anyhow we have to add. Along with the water, we try to add these plasticizers. Okay, we'll try to see what is plasticizer. Then also we'll try to add fly ash, we try to add GGBS. And so why all these things are added, see, actually when we do the production of the cement, a lot of carbon dioxide is released. So nowadays a trend has come up that in order to reduce the what you call pollution, in order to reduce the pollution, since carbon dioxide is released during the manufacturing of cement, so that is harmful to the nature. So what we are going to do, we are going to decrease the amount of cement. So that decrease in the amount of cement should be uh, justified, or let us say that has to be compensated by some other material. So that is why what we do, we make use of this fly ash. So fly ash is a waste product from the uh, coal industry, and GGBS is a waste material from the steel industry. Okay, GGBS stand for ground granulated blast furnace, like it is from the steel industry. It has been found through research and all. If you add fly ash and GGBS in your concrete, you are going to get more strength, and even the fineness of the cement and concrete will be very good. Along with that, what is this plasticizer? See, we saw one thing, right? Yeah, I'll make use of pen here. We saw one thing. If water cement ratio is increasing, If water cement, I'll make use of red pen. We saw one thing: if water cement ratio is increasing, water cement ratio increases, what will happen? Your strength is going to come down, right? See, now I have reached a stage when we prepare M30, M40 grade of concrete and all. What will happen? If I need more strength from this equation or from this logic, I need to keep my water cement ratio less, right? If I want to keep my water cement ratio less, only by keeping water cement ratio less, more strength is achieved. So M30, M35 is difficult to achieve. So in that case, we need to keep very less amount of water only. But we'll face another thing from design point of view, will pass. But during the execution, if I'm keeping less water and less water cement ratio, during the execution, the concrete will be not flowable. Right? If I want to pour a concrete in this particular footing, let us say, the concrete won't flow easily. I mean, the slum of the concrete will be very less. So it will be very difficult for the laborers to pour the concrete. So in that case, what will happen? We'll make use of these plasticizers. So these plasticizers, what they do, the moment you add plasticizers into this concrete, it will I mean, the entire concrete will become more, it becomes like water. Water cement ratio, we're not going to increase, the strength remains the same. But in order to make this concrete flowable, we'll make use of this plasticizer. So that by using plasticizer, two things is achieved. One is strength I'm achieving, that is I'm not increasing the water cement ratio. But second problem what I was facing at the site is that I was not able to make use of this concrete because there was no proper flow of the concrete, right? It was very harsh concrete. In order to make that concrete flowable, I'm making use of plasticizer, so that both the things are done. Strength is also achieved, and at the side, all this flow, and also at the side, the flow of the concrete will be easy. So that is why we try to add plasticizers. So it's written here, plasticizers are used to here to change the properties of the concrete and to reduce the water content. So there are a lot of plasticizers available in the market. With the help of that, we'll add 1 or 2% of plasticizers. Based on that, all this design mix are carried out. Whereas in the nominal mix, usually we don't make use of plasticizer and all, unless and until the engineer in charge prefers to use that. But in design mix, usually we make use of plasticizers, and also we make use of fly ash and GGBS, and based on that we are going to prepare a concrete. So this was a complete explanation between the nominal mix and the design mix. I hope you guys have got a clear picture about how a nominal mix and a design mix is done. We'll see you back in the next lecture. Yeah, thank you. Hello learners, welcome back to the course on construction methodology. In this lecture, we'll try to see a practical drawing of how a batching plant looks. In our previous lecture, we understood how a batching plant is set up. But in this particular lecture, we'll try to see how that batching plant will be set up at the site, and we'll also see the practical drawing of how those batching plant will be installed. So we'll quickly get into that. So I have a drawing here, right? So let us say this is some construction project. Yeah, so this is a kind of a construction that we need to do. So we'll not try to get into that, but I'll give an idea like how to see this drawing. So let us say this is some factory building what I have. You have a raw material storage here, and then you have a staircase here, and yeah, I'll try to zoom in. Then there's some control room here, you can observe it, right? There's some control room here, you have a diesel storage room here, and what else, you have a nitrogen package here, we have a wastewater treatment here, right? So these are the various things what is given in this particular building. But right now our concern is only to look into the batching plant, how that concrete batching plant is set up. So you can see here, right? So this particular area, what you can see, the one which is triangular, this particular, that is called as batching plant, which is 7721 square meter. So we'll try to see how this batching plant is planned in the site. So we'll go back to that. So this is how it looks. This is what we saw now. It's a blown up diagram what you can see here. This is the entire location what I have. So you can see here, right? We have a sand stock yard here, right? Because in order to prepare a concrete, I need cement, I need a fine aggregate, that is sand, I need coarse aggregate. So that is why what they have done, they are storing the sand somewhere here, that is called as sand stock yard. In the same way, we need 20 aggregate. So again, what they are going to do, they are going to store the 20 aggregate here. Along with that, we have to use 20 downgraded aggregate, that is 20 along with the 10 we are going to add. So again, you can see here 10 aggregate will be stored here. Along with that, we have a weighbridge here, right? So what is a weighbridge? So weighbridge is actually the one where the a transit mixer will come and come here, and it's going to weigh it, like what is the total density of the concrete, how much cubic meter of a concrete is present in my transit mixer. So you are going to check the weight of that vehicle. So your weighbridge will be here. So you have a batching plant here, then you have a curing tank here, right? Because as I already mentioned, when we go for a mixed design and all, we need to do the testing of that particular cube, right? So before testing, it has to be kept in the curing tank for 28 days, and after that we are going to do the compressive test on that. So that is why they have put up a curing tank here. This is a curing tank, and this is a water tank for that. And along with that, we have a lab here. So why this lab is given here? So in this lab, we are going to do the compressive testing of that particular concrete cube, right? And only in if you can remember, while understanding the difference between a nominal mix and the design mix, we understood one point, that is these tests are justified with proper lab tests, and only then that particular results are taken into consideration. So those tests are done in the lab. That is why in the site itself, what we have done, we have set up a lab here. Again, we'll be having a compressive testing, we'll be having a compressive testing machine here, and on that we are going to do the checking of the cube. I mean, we are going to check the strength of that particular cube. Along with that, we have a concrete mixer parking here, right? Whatever transit mixer comes, those things we have to park it here. That is why we have done all this arrangement. One, two, three, four, these are like 7 to 8 concrete mixer parking is done here. So this is how our entire site looks. Yeah, so when you work in some big companies, what they actually do is they set up their own batching plant. They're not going to order it from a nearby batching plant. What they do is they set up their own batching plant. So this is how the arrangement is done on the site itself. So that what will happen, daily we need to do the concreting from the batching from the same site, like wherever the construction is going on, from the same site we are going to take the concrete. We don't have to depend on some other companies, or let us say nearby batching plant. Instead of that, what we have done, we will set up our own uh, batching plant, so that we can do our work easily, right? So this lecture is all about giving an idea how this batching plant will be set up, like how it looks, sand stock, all these things we are going to do in AutoCAD. All these things, where you are going to place your sand, where you are going to place your aggregate, where you are going to place your 10 aggregate, where will be the curing tank, water tank, batching plant, weigh bridge and all, right? Yeah, that's it. I hope it's understood up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So far, we understood the basics of civil engineering, like cement, concrete, and all those things. Now we'll start with the sequence of the construction, which is the very first activity that we are supposed to do on the site, which is called as the site clearance. So we'll see how we are going to do that site clearance. And after that, we'll try to understand one by one all the sequence of a construction. Yeah. So this is the first activity that is done on any of the construction project. Let us say you started with your project, right? So what you are going to do, directly you're not going to start with the construction. Maybe the land what you have taken is not clean. There may be a lot of trees and lot of vegetations on the soil, right? So we need to clear off that. So that is a very first activity that we are supposed to do. So you can see it here, right? Let us say this is a land what I have, and there's a lot of trees here. So I need to cut down all those things, right? So that is the first activity. Next, the land is cleared with the excavator in removing the trees and the other plants. If there are any small plants and all, we'll try to cut it off. Yeah, the grader is used to spread the soil and to make a uniform layer. That means once you cut off all the trees, if there is any excess soil and all, right? I mean, if your ground is not uniform, if it is like up and down, in that case, what you're supposed to do, you have to fix one particular level, and then we are going to give a uniform surface. For that, we make use of this grader. So what this grader is going to do, it will spread the soil uniformly over the entire site what you have. And this is how it looks. So these are the small vegetations what you have, isn't it? So with help of this what is that, backhoe, you can try to excavate all these things, and then you can run the roller also, so that you're going to get a compacted soil. So it depends on the condition of the site what we have, but this is the very first activity that we are supposed to do. Yeah, so once this is done, the next activity is about the center line marking. Now to put it in a better way, yeah, see, for example, let us say this is a construction site what I have. Okay, so this is a big plot what I have. This is the entire plot is mine, but I want to construct a house, or let us say a building, somewhere in the middle part, somewhere here. Let me make use of only this much part, and only in this much part I'm supposed to do the construction, right? So this is my built up area. We call this area as a built up area because I'm building it here, right? So we call this as built up area, whereas this entire thing is my built up area, where this entire thing is my plot area. Okay, or my plot, you can say plot area or plot, right? So when this is my built up area, I need to do the marking, isn't it? Marking in the sense, say for example, when you construct any home or something, your columns will be somewhere here. Let us say my one column will come here, this is my second column, this is my third column, then another column is going to come here, another column is going to come here, another column is going to come, right? So in this way my columns are going to come, isn't it? So I need to do the, let me finish it off. So another column, so another column. So this is column marking I have given. Let me do the footing marking as well. So if you don't know what is footing, we'll try to see all those things, but for time being, I'm just trying to draw something here. Okay, anyhow, let it be. Okay, it will not look good. So these are the these are the column locations and footing marking we are supposed to do, right? So for that, what we need to understand the structural drawings. So I'll show you one particular plan, and we'll try to understand how the drawings has to be read. Okay, so I'll take you to one of the structural drawing. So whenever you work in any construction project, the first drawing that you're supposed to get is the architectural plan. In that, your complete plan will be there, like where is a bedroom, where is a kitchen, and all these things will be mentioned there. So that is your architectural plan. Now coming to the structural part, we get the first drawing, which is called as footing layout. You can see it here, plan, and it is written footing layout. So how do you understand this? Very simple. Don't get panic. I'll explain you how this has to be understood. So always remember, you can see something written here: A, B, C, D, E. So these are called as grid lines. Let me write it here. These are called as grid lines. Okay. So this is in horizontal, right? I mean, if I, this is horizontal. Yeah, right, because I'm going in this direction. So this is a direction what I'm following. So this is horizontal for me, and if I go in this direction, so if I go in this direction, it is a vertical for me, isn't it? Let me minimize this a bit. Yeah, so hmm. So this is horizontal. I have written horizontal grid line. Similarly, you can see a grid line somewhere here, like what is mentioned here. So it is written 1, 2, 3, 4, 5, and 6. So this is a plan what I have. So these are the grid lines. You can call this grid line as a reference line. Now to understand this in a better way, what I'm gonna do, I'll come here. So see, this is grid line A, it is coming here, and this is grid line 1, where exactly these people are meeting. If I try to draw a line, so this guy is coming from here. Okay, and then there's one more person, I mean the grid line 1 is coming, and these people are meeting exactly at this particular point, right? So this is that point, this is that point, isn't it? Now we'll try to understand what exactly it means. Okay, that means the name of this footing, like my name is Akshay, you people have your own name. In the same way, this particular footing, the name of the footing is F3. F means footing, and the number 3 is given. Okay, F3 is given. In the same way, how do you read this? The name of the footing is F5. Similarly, you have F3 footing. Okay, again you have the CF1 in the sense combined footing. In the same way, we have F2 footing, F2 footing, then we have F4 footing, we have F1 footing, and we have F1 footing, right? So these are the name of the footing. Now coming to the dimensions of this footing. What is the dimension of the footing? You can see something written here. See here, from here to here, what is shown? It is mentioned it is 7 feet. So this 7 feet is the length of this footing, and this 6 feet you can see. So this 6 feet is a width of the footing. If somebody asks you to read this drawing, can you read it? It's very simple. You should tell this is F3 footing, and the length is 7 feet, and the width is 6 feet. This much is clear. But usually, how we need to understand this is that whenever the surveyor or whenever we do the marking on the site, no, we take this center marking. You can see there's one grid line coming here. Yeah. So this is a grid line what I need. This is the center point what I need. So you can see where exactly it is meeting. This is that center. Okay. This is that center. Now from this center, what is the distance up to here? That is required for me. So how do I take care of that? It's again very simple for us. See, from this center to here, what is the distance given here? It is 5 feet, 1.5 inch. And from here to here, how much it is? It is not mentioned. But through simple mathematics, can I not do this? Very simple. Outer is 7 feet. So out of 7 feet, this is 7 feet. 7 feet minus 5 feet, 1.5 inch is going to give me the distance from here to here. This is understood. In the same way, I want from here, see, this is my center again. From here to here, how much it is? It is already mentioned here. It is already mentioned. It is showing 3 feet. And in the same way, from here to here, it is mentioned 3 feet. You can see it here. So it is mentioned 3 feet, and it is mentioned 3 feet. 3 plus 3 is 6 feet. So overall, this is 6 feet and this is 7 feet. So this much is clear. So just for our reference, I'll take one more drawing and we'll try to understand that. And then we'll get to the practical aspects of this. Right. Again, this is F5 footing. Very good. So how do you understand the size of the footing? So it is mentioned here that you have to provide a footing size of 8 feet 6 inch. So it's mentioned 8 feet 6 inch. Very good. And where is the center of this? This is the center for me. Yeah, the center is here. So you can see the two grid line meeting. That is a center for me. And from the center, how much I have to take on the left side? Again, it is mentioned here. From this center to the left side, it has to be how much? 3 feet 7.5 inch. And from this center to the right side, it has to be 4 feet 10.5 inch. Very simple. Now, if I come to the other side, where is the center point? Of course, this is the center. So I'll come here. From here to here, how much it is mentioned? 4 feet. Very simple. From here to here, how much it is mentioned? 4 feet. What is the overall size of my footing? The overall size of my footing is 8 feet from here. I mean, outer to outer. And from here, it is 8 feet 6 inch. Right? So it's very simple. We understood how to do this. So practically how you do this on the site. So we'll go back to that now. So there is a separate course of mine on reading all this structural drawing. I've taken around 6 to 7 different structural drawings, and I've explained you all these things. There's a course by name Learn to Read Architecture and Structural Drawing like an expert. If you know what you're supposed to do is, just in case if you're interested to learn, you can go to Udemy. Right, Akshay K will get around 7 to 8 courses of mine, and out of that there's a course which comes drawing reading. If you're interested, you can learn it from there also. Okay, there I have explained in more depth. Here whatever is required for the sequence of the construction, I'm explaining it here. Yeah, so now we'll go back to this. Right, you got it. And before that on the site, what we are supposed to do on the site, we need to draw these grid lines first. So we understood how to draw the footing, but before that, see, you need to understand how to draw this grid lines on the site. Yeah. Yeah. So what I'm going to do, see here, all these are my grid lines. So you can see a grid line here. Let me try to drag that grid line. Yeah. So this is one grid line. Okay. So this B is another grid line. This C is another grid line. So we need to do this grid line marking on the site. Okay. Another grid line, and this is another E grid line. So first we'll mark this grid line on the site, and then we'll take the other one. That is one grid line we have it here. No? We'll draw it on the site in this way. Then the number 2 grid line we have, we'll draw that. Then we have number 3 grid line. We'll draw this. then we'll draw number 4 grid line, then we draw number 5 grid line, right? So you got it. This is how you have to do practically on the site. Now how do you know the distance between the grid number A and grid number B? Again, it's very simple. It already mentioned here, you can see 4 feet. Yeah, you can see it here, 4 feet half inch from A to B grid line. From B to C it is 5 feet 8 inches. Good. From C to D it is 4 feet half inch. From D to E it is 14 feet 6 inch. Good. Similarly, from grid number 1 to grid number 2, the distance is mentioned here. So distance is 17 feet 4.5 inch. You can see it here, right? 17 feet 4.5 inch. Then from 2 to 3 it is how much? 4 feet 9 inch. Okay, 4 feet 9 inch. Then it is 5 feet 1 inch, 4 feet 0 inch, and so on, whatever is mentioned in the structural drawing, right? So this is 5 feet 1 inch and 4 feet. So with this, can't you do the same marking on the ground? It's very simple. So I'll explain you how it has to be done now. Okay, I hope this is clear up to here. So we'll go back to that now. Yeah, so now you look at this guy. So what these people are doing, no, they already kept the stone. So this stone will act like a grid line for you. To put it in a better way, see, let us consider, I'll write it first. Let me consider this particular stone, what I have it here, right? So I'll give the name to this stone as A. Yeah. Yeah. It's not visible. Okay. So this is A. This is B grid line. Okay. You can see the stones kept there. B. This stone represents C grid line. This stone represents D grid line. Then let us say this is E grid line. Okay, I'm taking some, we'll continue with this and then we'll say this is F. Okay, understood? In the same way, on the other side also it will happen. Now, horizontal is done. We'll come to the vertical now. For the vertical, what I'm supposed to do, we'll go with this. Yeah, I'll give a name to this particular as 1, grid line 1. We'll give this as grid line 2. You can see the stones kept, isn't it? So the stones are kept in the same way, like whatever distance I showed you between the two grid line, the same is kept practically on the side. And for the same drawing, this particular marking has been done. 4 and this is 5. Got it? So this is how you have to do. This is how you have to do it. Again, if you want, let me draw the grid lines to that. So this is 1. Then from here to here. Okay. Then we'll go with this. Okay. No issues. Maybe if I'm missing, it's okay in this. So you got an idea. These are the grid lines, what you do practically. So this much is clear for us. Yeah. Next, after this, what we are supposed to do, then this is that center point. The, like, let us say this is grid number A. Let us say this is grid number A. Okay. And this is grid number 1. Okay. And now exactly what is the center? This is the center where it is meeting. I'll show you the practical video of this. Till then, just wait for some time. We'll understand the basics and then we'll get into that. So where is the center of this? This is the center. Good. And from the drawing, it will be mentioned right from here towards the right side. From here. From here to the right side, it has to be, let us say, 3 feet. From here, it has to be 4 feet, let us say. Again, from here to here, it has to be, let us say, 3 feet. Again, from here to here, it has to be 4 feet 5 inch. So in this way, whatever is mentioned, we are going to do it on practically on the site. Okay, same. Again, here also it is same. Okay, from here to here, some distance will be mentioned. From here to here, the same, some distance in the same distance. Whatever you did, whatever marking you did here, right? The same you'll do it here. Whatever you did from this center to this outer, same you are going to mark it here. In the same way, you are going to do it from this center to here, from here to here. So once you do this, this entire will be a footing size, whatever footing size was there on the structural drawing, no? So the same you are going to get. This entire will be a size of the footing. Is it clear up to here? Yeah. Yeah, right. Hmm. So we'll see. So whatever I explained, this is the next activity which is carried out at the site after all the preliminary things are done. That is, once you remove the trees, the whatever trees, small plants were there, you are completely cut off. And if you're supposed to do the filling, you're going to do the filling. If you're supposed to do the cutting, you're going to do the cutting. Next, the surveyor gives the center line of the each footing, and the site engineer, with the help of a string, that is dory and tape, carries out the line out at the site. Like whatever I explained, no, that center line, right? Like these two are the grid line. The center, this will be given by the surveyor in bigger projects. In the smaller projects, I'll tell you how it has to be done practically on the site. And then, as a site engineer, I'm a site engineer. I have a structural drawing with me, and I know from this center it has to be 4 feet. From here it has to be 3 feet. From here it has to be 6 feet. From here it has to be 4 feet. I know to read the structural drawings. Based on that, I'm going to do the execution on the site. So each lines are drawn by looking the footing layout from the drawings, and the marking of the line is done with 3, 4, and 5 method. Now, what is this 3, 4, and 5 method? I'll explain you in the upcoming slides, right? So finally, once you do all that marking, this is how your footing looks. Now, for a time being, let us consider this is my F1 footing. Okay, let us consider this is my F2 footing. Let us consider this is my F3 footing. Let us consider this as F4 footing, and so on. How did I write all those things? Again, those things will be written in the structural drawings. Like you can see, F3, F5, F3, F2, F2, and whatever was written here, practically the same has been executed on the site, right? I hope these things are clear up to here. Yeah, so I've taken a small drawing here, and quickly we'll try to do that. By this time, you have developed the knowledge of how to read the structural drawing. Quickly try to do it on your own, and I'll also explain how it has to be done. So what the surveyor will give? The surveyor is going to give the grid line, that is your grid line A, and the grid line 1 is intersecting here. The surveyor is going to give this center point. Now, with the help of tape, what you're supposed to do, you are going to draw this grid lines, and we know the name of the footing is F1. And what is the size? From here to outer, it has to be 500 mm. In the same way, from here to here, it has to be 500 mm. The same marking I'm going to do on the side. Similarly, from here to here, it will be 500. From here to here, it will be 500. You got this distance, 500 and 500. Now we'll go in this way. That is, we are going to go this way. This way we are going to go, right? This way. So again, it is mentioned here that from here to here, it is 475 mm. Again, from here to here, it is 725 mm. You're going to do 725 mm marking. Here you are going to do 475 mm marking practically on the site. Again, 475 from here and 725. And finally, this is the size of the footing, what you are supposed to get on the, what was written in the structural drawing. And the same you are going to do the execution on the site, right? And that's how the footing size is. So entirely, this is 1 meter by 1.2 meter is the size of your footing. So again, these are the grid lines in a more animated way. So you're going to put the, with the help of this chalk powder, okay, you're going to put the grid lines, and this is how the grid lines are. Okay, let us say this is A and B, and let us say 1, 2, and 3 are the grid lines. And in this way, then all these footings you can see, footings you're going to mark it practically on the site. So finally, this is how your entire site layout looks once you're done with everything. So this is one site what we have. This is how the marking has been done. We can see it here. Here another marking has been done. Now you have got an idea, right? So you can see it here. These are your grid lines, right? The one which is drawn here, no? See, this is the white one, right? So these are your grid lines. These are your, let us say, vertical grid lines, let us say. And for the horizontal, let us consider these are my horizontal grid lines, the one which has gone in this way. You can see this grid. They are not drawn completely, but it's okay, right? So these are your vertical grid lines. Same thing you can see here, no? These are your grid lines in this direction, and these are your grid lines in this direction. Yeah, these are your grid lines in this direction. Got it? So this is how you have to understand the structural drawings, and this is how practically things are done on the site. Now, one thing we did not understand. The thing is that whatever I explained you, it's correct, but the way of marking is not like this. There's a concept called as working space. So we'll try to see what is the working space all about, why we need to understand. We'll also try to understand the bill of quantities for the what is that, the scrapping works. Like I told you, to cut the trees and all, right? So there's something called bill of quantities. It will be written like what is the total quantity you have and what is the price quoted by the contractor and how he is going to do. We'll try to see both of these things, and then we'll try to see the entire video of practically on the site how this entire layout has been done. So I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So in this lecture, we'll try to understand what exactly is a working space all about, right? So like I mentioned, whatever we studied is correct, like how to understand the drawings, the footing dimensions will be given. But there is a concept called as working space. We'll try to understand. Say this is a grid lines what we have. Okay. Now let us consider this is the size of the footing what is given to me. So yeah, so instead of this, yeah, yeah. So let us consider this is the size of the footing what is given to me, and let me take some size of the footing here. So we'll consider this to be, I'll speak in terms of meter now. Let me consider, okay, these two dimensions. I'll write it here. Yeah. So text. So this dimension, let me consider it to be 4 meter. And this dimension, no, let me consider this to be 2.5 meter, right? Sure. Yeah. Good. Now, this is the actual size of the footing. But when we do the excavation, okay, when we do the excavation or when we do the marking on the center line marking, this is not the exact size what we are supposed to take. What we are supposed to take is that, so understand that once we do the excavation, we are going to put the PCC, and usually the offset of the PCC will be either 75 mm or 100 mm. Now what exactly is PCC? We'll try to understand that, but now just understand, once you do the excavation, you're going to put a PCC, and that PCC will be at the offset of either 75 or 100 mm from the outer face of the footing. So here let us consider it is at the outer face. From the outer face of the footing, it is at a distance of 100 mm. So if this is my outer face, let us consider if this is the outer face of my footing, from here I have taken 100 mm extra. I've taken 100 mm extra from here. I've taken 100 extra from this side. On all the four sides I have taken it. Okay, on all the four sides I have taken 100 mm extra. Then what will be this size now? So what will be this size? So what will be this size now? And what will be this size now? Previously, what was the size we had? Previously, it was 4 meter. You can see it here. I've written 4 meter. But for 4, I'll add 100 mm, because from here you can see, from here it is 100 mm, and also from here it is 100 mm. So how much it will come out to be? Yeah. So how much it will come out to be now? It's very simple. 4. I'll write it once again. Yeah. It was 4 meter previously. Okay. Plus 0.1 on the left side, 0.1 on the right side. So 0.1 I am taking, 100 is mm. I'm writing in terms of meter. So 100 mm in terms of meter, it is 0.1 on the left side plus 0.1 on the right side. It comes out to be 4.2 meter. So this outer to outer, it is 4.2 meter. In the same way, here how much it will be? Again, we know this length, if you understand, see, this was 2.5 meter, isn't it? Now I need to add 0.1 on this side and also 0.1 on this side. So that will give me the total distance. So again, I'll write it here, 2.5 plus 0.1 on the upper side, let us consider, and 0.1 on the lower side. So it will come out to be 2.7 meter. Okay, good. Now we reached up to here. But again, after this, now there comes a concept of working space. So that means whenever we do the excavation, no, again we have to take certain distance from this outer, that is this is the outer face of your PCC. If you understand, this is the outer face of my PCC. From here I'll take certain distance, from here I'll take certain distance here, and also from here I'll take a certain distance, even from here I'll take a certain distance, and also from here I'll take certain distance. So how much is that distance? We'll try to see what is that distance. Now again, that distance is usually we take it as 300 mm or 0.3 meter. So from here it is 300 mm, 300, 300 and 300. So now you tell me what will be the total distance that you're supposed to mark. That means what I'm trying to ask you is, I want to know what is the total distance from here to here, from this outer to this outer, what is the total distance, and also from this outer to this outer, tell me the total distance. Very simple mathematics we need to apply. Already we know it is 4.2 meter up to this orange surface, that is outer of PCC. 4.2 plus 0.3 on the left side, 300 mm in terms of meter, 0.3 meter plus 0.3 meter. So quickly do this. 4.2 plus 0.3 is 4.5, 4.5 plus 0.3 is 4.8. 4.8 meter. And also on this side, if I try to do, we already know it is 2.7 meter. Where is this 2.7 meter? From here to here it is 2.7, but I want from here to here it is 0.3 extra, from here to here it is 0.3 extra, right? So I hope you are able to understand. So we'll directly write 2.7 plus 0.3 on the left downside and 0.3 on the upper side. It comes out to be 3.3 meter. Now this is the actual marking that you're supposed to do on the ground, and not this marking. Like this marking what we are doing, no, like I told, it has to be 4 meter and this has to be 2.5 meter. This is not the marking what you're supposed to do. Of course the size of the footing is 4 meter by 2.5 meter, but when you do the marking on the side from the center line, you're not supposed to do this marking. Instead you have to do the marking of 4.8 meter on this side, and this has to be your 3.3 meter. Okay, got it? This is how it has to be done. And from the center, how much it will be? It's very simple. See, now just in case if you have confusion, let me strike out everything. Let me say, I told you now that this is 4 meter, isn't it? I told you that this is 4 meter and this is 2.5 meter, right? Let me write it here. This is 4 meter and this is 2.5 meter. Good. Now you may have a confusion from here to here how much it is. Now for time being, let us consider, I'll take some random values. No, there is nothing much in that. Let us say from the center line to here, it has to be 2.3 meter. We'll do in that way. And from here it has to be some, let us say, okay, let us say it is 2.6 meter from here, and remaining 1.4 meter will be on this side. You're getting my point. And this is 2.5, isn't it? Now in this 2.5, in this is 2.5. I'll do it. From here to here I want to know, and from here to here I want, it is 2.5, isn't it? But it is in the center. So I'll take this as 1.25 on this side. Okay, and this is 1.25. Got it? So this is how the send. Now to do the overall calculation, it's very simple how you have to do what you are supposed to do, right? 2.6 plus from here it is 0.1 and from here it is 0.3. So from here to here you can get the distance, isn't it? If I put it in a very simple way, what I'm trying to tell is, if I want the distance from this center line, let us consider from this center line to this outer, can I not find the distance? It's very simple. How do I do that? See, I know already 2.6 is from here to here, that is 2.6, plus this from here to here it is 0.1, right? And from here to here it is 0.3. Let me do that and we'll see whether we end up with the same answer, right? So we get 2.6 plus 0.1, 0.3 is it comes out to be 3 meter. And also from here, how much you're supposed to get, we'll do that. From here to here I want, right? So how do I get that? Very simple. I know it is 1.4 meter from here to here, right? So you can see 1.4, isn't it? I'll put it here. Yeah, let me write it here. Yeah, I know it is 1.4 up to here. This offset of PCC is 0.1. Is 0.1, and then from here to here it is 0.3. Try to do it manually along with me. So 0.3 and 0.1 is 0.4, so it comes out to be 1.8. So 1.8 meter. Now what will be overall? Overall will be very simple. Try to add everything. It's simple. Overall I want to find from here to here. How do I get that? Just add it from the center on the left side. I'm getting 1.8, and towards the right I got 3 meter, right? Exactly. What is the answer I'm getting? 4.8 meter. And this is what we got exactly in the beginning, right? If you don't if you're having a doubt, if I just remember this value of 4.8. Let me write this 4 point. No, I cannot do that. Okay, you're getting my point. And this is 4.8. And initially, if I go back, let me quickly go back like, yeah, you can see how much we had got here. We had got 4.8, isn't it? Here now also I got 4.8, right? You got an idea how this has to be done. So this is a marking you're supposed to do. Now, why this marking has to be done? That is the first question. And why did I say you have to take it as 300 mm and not 400 mm? We'll try to find the reason behind this. So first, try to see this practically how it looks. So you can see this space, no? This is that working space. See, this is your footing. This is your footing. Then this 100 mm is this offset. This is that 100 mm on this side. This is a PCC. This is also your PCC. This on this side also you have PCC. Here also it is PCC. That is 100 mm. And then this distance what I'm marking, no, this is a working space from here to here. This is 300. From here to here, this is working space. From here to here, it is working space. From here to here, it is working space. Got it? So this is how it looks practically on the site. Now we'll see one more point. See, so in local construction, what they do, no, they don't give this working space because they don't believe in this. So, and also they don't put the shuttering here directly, they pour the concrete, which is not the right practice to do. When we work in bigger companies, this is the standards we are supposed to follow. You can see it here now. Now you'll get an idea. See, where is the working space? So we have this working space here. Here also we have it. It's not visible. And from here also here, we have this working space, right? Why this working space has to be given? If this working space is not given, you can see this is called as shuttering. Whatever the plywood boards, what they have kept it here at 1, 2, this are called as plywood boards. And for this, you are given these props. These props you are given as a support. If you don't give this working space, these laborers, they can't stand here. And if they cannot stand here, they cannot properly keep this shuttering board here. So this is called as working space. Working space for whom? For these laborers. So we call this as a working space. So if we give that enough space, like 300 mm, these people can stand here. They can put the shuttering board here. And also you can see the props here. These are the props what you are given for the support. You can keep it there so that there will be a good rigidity to this formwork. On the either side, look here. Here also we have supported it, right? So this is the main idea behind this working space. Yeah. Now you got it, right? So when you do the marking, you know how much offset you have to take. Now coming to the main question, where is this things written that we have to take 300 mm? So we'll try to see where exactly it is written. So if you become a building engineer and all, we have certain code books to follow. Okay, now I'll take you to IS 1200 1992. This is a code book, and what is written here? It is written methods of measurement of building and civil engineering works. So part 1 is for the earthwork, that for the excavation, how we have to take that offset. So directly I'll not go for everything. I'll directly show you here. See what is written. If you go to 4.2.5.1, authorized working space shall be special in each case. Where authorized working space is not so specified, the following shall apply. What it is written, 600 mm working space you are supposed to take according to Indian standard 1200 code book. But practically, it all depends what is written in your BOQ, what is given by the client. Otherwise, this is a one way. You can take 600, but usually in practice, we don't keep it as 600. 300 is a minimum thing what we try to go. Other than that, there's one more CPWD specification. Suppose if you are from India, we have a Central Public Works Department. Let me write it here, CPWD. It's called CPWD, which is called Central Public Works Department. I'll write it at DPT. Okay, Public Works Department, CPW. According to them, if I open here and you can see it here, so they have written measurements, right? In case of open footings up to the depth of 1.5 meter, all round excavation of 30 centimeter beyond the outer dimension of the footing shall be measured for the payment to make the allowances for the centering and shuttering. Any additional excavation, remember the word, any additional excavation beyond this limit shall be at the risk and the cost of the contractor and shall not be measured for the payment. Okay, we'll forget about the payment. Just understand it is mentioned here 300 centimeter. That is why I have taken 300 mm. Right? Just in case if it is not written directly, if it is written in your BOQ that you have to take 200 centimeter, we'll take 200 centimeter. If it is written no, you have to take 400 centimeter, we'll take 400 centimeter, right? But just before the start of the project, all these things will be told to you what should be the working space. and based on that we are going to do. So where exactly I have taken 300 it is from this particular code book of CPWD. I'll show it here. Yeah, so Central Public Works Department specification volume 1 2019 from the government of India, and under this they have written it here. Okay, and that is why I have taken 300 If it is 400 500, if it is 600, you can take accordingly whatever is written in your bill of quantities. If it is not written, you can directly take from this particular code book and say this is where it is written, and that is why I have taken 300 right? So I hope you have got a clear idea regarding this working space, how it has to be understood and all. So in the next lecture, we'll try to understand the practical video of this. We'll also try to see BOQ, and then we'll try to proceed in the same way. So I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. In this lecture, we'll see how a practically centerline marking has to be done. We'll break this lecture into two parts. In this lecture, we'll try to see, and even in the next lecture, we'll try to understand the remaining part. So straight away, first I'll explain you with the help of a structural drawing, and then we'll look into the practical video of this. So this is that drawing what I have, and for the same drawing the centerline marking has been done. First we'll try to understand. It will take some 5 to 10 minutes in the beginning, and then we'll straight away get into the video of this. So we know all these things, right? This A, B, C, D, these are the vertical grid lines, and this 1, 2, 3, 4, 5, 6, these are my horizontal grid lines. So whatever grid lines you are able to see it here, the same grid lines we are supposed to do it on the ground, right? That's the first thing. Now practically how they do it, let me give you an example for that. So usually in the real field, what they do is, wherever we have these grid lines, right, we are going to keep the stones over there. That stone can be a laterite stone or whatever stone. Okay, so I'm keeping one stone here. You can see one more stone here. I mean, you can see the grid number 2, isn't it? You have to keep on both the side. Okay, so I'll keep it here. Then again you can see 3 number here. I'm going to keep one more stone here. 4, I'm going to keep one more stone. 5 grid line, I'm going to keep it here, and 6. Okay, on one side it is done. Now the question may come, how do they try to keep this center to center distance? Now whenever they put this stone right over that, they are going to keep hit a nail over this. I'll show you practically. You have to take a nail and you have to hit the nail on this stone, and once you hit the nail, then with the help of a tape, what we can do, with the help of a tape, we can measure that distance, right? That is, you can see from here, from this center, okay, to this center, what is the distance given here? It is mentioned you have to keep 17 feet 4.5 inch. You can see it here. In the same way, if I go to the next one, see here, from this center to this center, what is mentioned? It is 4 feet 9 inch. It has to be 4 feet 9 inch. You can see 4 feet 9 inch here. And from this center to this center, it has to be 5 feet 1 inch. From this center to this center, it has to be 4 feet half inch. And from this center to this center, so what is mentioned here? It is mentioned 16 feet 0 inch, isn't it? So it's mentioned here 16 feet 10.5 inch, right? You got it? So in this way you're supposed to do it. Now I've explained you on the one side, isn't it? So we'll do the same stone marking on the other side as well. Quickly we'll try to do that. Now again I'm going to keep my stone even on this side. Again I have a grid here. Okay, I have a grid here, here and here, right? So one horizontal side we have done. In the same way, let me do it on the vertical side as well. Now for the vertical side, this is my A grid, isn't it? I'll keep one stone here. This is B grid. Again you can see the center to center spacing there, isn't it? So it is 4 feet half inch. This is 5 feet 8 inch. This is 4 feet 0.5 inch, and from here to here it is 14 feet 6 inch. So one side I have done. On the same, in the same way I have to do it on the other side as well. So I'm doing the same thing. Again this center to center distance is 5 feet 8 inch. This is 4 feet half inch. Okay, this is 14 feet 6 inch. Is it understood? So up to here you are supposed to do it. Next, we know that, like I mentioned, we have to nail it here, isn't it? I told you that we have to put a nail here, right? In this way we are going to nail it. We are going to nail it here. Okay, we'll nail it here. Similarly here also we are going to nail it. Here also we are going to nail it. So once that is done, next what we are supposed to do, we are going to take a thread. Okay, we in local language we call it as line dori, and then you are supposed to tie it from this nail to this nail. You try to tie it, so that will be your center line. If I do it exactly from this center to this center, you can see this dotted line. It's the same marking what you're supposed to do on the ground. Again, from this nail, this center line, you can see the dotted one. So this is the center line, it's meeting here. Similarly, this center line is meeting here, isn't it? Similarly, this center line is meeting here. You have to do that again from here to here, again finally from here to here. So one side I have done, I'll do the same thing on the other side as well. Again from this center line to this center line. So I'm going to tie the thread on either side, and this is how my all the center line will be prepared. Got it? So this is how your center line you are supposed to prepare. So once this is done, all the alignment will be done. Next, what we are supposed to do, you can see the footing here, isn't it? You can see the footing here. See, this is the size of the footing what they have mentioned. So whatever is the size of the footing, you have to do it practically on the side. Now from this center line on this side, what is the distance? It is mentioned here. If you can observe it here, just pay attention. So you can see something written here. It is written 3 feet and half inch. From this center to this side, it is 3 feet half inch, and from this center to this center, it is 3 feet 10.5 inch. What is supposed to do? From this center to here, you have to mark 3 feet half 1.5 inch. From this center to here, you have to mark 3 feet 10.5 inch. In the same way, from this center to this outer, you have to mark 4 feet 1.5 inch. This distance is not mentioned, but from 6 feet overall, the size of the footing is 6 feet on this side. So if you deduct 4 feet 1.5 inch, this much whatever is the distance left, now you are supposed to get it, right? Now I didn't explain about the working space. We'll try to see the working space and all later. Along with this, what you're supposed to do as an engineer, site engineer, you have to apply one particular rule that is called as 3-4-5 method. So what is that 3-4-5 method? Let me explain it here once, and then we'll see the same thing happening on the ground. So in 3-4-5 method, you will measure, on the 3-4-5 method, you will measure from here 3 meter. Okay, whatever it can be, 3 meter or 30, what we'll consider 3 meter. From here you are going to measure 4 meter. Okay, now what I need to do, I need to make sure when I check the diagonal, that is, this is a diagonal, isn't it? For this particular triangle, this becomes my diagonal. So, and if I write it here again, if this is my 3 meter and if this is my 4 meter, sorry, if this is my 4 meter, my diagonal should be 5 meter. How is this 5 meter? Simple. We know Pythagoras theorem. The Pythagoras theorem, if I do it here for the Pythagoras theorem, so let us say this is that, okay, and then this is that other one, and we'll say, so this is how it is. So what the Pythagoras theorem says that, so if I give a name to put it in a very better way, let me give this as A. We all studied all this during our school days, isn't it? This is A. We'll say this is this as B, and this particular point as C. So the Pythagoras theorem says that whatever is your distance, whatever is your distance, the square of this distance plus the square of this distance should be equal to this, isn't it? That's it. So if this is 3 meter, if this is 3 meter, and if this is 4 meter, then obviously this will be 5 meter. How is that? So simple. What is 3 square? AB square. If I want to write, I'll write in this way: AB square plus BC square. This has to be equal to AC. Okay, so that means what is AB square? AB square is 3 square, so I'll write 3 into 3 plus what is BC square? So it is 4 into 4. So what is the answer for this? 3 plus 3, it is 9, and I'll write 9, and 4 plus 4 is 16. So if I add this, you are going to get 25. And whatever is a square, now the answer is that AC, it is a square root of AC. Okay, so I'll write in this way, square root of AC. So what is square root of 25? If I write what is under square root, in the sense under root of 25 is equal to 5. So that is how I should get the answer. This answer should be 5, right? I hope your fundamentals are clear up to here, and whatever I explained here, right, the same thing we'll see with the help of a practical video, right? I'll play a video and just observe it. Yeah, first what these people will do, these people are going to keep the stones like I mentioned. You can see one stone being kept here. So in this way you need 3-4 people to do this activity, and then he is going to nail it. Okay, you can nail it anyway, provided when you keep it, make center to center distance between the nail according to the structural drawing what is given to you. So we'll put a tape to that, and from here we'll measure it. Okay, I'll try to go a bit forward. So you have to measure this distance. Okay, first we'll see what is the distance we are getting, and then practically we'll see what we are supposed to get from the structural drawing. So what you can see, then it is written 32 feet. If you observe it, let me show it once again. So what is written? It is 32 feet, isn't it? Did you observe that? I'll go a bit backward. Yeah, so you can see it's 32 feet, isn't it? Now we'll go back to the structural drawing where this guy is actually doing the work. Is you can see from here, see here, from this outer of the footing to this outer of the footing. Okay, what is mentioned here in the structural drawing? 32 feet. So that outer to outer he has given. Okay, you can do it from grid to grid. Okay, this guy has done from outer to outer, but usual practice is we will do it from grid to grid. Okay, that is how we are supposed to do it. Okay, yeah. Now whatever distance he is measuring, right, this distance, so this is this particular distance, he is going in this direction. Now he is going in this direction, that is from here. Okay, this overall distance is 58 feet 6 inch, but that is from outer to outer. He has to take it from this center to this center. So if you're not able to understand, see, this distance is outer to outer and it is 58 feet 6 inch, but we are supposed to do the marking from the center to this center. Then what you are supposed to do, whatever is that particular offset you have, that is 5 feet 7.5 inch from here. Okay, and 4 feet 9 inch from here, you take it out, that is 5 plus 4 is 9 feet, isn't it? 5 feet from here, 5 feet from here, 4 feet from here is 9 feet is out, and in 9 feet again this 9 inch plus 7.5 inch, almost you have to deduct 10 feet, somewhere rough to 10 feet 5 inches. Let me consider, that means out of this 58 feet 6 inch, 58 feet 6 inch, you have to deduct roughly around 10 feet 6 inch. Okay, I didn't calculate it exactly, but we'll say 10 feet 6 inches. So roughly you are going to get somewhere close to 58 minus 10 is 48, somewhere close to 48 feet you have to get the answer. Okay, and we'll see what this guy is going to do practically on the site. So you are getting somewhere close to 48 feet. Yeah, like I mentioned, you see what is that you are getting 48 feet 1 inch, and this is 1.5 inch. If this was there, it was 2 inches. Okay, so we are getting 48 feet 1.5 inch, right? Yeah. So and we also did the same thing. Like if I go back, yeah, like I mentioned, I told you we are supposed to get 48, somewhere close to that. Okay, maybe this was like 10 feet 4 inches in that case, or 10 feet 4.5 inch. In that case, you are going to get 48 feet 1.5 inch, right? Yeah, you can do it the same calculation. So once that is done, next what these people will do, they will put the thread, and like I mentioned, you have to do that 3 4 5 method, isn't it? Because you need to check whether the lines whatever you have put, whether they are perpendicular or not. So we have an instrument for that called as right angle. With the help of the right angle, we'll try to see whether my line whatever grid line what I have put, whether it is at a right angle, or let us say it is perpendicular to each other. So I'll show you how it is done. So this guy is tying it here. Yeah. Okay, so these stones you can keep it anywhere. Okay, it is like, see, how do you do all these things? Whenever you have any plot, let us say this is a plot what I have. Okay, this is the entire plot, and now you have planned that your building will be somewhere here, okay, this is the place where you're going to construct. Based on that, you're going to say, okay, this is my starting point. I'll place my first grid line here, second grid line here, third here, fourth and fifth. Okay, so it depends where exactly is your plot and in which area you are supposed to do the work. And why is that they have connected this thread to this thread? There is nothing like that. So this thread, whatever thread, you can see it here, this thread is your x direction grid. Okay, let us consider which is going, and this is your y direction grid. Okay, now why is that this connection has been made? Because sometimes what will happen, we have to, now right now we have done, we have kept the stone, but that's not exactly at the center to center distance. So sometimes you need to move your stone here and there, so that exactly you're going to get center to center. In that case, if you move this particular stone, no, accordingly you can move this particular stone also. So that is why what we do, we try to connect this in this way. Okay, and there is no much concept in this. Only the thing is, for our easiness, we have connected the thread from here to here, so that if I move this line, no, exact alignment I am going to get. So that is why we have done it. Okay, so we'll tie it on the other side. Okay, is it done? Understood? So this was the first grid line what we have done. This was the one grid line from here to here, and next we have, sorry, yeah, from here to here you have one grid line you have, and this is another grid line. Okay, now what you're supposed to check, both these grid lines should be right angle to each other. That means both this should be 90 degree, this should be 90 degree, both the lines. Okay, so how do you check that? For that you have to check with the help of a right angle, and we'll see that how this guy is doing that. So this is called as a right angle. I'll write it here. So it is called as right angle. Okay, so with this you are going to get that 90 degree and check whether your line is perpendicular or not. It is called as right angle, and this is how you are supposed to keep it. Okay, this is the intersection, isn't it? This is the intersection of my grid. So if there is small variation, this guy will instruct the guy on the other side to move the stone here and there, so that exactly the 90 degrees. So this is how you have to keep it. So he's telling to move on the other side. Okay, see the small variation, how exactly you need to get this. Finally your line should be in this way. Now you can see this line is slowly tilted in this way, isn't it? There's a small gap in between this. So by the time he fix it, you have to get a straight, this line and this line should be perpendicular to each other, and that is the angle between them should be 90 degree. Okay, That is how it has to be done. So almost it is on the line. The slight variation is there. So this guy will move the stone here and there so that exactly the 90 degree will be formed. So now it is almost there. Yeah, now you can see almost it is perpendicular, the horizontal and the vertical line, and that's how a 90 degrees got. So this is a first criteria you are supposed to do. So once this is done, next we'll try to see how that 3 4 5 method will be applied. Okay, so yeah, so we'll see this 3 4 5 method in the next lecture, because this lecture will become a bit longer if I try to explain everything in the same lecture. So we'll see from in the next lecture from the here itself how the 3 4 5 method is done. So we'll see you back in the next lecture. Thank you. Yeah, so we'll see from here how this 3 4 5 method will be done. From here he is measuring some distance, so this distance we'll see what he is measuring. So this distance he is measuring it as 8. Okay, so you can see a small yeah, you can see a small thread kept here. Like last time I forgot to mention, usually when you prepare this 3 4 5 method practically on the site, isn't it, like 3 6 3 4 5. So how they do is that on this particular end, since it's a very big line, I have shown a small line, but practically what will happen, this line will continue, isn't it? So you don't know where exactly you have to mark it. So what these people do, they take a small thread and they tie it here. Okay, so this is there, let us say 3 meter marking, this is there 4 meter marking, got it? And when you try to keep the tape from this end to this end, that is a diagonal, you should get that 5 meter. But here they are not taking 3 4 5, they have taken a different number, but we'll try to discover what exactly the number they have taken. So this is 8 we have got. So small you can do the adjustment. Okay, because see, now you are getting small adjustment this guy is doing, no, exactly on the 8 he is trying to keep it. Now I'll try to explain the logic behind that. See, these people are taking a number of 6 8 and 10. Okay, so why is that? Again same thing, if I try to put this in the form of yeah, so let us consider this is 8 he has taken. Next he is going to take 6, and then his diagonal will be 10. This diagonal he is going to get 10. So how is that so? So let us consider this was 8, this was 6. Okay, and how do you get this diagonal? You multiply this 8 square, 8 into 8, okay, and plus 6 into 6. So if I do this, 8 8 is 64 and 6 6 is 36, and 64 plus 36 comes out to be 100, but I'm supposed to put the square root of this, and square root of 100 comes out to be 10. So finally when you check the diagonal, you should get the answer for the diagonal as 10, and we'll see whether we are going to get 10 or not. Okay, so on the other side is checking now. So that guy is fixing that small thread. Okay, it can be any thread, there is no hard and fast rule, you can take anything. Just put a small string there anywhere you can put. Later you keep the tape and measure that from the intersection. Okay, wherever is the grid intersection, there you have to keep. And now you can see it is 6 meter. Why it has to be 6 meter? Because we are applying a 6 8 10 formula, so it is at 6 meter. It's not meter, I guess. Just understand the number, that is enough for us. Now how much this has to be there? This has to be 10 for us according to our logic. 6 square plus 8 square comes out to be 100. 100 square comes out to be square root of 100 comes out to be 10. So this guy is getting somewhere close to 11. Okay, you saw that? Maybe he has to, it's not 11 actually. We'll see that. Yeah. So now you can see, right, exactly whatever I was explaining you. Practically you can see the same thing, a same kind of diagonal they are checking. So this guy is getting 11, but that should not be the case. Now slight changes they have to do. Okay, yeah, now it is fine. So now you can exactly see that 3 4 5 method here, right? So this is that, then comes this one, and then finally comes this one. Got it? That's how it has to be done. So why this has to be done? To make sure that whatever center to center distance we have kept, or whatever 90-degree we have kept, no, it is exactly matching or not. All these are the preliminary checks that you're supposed to do. So once, if you are perfect with the 3 4 5 method and that 90-degree, 80% of your work is done. Okay, so now we'll go forward a bit. So again the same thing has to continue. Now which direction is taking? He is taking the other direction now. So right now whatever is marking, you can see, stretch the tape. Yeah, this particular marking you see, we'll see what is the distance he is going to get. So how much is getting? Again 32 feet. Right now we are on the other side. Like, if you understand, first we started here. Okay, let me give you a small idea. First we started from here. Yeah, so first we started from here, it was 32. Okay, then we measured this distance, that is from this center to this center we took, and now again we have measured this 32 feet. Okay, from this outer to this outer we have measured. Now again what you are supposed to do, from this center to this center, or this outer to outer. Actually I'll tell you what happened actually here when we were doing this practically. And this guy who was doing, he forgot to deduct this. Actually this 32 feet what you are getting, isn't it, this is from outer to outer. He actually was supposed to take it from center to center, that is from this column center to this column center he should have taken, but he did it from outer to outer. But later we did the deduction of this 1 feet 10.5 inch and 1 feet 10.5 inch, and finally we took this center to center. Okay, that was a small mistake we got, but because you can see it here, from this center to this center we had taken. That might have come in your mind, if you are taking center to center, then why is that you took this outer to outer? Otherwise you should have taken this outer to outer. Okay, right, but we took center to center here. I don't know what happened to the contractor. He maybe he was out of his mind. What he had done is he had taken from this outer to outer, but later we realized that because we were not getting the exact it was not matching, so later we did a small change, and then we took this inner to inner distance. Okay, so that is how we had done. That's a small mistake what we did, but it's okay, we later understood that. So just try to put center to center, that is enough for you. Okay, so this is 32 we have taken, actually it was not to be 32. And now the last part is doing, which is that last part. I'll go quickly to the drawing. This is that part. Okay, this part, that is 58 feet 6 inch what you're getting, that is outer to outer, but we want to direct this 4 feet 9 inch and 5 feet 7.5 inch. So we are going to get this center to center, this center to this center we are supposed to get. Okay, and same thing they are doing it practically on the ground. So you can see now, see 47 feet 1.5 inch. If you remember, in the previous case also we had got 47 feet 1.5 inch. How is that possible? Because out of this 58 feet 6 inch you have to deduct this. Okay, deduct this 5 feet and 4 feet, it comes out to be 9 feet, and 9 feet, then if I add 3 to here, it comes out to be 10 feet. So it has to be 10 feet you have to deduct, it will come out to be 48, and 48 minus some 10.5 inch you have to do, so it will come out to be 47 feet 1.5 inch, and practically you can see 47 feet 1, and this is half inch of this. Okay, got it? So I'll upload the same drawing for you for your understanding, so that you can go through that. You can take a printout and then you can start understanding this. Okay, so I hope so far your concepts are clear, and so once that is done, no, you have to do the threading, like you have to put that line like I mentioned, no, with the help of this now what exactly these people are doing now. So far we have done outer to outer, like if you remember what we have done so far we have just put this outer to outer stone, isn't it? That means we kept one stone here, we kept one stone here, next we kept one stone here, then we had kept a stone here, then we kept one stone here, isn't it? Now you can see the inner side, this stone is missing, that is 14 feet 6 inch, this 4 feet 0.5 inch is missing, then this 5 feet 8 inch is missing. In the same way, in the center all these things are missing, isn't it? That also you are supposed to do. So now they are doing the same thing. Okay, so now you can see this is that particular intersection what we have got, like I mentioned in the beginning. Let us say this is grid number A and this is grid number 1, so this is intersecting at this particular point. And same thing practically, if you see right now we are in this point, that is grid number A, and this is grid number 1, and the point where we are intersecting is this particular point. And practically same thing, this is that intersection what we have got. Okay, so we'll go a bit forward. So now here they are doing this marking, so we'll see what exactly marking this guy has done. Yeah, so you are getting somewhere close to 14 feet 6 inch, you can see 14 there, and we'll see in the drawing where that 14 feet 6 inch is mentioned. So you can see now this guy has started marking it from here, that is from this center to this center, it has to be 14 feet 6 inch, right? So the same marking we are doing now, this center to this center. In the same way, from this center to this center it is 4 feet half inch, from this center to this center it is 5 feet 8 inch, and this is again 4 feet half inch. So whatever values are mentioned here, isn't it, the same you can see it here. So you can nail it anywhere, provided when you keep the stone, isn't it, you keep it exactly. So this is at 4 feet half inch. Yeah, you can see exactly 4 feet half inch here kept. Okay, so we'll go forward again, and this is the final last one, I guess. So this has to be some 5 feet, yeah, I guess. Yeah, 4 feet, this is 5 here, and this is 5 feet 7.5 inch, isn't it? So we'll see the drawing if we are not wrong. Yeah, almost 8 inch it is. 5 feet 8 inch. Yeah, they have done 8 inch only. Yeah, it is here, right? So exactly. Yeah, so got it. So in this way you are supposed to do it. And the finally this is the last one. Yeah, now like I mentioned, you can see it here. Now you see here what is written, 28 feet and 3 inches, isn't it? I'll tell you what is the error that we made. Now we are getting 28 feet 3 inch. Like I mentioned, initially this guy had taken 32 feet. Initially had taken outer to outer, it was 32 feet. But like what we need from this center to this center. So how we did that? Again, out of this 32 feet, you can see the small offset here, this thing, and also on this side. How much is the distance on both the side? 1 feet, 1 feet 10.5 inch, 1 feet 10.5 inch, 1 feet and 1 feet, 1 feet, 1 feet comes out to be 2 feet, 2 feet 10.5 inch and 10.5 inch. Okay, so if you do all these things, you deduct that out of 32 feet, you take one, you remove 1 feet from here, it comes out to be 31 feet. Again 1 feet you take out from here, how much it comes out to be? 30 feet. Again in 30 feet we have 10 inch, 10.5 inch and 10.5 inch. Half inch comes out to be 1 inch again. So 10 inch is 20. Again it is 21 inches, right? 10 inch plus 10 inch is 20. Half inch, 20.5 inch, half inch. So it's 21 inches. So again 21 inches in terms of feet, how much it comes out to be? We know that 1 feet, see, you have to be good in all these things. 1 feet is equal to 12 inches. Okay, we are getting 21 inches. So how much it will be in terms of feet? You try to divide it. That's it. 21. If you divide it by 12, you'll get somewhere close to 12 to the 24. You will get somewhere close to 1 feet. Let us say 10 inches, somewhere close to that. Okay. Now finally, if you deduct all these things from 32 feet, yeah, let me do it only. Yeah, so I'll do it here manually. Okay, I have a calci with me. I have a calculator. So what I'll do? 32 feet minus 1 feet, I'll write in this way. 1 feet, how much it is? 10.5. I'll write in this way. Okay, 1 feet 10.5 inch minus 1 feet 10.5 inches. I'll convert everything in terms of inches. So 1 feet is 12 inches. 32 feet in terms of inches will be how much? 32 into 12. Okay, minus 1 feet from here, 1 feet is 12 inches. Again 1 feet from here is 12 inches. So 12 24. So again I'll put in this way, 24. Okay, and for this 24 I'll add. Okay, I hope you are able to understand, and let me not make you people confusion. So we'll multiply this 32 into 12. I'm getting 384. Okay, so this is 384 inches minus, you can see 1 feet written here. You can see 1 feet. So what is this 1 feet and 1 feet? 1 feet is 12 inches. Again 1 feet is 12 inches. 12 24. So I'll deduct 24 inches. Again minus, you can see 10 feet 5 inches. Sorry, 10.5 inch and 10.5 inch. 10 inch and 10 inch is 20 inch. 20.5, 20.5 and 0.5. So it comes out to be 21 inches. So now try to do all this manually. If I do it, 384 minus 24 minus 21, I'm getting 339 inches. Now everything is in terms of inches. Okay, so but I'll convert this in terms of feet. So how do you convert? So 339, if I divide it by 12, because 1 feet is 12 inches, I want in terms of feet. So if I divide it by 12, I'm getting 28.25, and I can say this as 28.3. What is that? Feet. And now you see practically what has happened on the side. You can see 28, 1, 2, I'll clear everything. 28 feet, 1 inch, 2 inch, and see 3 inch. He has taken 2.5, isn't it? Roughly has taken that. It's okay. Small error here and there. Got it? So this was a mistake what we did. Initially I told you to take 32 feet, but later we realized that we're not getting that correct measurement. So that is why we did it. And on the other side also we are doing the same thing now, because there also we had taken 32 feet. Now again, whatever mistake we had done, for that we are paying the penalty. And finally you can see here, if I go back a bit, on this side also we have got it. Got it? So 28 feet 3 inches. Got it? So I hope your concepts are clear up to here. So we'll go a bit forward, and now after this yeah, so all these things he is marking now. Okay, that whatever center to center we were supposed to get, no, we are marking all those things. So again, this is 4 feet half inch is marking. You can see 4 feet half inch. Where is that? It's here, 4 feet half inch. And same thing on this side also. Both the side you have to do. Here also it is 4 feet half inch, 5 feet 8 inch, 4 feet half inch, 14 feet 6 inch. Okay, whatever distance you are measuring on this side, same has to be measured here. Whatever you are measuring here, same has to be here. Okay, so that is why it is taking time for you. Shall go a bit forward. So 14 feet, whatever distance we wanted. Okay, 14 feet 6 inch is marking. Okay, got it? So we'll go forward now. I'm moving a bit forward because it's the same thing. We'll not waste our time here. Again, this is 7 feet marking they are doing. 7 feet 10.5 inch. So where is this 7 feet 10.5 inch? We'll try to look it. Yeah, we're not getting that. It's okay for us. Yeah, no issues. Okay, on this side is doing now. I hope you are able to understand. So it is that 5 feet marking what you're supposed to do. The slight arrangement you have to do in this way. Where is that? Which is this marking is doing? This one. Yeah, you can see here, no, this center to center. You can see this is 5 feet 1 inch. From 3 to 4 grid, you have to maintain this 5 feet 1 inch. Okay, so that is why they are doing that. Again, this 4 feet half inch marking it is. So I'm running a bit forward. Finally you have to, now everything is done on all the 4 sides. You have kept the stone, and finally you're going to pass the thread. You can see, right, all the 4 sides you can see the stones now, left, right, on the other side, and finally you'll pass the thread through that. Okay, and then finally whatever is the drawing, based on that you are going to do the execution. Yeah, so now we'll try to see all these things in the next lecture. Again, it has been almost 22 minutes of a lecture, so we'll see the next part in the next lecture. So we'll see you back in the next lecture. Thank you. Yeah, so this is a plumb bob what you can see. So I'll go a bit backward. Yeah, so this is called as plumb bob. So what you do with the plumb bob, so whatever line I have here, right, so this is my, like, see, this is the center what I have got, and now I know from this center I have to take certain distance to this side. From here I have to take, let us say, 3 feet. From here I have to take 3 feet. From here I have to take, let us say, 4 feet. From here I have to take 4 feet. Now how do you take this 3 feet? I know that 3 feet is coming somewhere here, so this level I have to transfer to the ground. So that is why with the help of this instrument called as plumb bob, we'll transfer the level. Okay, that is what it's trying to do. So we got a point here. Okay, so on this point he'll try to put that, he'll measure That is the center now. Okay, for this it is center. From here you'll measure on this distance, this side how much you want, and on this side how much you want it. They have to do it properly, but in a hurry they are doing it, but it's okay. Try to understand what exactly we are doing it. So that is our point. From there, let us say in the drawing it was mentioned you have to take 3 feet. From that point we'll take 3 feet. Okay, so let us say this is that particular marking you what you wanted. This is the other side you have done. Okay, so one is done. In the same way we'll do it on the other side. Okay, the same thing you'll do on the other side. So I'll show you one particular thing. See, this is how you transfer it. Okay, so I'll show you one particular footing where exactly they have completed it. Now you may find it a bit difficult to understand. I'm just going forward and I'll show you the exact footing where they have completed completely. Yeah, so we'll try to see for this particular footing. Okay, concentrate. 4 feet. So now you got an idea how they have done it. So 4 corners they have got, and with this they'll mark it. Yeah. So you got, no, this is the outer one, this is another outer, this is another outer, and this is another outer. So finally this was your center line. From the center line what was given to the right, left, on this side and this side, finally has done everything. So in this way all the footings you are supposed to do. I'm explaining you for one footing, but practically on the site when you do the execution, no, for all the footing you have to follow the same method, and that's how you're going to complete one by one all the footings. So got it? This is how it is supposed to be done. Okay, now they are doing it for other footings. We'll not concentrate on that. Finally I'll show you how it will look once everything is completed. See, this is another footing what they have done. Okay, got it, no? See, two are done, then they are doing it on the other footing. Okay, now this particular footing where it comes, this is that particular footing. So right now he is doing this particular footing because it is on this edge. Okay, F1 footing, which is 5 feet 6 inch and which is 6 feet, and this was your center line. From this side it is 3 feet, from this side it is 3 feet, from this center to this side it is 1 feet 10.5 inch, from this center to outer this is 4 feet 4 feet half inch, and practically this is how it is. Okay, so almost 3-4 footings they have completed. So again the last footing that is also done. I'll go a bit forward. Yeah, so this is one more footing that is also being done. So right now this particular footing what we are looking, this is this footing, this footing it is, that is F4 footing. Okay, it is F4 footing and it is a 7 feet and this is 7 feet 6 inch. So for this 7 feet it is 3 feet 6 inch, 3 feet 6 inch on this side. So that is this one, this is 3 feet 6 inch on this side, and from here it is 3 feet 6 inch on this side, and from here to here we'll see the distance. Yeah, again from here to here it is 3 feet 9 inch, from here it is 3 feet 9 inch. Okay, so finally you can see all these stones kept, no, like whatever I mentioned, same thing you can see it here. Okay, so again I'll go forward, again it's the same thing. Okay, finally I'll show you how it looks. So again this is one more footing has done. Now finally they are doing that combined footing one. So this is that combined footing, like if I show you, right now we have done all the footings. So this is one footing which we have CF1, combined footing 1, CF1. So this shape we need to get on the side practically, and all the measurements will be given, like from this center to here how much it is, this to this how much it is, from here to here how much it is 3 feet, from here how much it is 5 inches, from this center how much it is 3 feet 4.5 inch, from this outer to this center line how much it is 3 feet 9 inch, because this center line we have drawn. From here to here it will be mentioned, from here to here, here to here, everything will be mentioned, and practically we have done it. Moving a bit forward so that we can see the complete footing once it is done. So you can get an idea exactly we are getting that particular shape now. So almost we have got that shape. Again one more thing, see, when you do such kind of work, no, usually in our place there's a tendency of cow coming and all. So usually what we are supposed to do, you can see all these stones kept here. So once you keep this stone, you have to cement it, that is with the help of cement mortar. You have to fix this point, because once you do the excavation, because after this we are going to do the excavation again, when we do the PCC, and after the PCC we are supposed to put the column starter marking, that is column marking we have to do. Again for that we need reference of this particular stones what we have kept. Again we have to do the same thing again, and then with the help of a plumber we have to transfer that level. I'll show you how that level will be transferred later. So that is why you just have to fix all these stones. You cannot simply keep it, you have to cement it, so that if there is any movement of cow or let us say any vehicle, this particular stone should not get dislocated. If they get dislocated, again it will create a problem. Again you have to start from the beginning itself. You have to properly check the center to center distance. So that is why always make sure you are going to cement it. Yeah, finally you can see the picture here. See here, finally you can see the shape whatever you have got it here, no, and same was mentioned in the drawing. See here, this is the shape what we have got finally on the ground. So finally all the footings we have completed, and this is the final thing what you can see. So right now whatever we have done it manually. Tomorrow when we work in a bigger companies and all, we don't adopt such method. We call the surveyor, and the surveyor is going to give us all the outer to outer marking, and then it will be easy for us to do it. Okay, we'll try to see that also, not a complete thing but a basic idea I'll be giving you how that is done with the help of a surveyor, and how the marking will be given by the surveyor. So you can see this is the final layout what we have, and also these were the starting footings what we have. This is your raft, and these are the outer footings what we have. This particular footing what you can see, 1, 2 and these three footings are these footings 1, 2 and 3, that is F1, F4 and F1 footing. Then we have CF1, and starting we have F3, F5 and F3 footing. We have F2 footing and F2 footing. So practically all the things you can see it from here, right? So these are the starting 3 footings, isn't it? That means these were those 3 footings, these are those 3 footings, F3, F5 and F3 footing. F3, F5 and F3, F3, F5 and F3. Okay, so this is how your building looks this is how your marking looks finally once you are done with everything. This is a combined footing, because a lot of columns are coming in that, so we call that as a combined footing. And these are the last 1, 2, 3 footings which we have it here, that is F1, F4 and F1, F1, F4 and F1 footing. So I hope you have enjoyed the lecture up to here. So this is how we do practically on the side, and we'll see you back in the next lecture. Thank you. Hello my dear students, welcome back to this lecture. In this lecture I'll show you how practically you're going to do the marking with the help of a total station. I don't have a complete video of this, but with the help of AutoCAD drawing and with one of the layout, I'll explain you how it is practically done with the help of a total station. So one thing we need to understand, see, you may find it bit difficult to understand everything. So all these things need not be done by you all the time, because when we work in a bigger construction project, so let us say you are working as a site engineer. Okay, so as a site engineer you don't have to do all this markings and all, like I'll explain you what markings, right? You don't have to do, but the thing is that you should know how it has to be done, and you should know how to read the drawings. So those two things I have covered so far, and I hope you are in such a position now to understand those structural drawings, how to understand the drawings. So in a bigger projects we'll be having a surveyor, right? So a surveyor is going to make use of an instrument called its total station. And with this he is going to give you all those points. Okay, so you don't have to worry how those points and all are coming, but as an engineer it's always good we know something what other people are doing, so that we at least have some idea, right? So that is why I'm trying to explain you. So first let me play a video of this. So here the entire marking has been done with the help of a total station. We'll see the marking, and for the same building I'll show you the drawing. So just we'll have a look at all these things. So this is one of the building which is happening in my place. It is a basement plus ground plus 4-story building. Now one thing you need to observe, you can see, okay, we'll go forward and then I'll stop. Okay, you can see all the markings been done here, isn't it? So all these are marking. Now what the total station guy will do, the total station guy will come and he'll directly give, you can see the rod pegged here, so he'll give you this point, he'll give you this outer point, he will give you this outer point, and he's going to give you this outer point. Now our task as a site engineer becomes very easy. Just what we are supposed to do, we need to, you know, connect these points in this way, in this way, in this way, and in this way, and the size of your footing is ready. So here you don't have to worry about that center point, offset on the left, offset on the right, and all, right? So these things directly he is going to give you the end point. Just in case if the surveyor is there, this is how the work will be done. Okay, you got an idea, right? See, all these are pegs what they put. This is one end of the footing, the second end of the footing, third end, and fourth end. See, actually there is a steel rebar inserted here and also inserted here. So this guy is hammering it down because if there is a movement of the vehicle, then the tire of a vehicle will get punctured, right? If I mean, also the vehicle movement cannot happen if you are keeping the rebar to this side. So this guy is hammering it and in bringing it to this ground level. Okay, that is why you cannot see the rebar here and also in this position. Yeah, right. So one more thing you need to understand, just observe on this part. Okay, I mean, you can see here a kind of a marking has been done. Here also they have done a marking. So I'll explain you what is that marking. So those marking are nothing but they are just the grid lines, but with help of a total station we have done. That is how we do. So all these are your grid system, like let us say A grade, B grade, C, and whatever we did, no, with help of a total station we have done it. For example, see, let us say this is my A grid, this is grid number A, vertical, isn't it? Now this is in horizontal, let us say this is grid number 1. So here on the what is this, on the soil itself we have done the marking, so that this will remain there permanently. Okay, as I mentioned, we don't want that to disappear after some time, because we want that at least our columns will come up. Till that point we require this. That is why all this marking have been done, right? So I'll go a bit forward. So just closely observe all those marking. All these are your grid systems. Okay, you can see how they have done the marking. See here. Yeah, everywhere, even here also you can see. See, here also there is a marking done, here also there is marking done. So all these are the grid lines. And how do you find those grid lines? What is a reference for that? I'll explain that through a AutoCAD drawing. Here you can see, here also, even here also, and here also. Okay, yeah. Okay, so finally this is the entire building what we have seen, and you can see even the grid lines have been marked here. Here also they have marked it. Okay, here also they have marked it, here also, and all these are your footings marking what they have done. Yeah, so now I'll pause it here. Now we'll get into the drawings of this. So we'll try to understand the drawing first. So this is that particular drawing, whatever building we are seeing, isn't it? This is a drawing for that. First try to understand, all these are the boundary line for them. The red one what you can see, isn't it? This is a boundary line. Okay, when you construct a bigger structure, you'll have a boundary line, and from there you are going to leave certain offset, that is according to the building bylaws. So this is entire, and here we have a 4 feet wide footpath, and all this are a building line which is the red in color. Now coming to the coordinates, see, now where are your grid systems? You can see the center line passing here, Let me show the center line. Where are those grid lines? Yeah, see here, you can see the one which is blue in color, isn't it? This blue in color, you can see this is a grid line which is passing to the center of this column. Okay, RC1 means this is the retaining wall we have. Will not try to get in so much detail, but whatever I can see I'll explain you. R stands for retaining wall. C is a column, that is a retaining wall column 1. Okay, so this is a starting point we have 0.0. Now from this center point to this center point, the blue one, the distance is 3.78 meter. So it comes out to be 3.78. Now from this blue to this blue we have 0.44. So what we have done is we have added this. Okay, that is 3.78 plus 0.44 will give you 4.21 meter. Next, from this grid line to this grid line we have 0.65 meter distance. So 4.21 plus 0.65 will give you 4.86. Similarly, now you know, now you are in a position, you know that this grid line to this grid line it is 1.60 meter, 1.27 meter, 1.51 meter, 2.09 meter. So in this way, for the whole building, no, they have done it, right? You can get it for whole building. This is center to center is 3.50, 4.10 and so on. Now in the total station, what they are supposed to do, we'll see that. See, for that particular building, this is the footing. Okay, you can see all the footings marked here. See, this is all footing here. Okay, this is all footing here, right? So you can see all these are the footings. You may find it a bit difficult if you are new to this particular drawing. If you already taken my drawing reading course and all, it would have been easy for you. So all these are my footing, and over this footing we have this column C18, C18 and all. Yeah, so now you can see something written here, 100.00, 100.00, then we have written 103.78, 104.214, 104.815, then we have 106.40, then we have 107.730, right? Yeah, so how we are getting all these numbers? Again, it's very simple. You have to take one particular point as a reference point. So here what they have taken, so this they have taken as a reference, like here, see, this is 0, this is the first grid line what I have, isn't it? So it is 0.00. so here we have taken RL has 100.00. okay, now from here next grid line is this one. So how it is 103.788? Very simple, 100 from here to here I'm moving at a distance of 3.78 meter. So 100.000 plus 3.7800, you add it, you will get 103.778. now from this purple, from this blue grid line to this blue grid line, the distance is how much? 0.44 meter. So for 103.778 you add 0.440, you are going to get 104.214. so all these are the readings what I am supposed to input in my total station. So whenever the total station guy will come and give the point, exactly the same point will be there on the side, right? I hope you have got an idea what I'm exactly trying to tell. Okay, if you are able to understand, well and good. If not an issue, not an issue, because it's a surveyor's job to be done. We don't have to be so much, you know, good in all these things, but at least a basic understanding is enough. I hope these concepts are clear up to here. Now we'll go back to the video and we'll see how it is practically done again. Yeah, so I'll go a bit. Okay, so yeah, now to get a better idea I'll stop here. So this is the first grid line what they have measured. This is the second one. Then after that we have third one. Don't look here, the one which you can see it here, no, whatever they have done it here, they have transferred that here. Okay, because whenever you want to do, because the construction should happen in this area, isn't it? So it's very difficult for a person to take a reading from here and transfer it here. That is why whatever reading you are able to see here, isn't it, here, yeah, where is that, here, the same has been transferred here. You don't have to worry about it. Now this is my first point on the drawing, which is that first point. This is that first point on the drawing. So if I come here, so this is that first point which they have written it here, 100.000, that is 0.0. This is the first grid line. In the side, this is my first grid line. Okay, got it, this one. Now from here to here, what is the distance? You go back to the drawing. From here to here it is 3.78 meter from this grid line to this grid line, and your RL reduced level is 103.778. so again on the practically, from here to here, from here to here it is 3.78 meter, and this is that second point what you have got. Okay, I hope you have got an idea. In this way all that marking has been done on the side. Now you see this guy is already done. when I went to take the video, it was already done. But look at this guy. This is how they are marking, and I'll tell you how practically it will be done. So in this total station, it's an instrument and he's a surveyor. So already has all the input in this particular machine. You have to input all those things, and you have to just give the value, and you can see one guy standing here. He'll keep it here, and from here a laser will be projected, and wherever the laser will point, no, that is your marking level. Okay, so I hope you are getting an idea what exactly I'm trying to tell. So in this way, everywhere the marking will be done. Now for the same thing, I'll explain you how this particular level, that is, you can see it here. See here they have done a marking, no, the same marking I want here on this particular point, and you see how this marking will be transferred to this particular point. Okay, yeah, now you can see it here. This guy is standing here, and this is my marking here. Okay, because I want the marking to be done on the ground, so I cannot take the level from here. Otherwise what should happen? I should put a plumb bob from here. I should put a plumb bob in this way, right? You should tie that line dory, then from here you have to drop that plumb bob, isn't it? You're getting my point. What is plumb bob? From here you will drop the plumb bob. So it's quite difficult. It's a bit tedious work, and the chances of error is more there in this way. So instead of doing that, we told the surveyor to transfer the level, this level, on here, so that it is easy for me to work on. So that is why the surveyor will have all the, see, now if you want this particular marking, what should the surveyor do? The surveyor has to go back. I mean, right now he is marking this particular point. Let us consider that is this one, 3.78, that is 103.778. so 103.778, he has already done the input to this total station, and then he'll give an enter button. From there you can see a laser coming out. I'll show you that laser now. Observe there. So you'll find a laser. Yeah, you can see a laser, how it is pointed. Yeah, now you see this is a red color, this is a laser. So this is that exact point which I wanted, that is a grid line. So once you project that, it will he has to adjust that. Okay, this is that exact point where we wanted, and once it is done, we'll insert a nail to that, or we'll give a small line to that. Okay, done. You're able to see that laser, it's blinking. And now we'll try to do a marking in this way practically on the side, and this will be permanently there throughout the throughout the construction has happened, or let us say at least till the time of a backfilling. We want this level to remain there. So this is how we have done it. So you can see the laser coming. Yeah, so that is a level, that is particular marking what I wanted. Okay, so in this way he is going to give another marking on here also. These people wanted another marking to be done here also on this side. So that is also being done by the, you can see here, no, see here also they wanted. So you can see the laser coming. So all these things will be done by the surveyor. Since it is a big building, we have taken help of our total station, but in the previous video it was a very small building, isn't it? So we have done with the help of line dory, that is with the help of thread and those stone, whatever method I have explained, no, that we have done. This is another point. It's the same point, you are transferring it below so that you can get a straight line. Got it? So now with this is my center line, okay, for this particular grid, let us say A, B, C, or whatever grid. Now again they wanted one more here also. The same thing they are doing, the same they are transferring it here. Okay, from they wanted one here also. Why is that they wanted one there? Now you concentrate here. If I go forward a bit, yeah, a bit forward, a bit forward. Yeah, so you can see some numbers and all are written here, right? All these numbers are these things, whatever is there in the drawing. All these are coordinates what they wanted. Anyhow, when I explain you how to do the footing marking, the column center and the footing marking, I'll explain you. There you have to make use of these values. Like you can see here, this is my column. Okay, for the column he has given a number 163, 164, 165 and 166. So while doing a column marking, he'll give this outer to outer lines, and we'll try to understand. I'll explain you there how this is practically done in a more better way. Okay, yeah, we'll go back. So you can see a lot of numbers coming here. So this is the input what you have done to the total station instrument. So this is processing. So once it is processing, he'll project it there, and with this you can set it. The laser you can set with this. Yeah, you can see some numbers are written here, right? 100.003, you can see it. 527, see 100.003. Okay, so in this way, whatever we wanted, no, exactly how to infill, you can see here east, north, and what is the height, everything will be done here. Yeah, got it. So in this way, wherever marking us, now you can see it here. I go a bit. Yeah, you can see everything. East is 100.002 meter. This is north marking. All these things they are going to input, and based on that, you'll get the answers. I mean, he's going to give you the marking. Similarly, that they wanted some marking here also. This guy is doing that marking. Okay, so I hope you have enjoyed the lecture up to here. In the upcoming lectures, we'll also try to understand how this column marking will be done and all. So I hope at least you have understood how we have to do it manually with help of 345 method, and also we understood with help of instrument how we have to do. So now to put it in a better way, this is a very big project. Okay, the project what right now what I'm showing you, it's a basement plus ground plus 4-story building. So in that case, we don't want to do this by manual method because it will take long time and chances of error is also more. So that is why we have brought in this surveyor, and we have told him to give the drawing, I mean the reading. Whereas in the previous, this was a very small structure, not a very big structure. Hardly it is 1200 square feet. So in this case, we did not want this surveyor to come, because the surveyor will charge around 6500 to 8500 rupees per day for the 8 hours of the work. I feel they're going to charge you this much amount. So we don't want that amount to be spent on this particular building. So that is why I taught you how to do it manually, and always we should learn manually, and only then with the help of instrument it is easy for us. So our fundamentals should be clear always. So I hope your fundamentals are clear, and you know how the marking is to be done manually and also with the help of an instrument. So we'll see you back in the next lecture. Thank you. Hello my dear students, welcome back to the lecture. In this lecture we will try to understand how the excavation has to be done on the site. So far we understood how the center line marking has to be done. So once this thing is done, we are supposed to do the excavation and take out the quantities. I mean take out the soil from the ground. So we'll see that how it has to be done. So excavation is done so that the footing is laid at a suitable depth from the NGL, where NGL stands for natural ground level. Wherever you are standing, if you go out of your house and the ground wherever you are standing, no, that is called as NGL, which we call as natural ground level. The excavation is done till the hard strata is obtained, so as to rest the footing and transfer the load to the soil. So we should understand how the load transfers happen in a building. So let us consider this is a slab, right? The gray color, what you can see, this is my slab. The one which is yellow in color, this one is called as a beams. And then the vertical elements, we call this as a columns. And finally, the brown one, what you can see, no, that is my footing, or you can call it as foundation. Depends what exactly you're doing there. And then you can see the vertical arrow mark over there. That is actually the reaction coming from the soil. See, one thing we need to understand, whatever load comes on your building, everything has to be taken care by the soil. So soil is going to give you the reaction. This is the action you are putting, the entire load, and from the soil, the reaction is going to come. Okay.
That means it depends whatever depth I'm supposed to do. It depends on the condition of the soil, how much capacity my soil has to take it, right? So it depends on the soil. So always understand the load will travel from the slab. From the slab, it will go to the beams. From the beams, it will come to the column. From the column, it will come to the footing. And the footing is going to distribute that particular load over the soil. This is how the load transfers happen, right? So this is how you are supposed to do the excavation. You will be calling in the JCB or a backhoe, and he's going to do the excavation, right? You can see whatever marking we had done, the footing marking we had done. So that much amount of soil will be excavated by the backhoe, and with the help of a tipper we are going to dump the soil wherever space we have. Okay, so this is how the excavation is done, and you can see a lot of excavation has been done. Let us say in our particular drawing what we had taken, we had roughly 3 and 3, we had around 10 footings, right? Now let us say the 10 footing excavation has been done here. Okay, now next question comes, how much is the depth of the excavation that you are supposed to do, right? When we are doing excavation, we should know what is the total depth we are supposed to do. We'll try to see that how much is the depth we are supposed to do. Whenever you refer any structural drawings, you'll be getting a cross section something like this. This is called as a cross section. Whatever I'm explaining, just concentrate on those things, forget about all other things. We'll try to understand them in a due course of a time. So there's one level which is called as EGL. EGL stand for the existing ground level. I'll write it here. EGL stand for existing ground level. Okay, whatever is a ground level that you have, it is an existing ground level. That's the first thing what we have. After that, where EGL stand for existing ground level, then we have NGL. NGL is called as natural ground level, and sometimes we write ground level. All three are one and the same. There's a slight variation, that's it. Natural ground level in the sense wherever is a level you have, you come out of your house, wherever whatever level you have, no, that is my natural ground level. Existing ground level is also similar to that. Sometimes we may do a filling wherever you are out of your home, right? If you come out of your home, that is a natural ground level what we have. But sometimes what we do a filling. Okay, maybe we don't want the rain road, we don't want the water from the road to come inside, right? That means my plinth level is little down, so I'll add little few more amount of soil, and that will be my existing ground level. Okay, there's no much difference in that, and few people call this as a ground level, right? This much is clear for us. Now you can see something written here. See, from this EGL level, how much is the depth of the footing that you're supposed to excavate, that is written here. So what is mentioned here, minimum 1.5 meter or up to hard soil. So here they are given minimum 1.5 meter excavation has to be done, otherwise up to the hard soil you have to do. So that is why what we are going to do, we are going to do the excavation till 1.5 meter. Now sometimes what will happen, if you're working for a bigger projects and all, big residential projects, big industrial projects, all this depth will be given by the geotech consultant. See, we have two types, we have many types of engineers, but for our discussion we want two. One is a civil engineer who will take care of all the work at the site, and whatever drawings we are seeing it here, like the foundation sizes, the column sizes, all those things will be given by the structural engineer. And then there is one more engineer called as geotechnical engineer. So geotechnical engineer is going to study about the soil, what kind of soil is there, how is the quality of the soil and all, because ultimately the load has to come and it has to get transferred to the soil, right? So first we need to understand the behavior of a soil. So a geotech consultant will come, if it is a very bigger project I'm speaking of, they're going to take a sample of the soil and they're going to do a test on that, and finally they're going to come to a conclusion, for this particular area or for this particular soil or for this particular plot, you have to do a depth of excavation up to 2 meter, or let us say 2.5 meter, right? In this way they are going to mention it in the geotechnical report, and based on that we are going to do the excavation. But if it is a normal G+1 structure, okay, not a G+1, if it is a normal structure and all, and uh, if the soil is very good, in that case we don't have to do this geotechnical investigation. Through our experience we can come to a conclusion that usually for a small house G+1, G+2 and G+3, if the soil is very good, we can go up to 5 feet or 6 feet of excavation is a very good excavation. So that is why they have mentioned it as 1.5 meter, that is 1 meter is 3.2 feet. So almost it is roughly close to 5 meter of the 5 feet of the excavation has to be done. Okay, up to the hard soil. Until we get a hard soil, we have to do the excavation. Okay, I hope this much things are clear for you. Yeah, so once you do the excavation, this is how it looks finally. You can see it here. This is the excavation what we have done, and this is the depth of the excavation that we are supposed to do. So let me go in this way. Let us say this was my breadth of my footing, and this, wait, let us consider this was the length of my footing, okay, and this was the breadth of my footing, and finally this is the depth of my footing. Whatever depth I was supposed to excavate, no, that much depth I have done the excavation, right? So I hope you are clear with these points. Now coming to the main point, yeah, we'll see even this also. So finally, when you do the excavation, no, this is how it looks finally. You've done the excavation. Let us say 1, 2, 3, 4, 5, 6, so many footings you have, and you have done the excavation. Now we'll come into the main question. That is, we'll try to see different structural drawings, how it is mentioned. So I've taken one drawing here. It is mentioned schedule of footings. And this is a section where we need to concentrate. See what is the depth of the footing. So if I come here, you can see they have written NGL, which is called as natural ground level. And from there, they have given an arrow mark. I mean, they have shown it in this way. You have to do an excavation of 5 feet. You can see. So for this particular project, that is what is the name of the project they have written here. Okay. The client name is so and so, and this is the project what they're doing. For this particular project, you have to do an excavation up to 5 feet. So what you are supposed to do, you are doing an excavation up to 5 feet. In the same way, I'll show you one more drawing. We'll see here. This is a one more drawing what I have. Okay. And here what is mentioned here, this is GL. It's one and the same. See here they have mentioned GL, that is ground level. From there to the bottom of the PCC, what they have mentioned, 6 feet minimum or up to the hard strata. They have written. That means for this particular building, they have found that they want to do excavation up to 6 feet. So you'll do excavation up to 6 feet, right? Got it? Similarly, we'll take other cases as well. Okay, I'm taking different drawings just to make you clear with all these things. Again, you see here in this particular project, they have written this is NGL, which is called as natural ground level. And what they have mentioned, from the natural ground level to the bottom of the PCC, it is mentioned you have to do 1.5 meter, that is 1500 mm, or 1.5 meter of excavation has to be done. Got it? Forget about all the things, all these things, you don't get confused. Already explained in my drawing reading course, but as we proceed with the course, I'll be explaining a bit about all these things. Complete understanding of a drawing is quite difficult in this particular course. There's a separate course taken by me by the name drawing reading. In that course, I've explained all these things, and there we are actually concentrating on how to read the structural drawings in a more better way. Okay, but for our understanding, this much is enough. In the same way, I've taken one more drawing here. Now again, we can see what is mentioned here. Again, it is mentioned GL. Again, from here to the bottom of the PCC, it is mentioned 5 feet minimum or up to hard strata. So you are going to do the excavation up to 5 feet. Okay, I hope this many drawings are enough for our understanding. Anyway, we'll take another two drawings. Again, this is one more drawing I've taken. It's a school building what I have. Again, what is mentioned here, see here, again they are written NGL, that is called as natural ground level. And what is mentioned here, 1500 mm or up to hard strata. That means from here you have to do an excavation of 1.5 meter. And finally, I'll take you to one more drawing now, where we had done the total station marking, right? So this is that particular project where we had done that total station marking, right? For that particular project, what they have mentioned is, see, this is that level. From here to the bottom, that is up to the top of the foundation, they have written depth of excavation less than 2.5 meter or as per soil test report. But for this particular building, like the total station building what I shown you, there we had conducted the soil test, and through the soil test they gave us a report that you have to do a excavation of nearly it was nearly about 10 feet, yeah, nearly about 8 feet of excavation we had done. Okay, 8 feet of excavation we had done, and based on that the execution was carried out, right? So I hope you got an idea about all these things, that how we have to do the excavation. We have done the marking. After that, you have to call in the excavator, and in the drawing it will be mentioned whether you have to do the excavation for 5 feet, 6 feet, 7 feet, 1.5 meter, or whatever. Just in case, sometimes what will happen, even after doing excavation of, let us say, 5 feet, if you're not getting a hard soil strata, maybe you have to excavate another 1 feet. Okay, but that you have to take a call with the help of a structural engineer. You have to contact the structural engineer, saying that we are getting a soft soil there, and in that case we can try to excavate another 1 or 2 feet, so that we are going to get the hard soil strata. Most of the time we get it. Okay, otherwise you can do the soil investigation, and you can come to the conclusion. For the smaller projects, usually we don't want to spend on the uh, soil testing, because again they are going to charge you like 15-20,000 rupees. So that is why, based on the experience and based on the neighboring plot, we can have a discussion with them. What is the depth they are taken. Of course, it depends on building to building. You cannot let us say your neighbor constructed a G+1 building and you want to construct a G+5 building. In that case, whatever depth he has taken, you cannot take the same depth. Since your height of the building is more, you're constructing a more floor, more load is coming, then you have to get in the geotech consultant and get your soil tested, right? So I hope I was able to convey most of the things in this lecture. Now, yeah, so now you have to tell me, we have done the excavation. Now tell me, what is the total excavated soil that we have got? You can see a lot of soil has been stored here, right? So what is the total quantity of a soil that we have got it here? So just think on that, how you can calculate that quantity of a soil which we have excavated. So in the next lecture, I'll be explaining you how to understand the bill of quantities, and also will explain you how you can calculate the quantity of this particular plan, like how you have to measure all these quantities. So I hope you enjoyed the lecture up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to this lecture. So in this lecture, we will understand what is bill of quantities, and also we'll understand how to calculate the excavation quantity for that particular footings. Okay. So first we'll try to understand what is BOQ all about. So I'll take you to one of the Excel sheet. So you can see it here. What is written? It is a bill of quantities. You can see it here. Yeah, what is written? Civil BOQ. Let me, yeah. Yeah, you can see here what is written. Civil BOQ is written. That stands for bill of quantities. Let me write it here. So BOQ stands for bill of quantities. So what is this bill of quantities? See, whenever you take up any construction project, before we start with the construction project, we'll be knowing the entire details of the house and all, right? And we also be knowing what will be the total cost, coming to approximate cost that is going to come, right? So we have to prepare. So what all activities we have? Let us say you want to construct your own house, you're going to do the excavation. If you want to do the excavation, you want the labors or you want the excavator to come and take out the soil, right? So you're going to pay to the excavator, right? Once you're done with the excavation, next you're going to lay the PCC. For that you require concrete, and to prepare the concrete you require cement, sand and aggregate. Again, for those people you have to pay. How much is the total quantity? What is the money required? So all this is called as estimation, right? To put it in a very better way, let us say there's a function in your home. Okay, I'll write it here. There's a function in your home, and let us say you have a plan to invite your friends and you're arranging for a lunch or a dinner. Now you want to find out what is the approximate cost that is coming. Now let us say for the decoration you're going to pay, let us say 50,000 rupees for the decoration, right? And for the lunch or for all the food and all, it will cost you, let us say some, some, I'm taking some rough value, 75,000 rupees. Okay, 75, yeah, 75,000. Okay, then decoration is done, lunch is done. Let us say for the sweets you require some 10,000 rupees. Okay, now all these things are the amount that you require, isn't it? All these are the amount that you require. Now for the decoration, under the decoration, what flowers you're putting in, what kind of decoration you want, based on that you're getting this 50,000. In the same way, for the lunch it is 75,000. So how many people are coming? Let us say the cost of one plate for the lunch is, let us say 200 rupees. So how many people are coming? Based on that you are coming with the total cost. For the sweets, now in sweets we have many kinds of sweet. Let us say you're giving one laddu, and the cost of one laddu is, let us say, 8 rupees. Okay, right? So all those things you are specifically telling that you want this particular laddu, or let us say you want this particular item for the lunch, right? Based on that you are coming to this final amount. In the same way, when we take up any construction project, we'll have a one person who is called as a quantity surveyor. Is going to take out the quantities of all the materials that is required for the construction project, and based on that is going to quote the road rate also. Now who is going to quote the rate? Let us say, I'll put it in a very better way again. Now let us say I want to construct a house. All right, so I don't know whom to give. I don't know for which contractor I need to give. So I'll be telling that I want to construct a house, and maybe let us say 4 to 5 different contractors are going to come. Let us say we have a contractor A. We have a contractor B, we have a contractor C, we have a contractor D. So each contractors will come and they'll say, I'm going to take up your work. Now I'm going to give them the quotation. I'm going to say them, this is the house I want to construct, and tell me your rate. Like for example, we'll put it in this way. Okay, remember A, B, C, D are the 4 contractors. Now for the what are the first activity we did in the entire this thing? Yeah. Yeah. So what is the first activity that we did in our project? That was about the clearing our land, isn't it? So you can see here, civil works is written. Under that, earthworks is written. So what is written here? Clearing and grubbing road land, including uprooting the rank vegetation, grass, bushes, shrubs, saplings, and trees girt up to 300 mm, removal of stumps of trees cut earlier, and disposal of unserviceable materials and stacking of serviceable materials to be used or auctioned, including removal and disposal of top organic soil not exceeding 150 mm in thickness, complete as per the specification by manual means, and so on. What does it mean? That means you want to clean that complete area. Like if you imagine, if you remember, initially we had taken a site, isn't it? We wanted to clean that, so we had deployed the excavator and all. Now 4 contractors are there. 4 contractors are going to give 4 different rates. So this is a one particular rate given by the contractor. So when we work in some bigger projects and all, we apply for the tendering, right? We say that this is a project we are interested to construct. So different contractors participate, and whoever's rate is little less, first thing. Second, coming to the technical specification, how that contractor has performed in his previous project, right? All those things will consider and will award the project to that particular contractor. So that contractor will give you a rate for that particular work. I'm going to quote this much amount of rate. Now for this particular work, the contractor has given that he is going to charge 52,788 rupees for the hectare. This cleaning work what we have, no, usually if it is a small project, we consider that in terms of square meter, but here they have taken it as hectares, right? Now in your particular project, what is the total quantity that you have? You have 0.27 hectares. Now can I not find the total amount that is required? I know the total for 1 hectare, it will, they will charge you 52,788 rupees. I have a 0.27 hectare. If I multiply 52,788 into 0.27, I'm going to get the total amount. Got it? So this is how the activity has to be done. Now this rate and all will be worked out by the contractor. Different contractors are going to give different rates based on their requirement, right? It's simple. Let us say I want to buy a pencil. So you go out of your home, you have 4 different stationery shops. One is selling the pencil for 3 rupees, the other is selling the pencil for 4 rupees, the other is selling the pencil for 3.5 rupees, the other is selling the pencil for 5 rupees. So which one is good for you? So what you're going to do, you're going to go and take the pencil. It's the same case here. Only the thing is here will have a contractor, have a specified format to that. All those things we are going to do it in a construction project, right? Now we'll come to the earthwork. Now come look here. Now what is this number? See, all these numbers will be written in your uh, PWD, whatever DAR we have, right? In that, in the schedule of rate, all these things number will be written there, item number, what exactly according to the PWD department these numbers are. We can go and verify there. Anyhow, this is not required for us, just concentrate here. Again, what is written? Earthwork excavation for all type of soil, for foundation of buildings, culverts, water supply, sanitary lines, and electrical conduit, either in the pits or in trenches, 1.5 meter and above in width, in ordinary soil, including dressing the bottom sides of pit and so and so. That means if you want to do the excavation, the contractor is quoting a rate of 305.64 rupees. So it will hardly come out to be how many dollars? It will come out to be 730. It comes out to be around $4 for us, right? $4 to $5 it comes out, because dollar rate in India is 75 rupees. So if I do that, 75 into 4 comes out to be, yeah, it comes out to be around $4 for me. The contractor is quoting $4 for this, or let us say 305.64 Indian rupees, and the unit is in cubic meter. What is the total quantity of excavation I'm supposed to do in my building? So I have 1,130 cubic meter of the earthwork excavation to be done. Now to get the total amount, what you're supposed to do, whatever is the quantity I have, that is 1130, you multiply that by the rate, you're going to get this. So if you want, you can try to do it manually. Multiply 1130 into 305, you're going to get unit tens 100, yeah, 3,45,373 rupees, right? So let me do it manually once. Yeah, I'm getting 3,45,373 rupees. Got it? So these two things, this is how you have to prepare all these things. You don't have to prepare. Again, we have a quantity survey. A quantity survey will take care of all these things. But again, we know how these things are prepared. Now I'll teach you how these quantities are to be obtained, because even as a site engineer you should know how to calculate these quantities. So we'll try to get into that, right? So for that we have to prepare Excel sheets in this way, and based on that we are going to do workout. So all these things I've covered in one of my course by name site engineer, by the name of quantity estimation. If I take you to that, see, this is a course what I have by name quantity estimation, building BBS with Excel and CAD. If you're interested, you can learn all these things in a more detailed way. Anyhow, here I'll give you a small idea about how it has to be done for one or two footings. Rest you can learn from here if you're interested to learn here. Okay. Anyhow, we'll go back to the main part. Yeah. So just concentrate here. Again, you have to write it in this way. We'll be writing a serial number, description of the work, units, length, breadth, depth, quantity per number, total numbers, and total quantity. Now let us say I have a footing, F1 footing. Okay. From where do I get all these things? Again, same thing. See, if you go back, let us say I'll take one AutoCAD drawing. Yeah. So all these are the things you get in the structural drawings. You can see here F1 footing is written. The size of the footing is 1500 mm by 1500 mm. That is 1.5 meter by 1.5 meter. Similarly, F2 footing is 2 meter by 2 meter. F3 is 2.5 by 2.5. F4 is 2.8 by 3.3, and so on. All these are my size of the footing. So I'll take one example here. Then we'll do one or two problems from here for our better understanding. Right now, just concentrate here. Yeah. So what is mentioned? The name of the footing is F1 and the size is 3000 mm by 4200 mm. If you want to put this in meter, it's very simple. So it is 3 meter 3.0 by 4.2. Okay. And this much is enough. So the depth of the footing is not important for the excavation quantity because we are doing complete excavation. This depth, what you can see, it's a depth of the footing, which will try to take care of that in the later part, where we want to find the concrete quantity for the footing. Right now you only want length and the breadth. Yeah. Now coming to the length part, in this, which is a length. Yeah, we'll go in this way. Okay. Yeah. So first what they have done. Yeah. Now this is 3 meter, right? Forget this. Okay. Length and breadth. Anyhow, don't get confused with the length and breadth. I'll write breadth here. Yeah. Breadth, and let me write this as length. Okay. Always remember the whichever is a longer length, that will be your length, and the smaller will be the breadth. I'll write this as length. Okay, done. Chalo. Yeah. So 3 meter and 4.2 meter. 3 meter is smaller. So 3 meter will be my breadth and 4.2 meter will be my length. First, I'll take the breadth, that is 3 meter. So we are trying to find the excavation quantity. Now try to understand the logic. See, whatever size they have mentioned it here, I'll quickly do that. We already seen whatever size they have mentioned. This is a footing size. Whatever size they have mentioned, no, it is a footing size. Okay, but we know we have to take the PCC offset, right? Which is 700 mm on all the four sides. So again, after that, we are supposed to take what? That is a working space. So finally, we need to find this particular length. Finally, we need to find this particular length, that is this to from here to here and from here to here. This is what we are supposed to do. And right now, whatever you can see, that is 3 meter by 4.2 meter. So this is 3 meter and this is 4.2 meter, but I want from here to here. How do I do that? I'll first do it manually and show it to you. Later, with the help of Excel sheet, I'll teach you. Yeah. First, we'll take 3 meter. Understood? Plus. Now this offset, that is a PCC offset, usually it will be mentioned in the structural drawings, right? If it is not mentioned, you can take 75 mm or 100 mm. So let me show you one drawing. If it is mentioned, it's well and good. Yeah, see, it is not mentioned here, but you can, this distance you can see from here to here, this distance. Yeah, this distance from here to here, it will be usually 75 or 100 mm. It will be mentioned in the structural drawings. If not, you can take 75 or 100 mm. No issues with that. For my understanding, I'm going to consider this as to be I'll consider this to be 100 mm, right? I'll be considering this to be 100 mm. So we'll do that quickly. So 3 meter, 100 mm in terms of meter, it is 0.1. On the left side, I require 0.1 plus on the right side, I require 0.1. Done. Working space, I'll take 300 mm. Again, it will be told to you. Most of the time, we'll be taking 300. If it is mentioned like 400, 500, based on that, you have to take it. But most of the case, 300 mm is a good spacing, which is according to CPWD. And according to that, I'm taking 0.3 on the left side. Again, 0.3 on the right side. Try to add it manually. Let me do it quickly for you. 3 plus 0.1 plus 0.1 plus 0.3 plus 0.3. I'm getting 3.8. So this is 3.8 meter. Done. So you can see on the Excel sheet, the same 3.8, you can see it here. 3.8 is what you have got. Similarly, I'll do it for the length side also. Again, for the length, what is the length? It is 4.2 meter. This 4.2 you can see here, right? This is 4.2, right? Plus 0.1 to the left side, 0.1 to the right side, plus 0.3 on the left side working space, plus 0.3 on the right side working space. Try to do it along with me. 4.2. If you learn this, if I give you any project after this, you can do it easily. 0.3 plus 0.3. So I'm getting 5 meter exactly. And you can see here practically with the help of Excel sheet also, we got 3.8. It is 3.8 and length it is 5 meter. Is it understood up to here? Now just take a screenshot of this, just in case if you're interested to work out. Write down all these things and try to verify, try to do it manually, take it as a kind of assignment and try to check whether you are getting the same answer or not, right? So again, I can do it one more for you. I'll take this 4,500 and 3,700. So quickly I'll do this. 4,500 is what I'm taking now. So 4.5 plus 0.1 on the left side, 0.1 on the right side, working space is 0.3 and 0.3. So I'm getting 5.3. Exactly, I'm getting 5.3 here. Similarly, I'll take for 3.7. So this 3.7 is a breadth of your footing plus 0.1 plus 0.1. That is my PCC offset plus 0.3 is my working space on 0.3 and 0.3. I'm getting 4.5. So I'm getting 4.5, right? So I hope up to here concepts are clear. So we got a length, we got a breadth. Now I want the depth. Only then I'm going to get the volume, and that is called as cubic meter. And that is the amount of excavation quantity that I require, right? So for that, I need to refer the structural drawing. And in the structural drawing, it will be mentioned that what is the depth of your footing. I mean, what is the depth of your excavation? You can see from the natural ground level, that is NGL, you have to do an excavation of 1.5 meter. From here, you have to do an excavation. Here you have to do an excavation of how much? 1.5 meter. It is mentioned here. 1.5 meter. So directly I'll take it as 1.5 meter is my excavation quantity. Directly I'll input all those things there. So I'll go to one of the Excel sheet again. So here directly I'll write 1.5, isn't it? Again, I'll write one everywhere. I'll write 1.5 for time being. Otherwise, you can drag it in the Excel sheet in this way. And finally, you are going to get this answer, that is quantity per number. What is, how do you find this quantity per number? 3.8, multiply this by 5 and multiply this by 1.5. That is a length, breadth and depth will give me the excavation quantity for this F1 footing. So multiply this 3.8. I'm doing it manually into 5 into 1.5. I'm getting 28.5 cubic meter. So you can see 28.5. Now coming to the most interesting part, this F1 footing, right now we did it for only one footing, isn't it? Now practically let us consider in this particular drawing, how many F1 footings are there? So you need to check now. I'll go to the drawing now. It is nothing will mention here how many footings are there. You have to look into the drawing and we'll try to count how many F1 footings are there. So this is F3, F3, F6, F6, then we have F6, F6 everywhere. So right now I'm not getting any F1 footing here, but if I come here, no, just observe here. See, this is F1 footing. This is F1 footing. So one footing is here. This is second footing. 3, 4 numbers are done here. Again, let me check. Yeah, 5 number, 6 number, 7 number. Again, check whether you have F1 footing. Yeah, 7. These are F2. So far we got 7 footings of F1 number. Right. We don't have any other F1 footings. Only we have 7 number of F1 footings. Right. So what I'm supposed to do, directly total number, I'll put input 7 here and directly I'll hit enter. So you can see the quantity changing. I got 199.500. So you do it manually. that is 28.50 into 7 is what I'm supposed to do. 28.5 is quantity per number. Total I have 7 footing. You multiply 28.50 into 7, I'm getting 199.50 manually, and I'm getting 199.500, right? So this is how you're supposed to do. Now for this particular one drawing, let us consider I'm getting 865.335 cubic meter of the total excavation quantity I'm supposed to do, right? So I've written here total excavation quantity in cubic meter 865.335. So this answer what you're getting, no, 865.335. I'll go to the Excel sheet. I'll go to the BOQ, that is bill of quantity. It is the earthwork quantity what I'm getting. What is the quantity I got? 865, and inputting it here, 865.335. Yeah, I'm writing 865.335. Okay, so quantity I've written it here. This is how you have to fill the bill of quantities. For filling the bill of quantities, you know how to take out the quantities. So we have taken out the quantities. Now we are filling that into the bill of quantities. I'm entering it here, and finally I got that. And this is a rate given by the contractor. Let us say you are a contractor and you are going to tell, no, instead of paying 305, I'll get this particular work done at 275 rupees. I input 275, and now you see you have to pay how much it is, unit 10 you have to pay 2,37,967 rupees to take out the soil from your particular building of having 865 cubic meter of the excavation quantity. You're getting my point? So this is how the total bill we are going to make. I mean, this is how you're going to find the excavation quantity, and this is the total amount you require. Now this rate depends for whom you are giving the project, and what rate that contractor has given, that particular rate he is going to put here. Got it? So this is how you have to carry out the excavation quantity. Now coming to the main question, how do we prepare all these things? So these things comes through experience, but for your understanding, I'll take one Excel sheet and I'll explain you how it has to be done. So what all things we are supposed to feed up, I'll write here serial number SL. I am entering it on Excel sheet. Let me keep it in capital, serial number, right? So once the serial number is done, next what we are supposed to do? Okay, description of the work. Okay, where is that? Yeah, I'll write here serial number. Got it? Next I'll write description of the description of work. So here once you write, it won't be visible. So you can see this edit, this option here. You just drag it with your mouse so that description of the work is done. Next I want it terms, I want the units, right? I'll write units. Then I want length, leng, length. Then I want breadth. You have to input the units also, that is in meter. Right now I'm not doing it, will not waste our time. Length, breadth, and then I want depth of the excavation. Okay, and then I want quantity. Yeah, I want quantity per number. Got it? I want quantity per number. Next what we are supposed to do, quantity total numbers. Next I want total number, how many footings are there, and then you drag it in this way, and then I want total quantity. So I want total quantity. Is it done? Quantity. Got it? No, how you have to do? So you have to be good in Excel sheet. I can't explain everything here, but okay. Now I'll pick all these things. If I want to color this, there's one option here called it. You have to fill the color. If you want, you can fill the color in this way. If you want to change the size, if you want to give a different font, click here. You have to, you're selected, right? Everything is selected in this way. Go to Calibri and let me go, and whatever style you want, I'll keep this as in this way. Okay, then let me make it a center. You can see the here, with this you can make it a center. Got it? So this is done. So again you just pull this from here so that everything is visible clearly. Got it? Again, if you want to give a outline to this, again you see total number, this you drag in this way. Okay, you'll get total quantity. Now if you want to give a outline to this, I selected it here completely. You go to this option here, bottom border, click here. There's something written here, thick box border. Click on that. You can see everywhere the border has come. Now serial number is done. I'll give my first quantity 01. What is the description of the work? It is earthwork. earthwork. Earthwork done. Now units, we want it in terms of cubic meter. I'm writing cum. Now length, now I'll do it for one footing from this particular area. We can take this also. Okay, I'll take I'll take this particular drawing. Okay, we'll do for this. I'll take the footing size as this one, F7. We'll do it for F7. What is the size? It is 3.8 meter by 3.8 meter. This is the size of the footing. But when I input it in the Excel sheet, what I'll do, so always whenever you want to apply the formulas, input is equal to sign. See, concentrate on this part. Okay, whatever I write here, right? Whatever I write here, whatever I write here, it will come here. So just observe in this portion and you'll understand what I'm writing. Yeah. So right now I'm writing it here. I'm written, always you have to put equal to sign, is equal to, what is the size we got? 3.8 meter. I'm inputting 3.8. Let me confirm it once again. Yeah, 3.8 it is. Yeah, 3.8. So say plus, I'm inputting a plus, okay, on a keyboard. 0.1 to the left, 0.1 to the right, 0.1 plus 0.1 plus 0.3 to the left, 0.3 to the right, 0.3 plus 0.3. You can directly input 0.6 also, but for your understanding, I'm inputting 0.3 and 0.3 separately and give a enter button. So you can see directly 4.6 has come. Similarly, your breadth is also 3.8, but still will apply the formula is equal to sign 3.8 plus 0.1 plus 0.1 plus yeah 0.1 plus 0.3 plus 0.3. I'll hit enter button. I'm getting 4.6. Got it. Length is done, breadth is done. Now coming to the depth of excavation, we'll go to the structural drawing. So depth, this is the footing depth. You should not take this for excavation. For excavation, you can see here what is written from the natural ground level. You have to do an excavation of 1.5 meter. So we'll input 1.5 meter. We'll input depth directly 1.5 meter. Now quantity per number, right? I'll click here. I'll say equal to sign. And now I'll click on this. Okay. And then I'll give multiply sign. No. Yeah. Not the multiply. This one. The multiply on the keyboard. You give the multiply. Then again, I'll click on this. Again, you give the multiply button on your keyboard. Again, you select on the depth. And then you hit the enter button. So you'll get the quantity per number. Got it? Now coming to the total number. So total number will go to the X. Now for this particular footing, that is F7, we'll try to count how many F7 are there in the footing. F3, F6, F6. So everything is F6 here. I'm not able to find any F7 in this particular line. Yeah, there is one F7 here, one. And one F7 is here. Another F7 is here. Two F7 are done. Here another F7 is there. Three are done. Another one, four. Another one, five. Five. So only five F7 are there. So I'll go to the Excel sheet and I'll tell Excel total number is 5. I'll input 5. Now total quantity will be equal to sign, equal to I have given. I'll take quantity per number and I'll say the multiply button and I'll click on total number and I'll hit enter. So you got the total quantity. I got the total quantity as 158.7 cubic meter. I have done it for one footing. So I shouldn't have written earthwork here. I should have written the name of the footing. Okay. That is, let us say, which was the footing? F7 footing. And I should have written the name to that. Or here you can write earthwork. Okay. Got it? Yeah. Now to make it, to beautify this, what you can do is, you can merge in this way. I'll selecting here. I'm selecting here, dragging in this way so that I can give enough space to that. Vertically click on control button and try to drag in this way. Try to drag. Okay. And there's one option here. Oh, yeah. So I'll drag in this way. Got it? So this option here, merge at center. So you can see everything got merged. And now if I click here on this, it will come exactly at the center. Got it? Now to make it beautiful, what I can do, I can click on the bold option. So everything got bold. Again, you can change the style of this. Again, let me go for this bell empty, or you can take other one. I'll go with this one, bookman old style. Got it? And then if you want to change the color from there, give this as whichever color. If you want, you can give, instead of giving, yeah, I'll keep black everywhere, right? Got it? And now again, select everything in this way. Again, you go here, say thick box border. If you give thick box border, only the outer will be bordered. Instead of that, I want everything to be bordered. I'll select on that. I'll go here. Is everything written? All borders. Click on all borders. See, everything got border, right? So I did it for one footing. Similarly, you're supposed to do it for other footings as well. Got it? Again, if you want to beautify, you can do that. Again, if you want to fill this, let us say F7, I want this to be highlighted, or I want this quantity to be highlighted. Click here, go to this option, fill option, give a different filling to that. Let us say I want to make it red. I'll give it red. So in this one, 158.7 I've done, right? So in this way, we prepare all these Excel sheets. Got it? So in this way, you have to prepare the Excel sheet. Anyhow, we'll try to cover a bit of this. If you want to study everything in a more detailed way, quantity estimation course you can buy, okay, and you can learn from there. Yeah, you can ask for the coupons. I'll be sending you the coupons. If you have any doubts, you can WhatsApp, you can mail me on this, Akshay Kamath 73 at gmail.com. You can mail me here. I'll be sending you the coupons. Usually the course prices will vary from 360 to 400 Indian rupees. If you are from foreign, you will be, other than India, you'll be getting this for $9.99 most of the time. Okay, you just have to mail me here, so that whenever I see the mail, I'll reply you, just in case if I have a coupon available for you, right? Yeah, so I hope you got an idea how this excavation quantity has to be taken care of. So in this way, whichever drawing we get, no, practically tomorrow if I get a drawing something like this, again as a quantity estimator, I'm supposed to calculate all these things, F1, F2, F3, F4 footing and all these things. Got it? So in this particular drawing, how much will be down? This is in terms of feet now. So they are given 5 feet here. So in the Excel sheet, what you're supposed to do, again, you have to change the format. I've written everything in meter. For feet, again, you have to convert this into feet. Then here you will directly write 5 feet now. Okay. So in this way, everything will get changed. Yeah, so we understood what is bill of quantities. We understood how to take out the excavation quantity for this. So I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So in this lecture, we will understand how to take the levels at the site with the help of AutoCAL. So far what I told, that we understood how to take the breadth, we understood how to take the length. And also we saw from the drawing that this is a depth of the excavation that we are supposed to do. But how do you determine this depth? What is the instrument that you're going to use? Whether you make use of a tape or whether you have any certain instrument through which the level can be defined. We'll try to see that, right? So before that, we need to understand that all the construction project will have a permanent benchmark taken from the survey department or from the local authority. Keeping this reading, all of the levels are taken on the construction project for marking the levels. That means, see, usually if you take up any construction project, we'll be setting up a temporary benchmark. You can see something is written here. TBM stand for temporary benchmark, and then written something that is 3.357 meter, whatever it may be, right? So we want certain temporary benchmark to be set up in a particular project. Now, how do you do that? How do we get this temporary benchmark? We'll try to understand. So before understanding the temporary benchmark, we have something called as permanent benchmark. So I'll first explain you what is this temporary permanent benchmark. If you have visited to any of the railway stations, right, what will happen? You can see it's written New Delhi, and what is written here? Mean sea level, that is 214.42 meter. That means this New Delhi city is at a mean sea level at a height of 214.42 meter above the mean sea level. In the same way, if you come to Bangalore city, it is written MSL, that is mean sea level. It is 896.920 above the mean sea level. Now, what exactly is this mean sea level? See, suppose if I ask you, what is the height of this plane, then how you are going to tell me, right? So, for example, I asked one person to tell me the height of this building. he told me with reference to the top of this mountain, let me tell, with reference to the top of this mountain, he measured and told me that this is the height of the flight from that mountain, and let us say it is some 200 feet. Okay. Now I asked another person, tell me the height of this particular flight. So another person told me from the with reference to this particular mountain, you can see a small thing from here. He measured it and he told that the height of this flight is 350 feet from here. Now, if I ask another 3, 4 different people, based on where they are standing, they are going to tell me the height of this particular flight. But that will not work out for me, right? I want one particular benchmark, or I want one particular level from where all my measurements will be done. So that is why the concept of mean sea level comes into play. That means, so this is a sea what I have, right? So every time what will happen due to the waves, the sea will try to, you know, this is a kind of a wave what we try to see in the sea, isn't it? Now we have taken an average of this. So this averages and all this will taken by the survey department and all. So once in 20 years, they are going to measure that what is the average sea value and all. Okay, what is the average sea waves that we have got, and based on that, all these calculations will be done. So one thing we got, we are going to take an average of this waves. Okay, and with reference to this, we are going to tell all the distance. Now, after doing that, we got one mean sea level. So that is called as MSL. Now, if I ask you, always I'm going to measure from here itself. Always I'm going to measure from here itself. So this is my mean sea level. Okay. And now if I ask you what is the height of this flight, you're going to tell from this mean sea level, it is at a distance of 5,000 feet above the MSL level. That is, what is that? This particular flight is at a height of 5,000 feet MSL, that is mean sea level. In the same way, if I ask you what is the height of this particular hatch, that is the boat is here, the top of this, if I ask you how much it is, again you're going to measure it from the mean sea level. From the mean sea level, it is at a height of 3,000 feet. Got it? So this is the reference level. In the same way, in the same way, let us say I have one small building here, a kind of a building here. Let us consider. Okay. Now, if I ask you, tell me the height of this building, again, you're going to measure from where? From this mean sea level, you're going to measure and tell, okay, this is the height of my building. Got it? So this mean sea level will act as a reference for me. And from here only, all the railway station marking what they have given, no, that is taken from here. Got it? So that is why I had shown you this. That is, it is written. Now, what do you, now you understand what is this 896.920 MSL. That means this particular Bangalore city, that is at the railway station point, what we have, it is at a height of 896.920 meter from the mean sea level. Okay, so that is how you have to understand it. So now we understood all these things. Now, how do we carry this mean sea level? Because see, this mean sea level, whatever RL we have, that is reduced level we have, it is at the different, it is in the railway station. Now let us say the site what I am doing, it is, let us say 100 or 200 kilometers far away from the railway station. So in that case, how do you take care of this? I mean, how do you convert, how do you transfer this level to your particular site? These levels can be carried to a particular site either by leveling instrument, that is with help of an auto level, or even total station can be used, or with help of a satellite. So with the help of a satellite, we can try to do all those things. That's the one way. Second is that these levels can be taken even from a nearby government inspection bungalow or from the road level. Once these levels are carried, we will establish the permanent level of this on the site. That means you have two options. Either you can carry this level from the railway station to your site, that is one way of doing. Otherwise, usually there's something called as inspection bungalows. If you are in any of your city, we have IB, which is called as inspection bungalow. So since it's a government bungalow, even that particular bungalow will be having certain RL. Okay. In the same way, the road level, you can see these are my road, isn't it? Even the road is going to have certain RL. So we can take that as a reference level, and from that we can establish the permanent benchmark, or let us say temporary benchmark onto a site. Got it? So again, it's written TBM 100.0 meter. It has been carried from somewhere, and in this particular site, they have created a small, what I call this, a small kind of a structure, and over that they have written 100.00 meter, right? Yeah. Now this is how you carry it. Let us say you have a railway station or an inspection bungalow, and I've taken 896.920. So what is this 896.920? Let us consider I've taken it for the Bangalore city, 896.920, and I've written it here. Okay. or if it is not railway station, you can make use of an inspection bungalow. Even on the inspection bungalow, they are going to write it here. Now this is my road level. Now I'll transfer this. Even I can transfer with the help of Autolevel. Now how do we transfer this? All these things comes under the scope of a surveyor. A surveyor is going to do all with the help of all those calculation, height and rise method, okay, backside, foresight, all those things we have to do. We'll not try to get into that, right? Yeah. So this is a road level which is 96.9 meter. Now this is a particular site what I have. Now imagine this is a site what I have. I want to establish a temporary benchmark here. So whenever I do construction, no, whatever is my road level, 1 meter or 1 meter or 1.5 meter above that only I'll do my building construction. If you do at the same level, what will happen? Whatever water will come in on the road, the same will enter into your building. So we don't want that. Always whenever we do construction, we get the construction done at a height, at a more height than the road level. That is why you can see the level here, it is 96.9 meter, whereas when we transferred it to our site, I've taken it as 98.25 meter. That means almost 2 meter I've increased it from this particular level. Got it? So in this way I will carry, and I'm going to establish this temporary benchmark. You can see why I have established 4 different benchmark here, because see, if it's a very big project, then it's difficult for me with the help of one particular temporary benchmark to carry it everywhere. Let us say this is my entire project. Got it? And I have a lot of footings everywhere. I have a footing here, I have a footing here, I have a footing here, here, here. Okay, all these are my footing. Now let us consider for this particular footing, for this particular footing, I want to give the depth of the footing. So in that case, what I'm supposed to do, I'm going to keep my Autolevel here. I'll show you what exactly Autolevel looks like. Just till then, try to understand. So let us say this is my Autolevel. I'll keep it here. So I want to see this benchmark from here. So it's difficult for the surveyor to see the benchmark from here to here because it's a long distance. It's difficult. So instead of that, since this is a footing, I'm going to establish one temporary benchmark here as well, so that it is easy for me to see here, right? In the same way, if I want to give the depth of this footing, I won't be looking at this temporary benchmark. I'm going to look at this particular thing. In the same way, if I want to do a footing in this area, I'm going to look it in this way. So if it's a big project, we'll try to establish 4 or 5 different temporary benchmark at each of the corners, so that it is easy for me to carry out my surveying work. Got it? Yeah. So now we'll jump to this. What exactly is the Autolevel? So this is called as Autolevel. You can see this is the instrument what we have. So it's written Autolevel instrument, and this is a box of instrument. So to keep this, that is to balance this, we need to get a tripod. So this is called as tripod. Why it is called tripod? Because it is having 3 legs, 1, 2, and backside there's one more leg. So it is tri for 3. So it's a pod, tripod head. This is a tripod head. These are your adjusting clamps where you're going to fix the level, and this is a strap for you to carry, and this is a tripod with legs closed and carrying the strap. Got it? And this is a leveling carrying case. So this is where your auto level instrument is. Now this is how it looks finally. You can see this is how you kept your auto level. I mean, this is how your tripod looks. So these are the 3 legs, 1, 2, and 3, and these are the different names given to that. You call this as leg, this is called as pedal, this is called as sharp foot, then again this is called as belt. This is a mounting screw knob to fix your auto level over this, and this is a platform where you're going to keep the auto level. In the same way, this is how your auto level looks, and these are the different parts of that. Okay, so from here you are going to focus. This is your objective lens. From here you are going to focus, and from here you are going to see that. Sorry, from here you are going to from here you are going to see, and from here you are going to focus that. Then this is a sight what we have. Then this is the objective lens focus. These are the leveling screws. So this leveling screws will help us to make the level over this. Otherwise, what will happen? It won't be horizontal, isn't it? To bring it horizontal, with the help of this, we'll try to adjust it. So I'll show you a video for that, how the adjustment has to be done. And this is how it looks finally. Okay. Now coming to the main part, this is called as leveling stuff, because we need to understand the reading, right? So this is the leveling stuff, it is called, and this is called as leveling stuff. It has got different heights. Like this leveling stuff is up to 4 meter. You can see 4 meter written here, and all these are the readings. In the same way, you get another leveling stuff which is 5 meter here. So in this way, 3 meter, 4 meter, and 5 meter are the different heights that you're going to get for the leveling stuff. Got it? Yeah. Now this is how it looks. This is a back side of that leveling stuff, and this is a front side of that leveling stuff. And you need to understand how to read this particular values here, and I'll be teaching you that how to read all this particular drawing, all this particular readings. In the same way, how it looks practically, this particular thing will go inside this particular thing will go inside this, and this is how it looks. So in actual, whenever you want to close it, this is how this is the actual size of that. But inside that, again, another part will be there. Inside this, another part will be there, and inside that, another part will be there. Okay, so whenever you want to increase the height of this, you have to take it out so that you can see 1, 2, and 3. So based on that, whatever height is required, you can see one, they have opened it here, then they opened another one here, and in this way they have opened it. Got it? So this is how it has to be understood. Now coming to the reading part, see, one thing you have to understand, this is 7 meter. It's written 7 in the sense it is 7 meter. Okay, this is 7 meter. So 1 in the sense it is 7.10. So 7.10. Next, if I read it here, it is 7.20. If I read it here, it is 7.30. Then this is 7.40, 7.5, and 7.6. Got it? Yeah. Now let us say you have a reading something, this one. How do you read this? Let us say I want to read this particular. I got a line, or I got a level which says this is how it looks. Okay, then how do you read this? It's very simple. Try to understand. This is 7 meter, this is 7.1, and this is 7.2. Now this, each of this horizontal lines, what you can see, each of this is like yeah, so 1, 2, 3, 4, 5, isn't it? So each of this is 0.5 units. Each of this is 0.5 units. So if it is showing in the below portion, it is 7, 2, this is 0.1, it is 7.21 in this way. So it is 7.21. And then if it is in the bottom, it has to be odd number, like see 7.1 and 7.2. Up to here we are clear. If it shows here, it has to be 7.21. If it shows here, it has to be 7.23. If it shows here, it has to be 7.25. If it shows here, it has to be 7.27. That means 27, 25, 23, 21. That is 1, 3, 5, 7. That are odd. Those are odd numbers. In the same way, if it shows at the top, so here it was showing at the bottom. Here it was showing at the bottom. Now, if it's showing at the top, let us consider. Then it will be your even numbers. That means 7.1, 7.2, 7.3, and it is 7.4 here. Got it? Now again, it is showing at the top. So again, it is 7.4 it is. So it will be 7.42 on the top. If it was below, it would have been 7.41. Got it? Next, again, it is at the top. So each unit is 0.2 for 7.42. Next is 7.44. Each unit is 0.2 now. Okay, let me write it here. See, this each unit, what you can see, this each unit, okay, from here to here, okay, this is 0.2. I'll write it here. It is 0.2. If it's showing below, it will be 0.1, and if it is showing above the line, it will be 0.2. Got it? So that is how you have to read it. So again, now again you see here, it is again at the top. So this is 7.4, 4, it is 4 here, 4 to 4, 4. This is 7.44. Next, this is 7.46. Suppose if it was here at the bottom, then it would have been 7.45 exactly. Then this one, it is 7.48 at the top. Suppose if it was at the bottom, suppose if I had to read this particular thing, then what it would have been? It would have been 7.4, 7.42, 44, 46. It would have been 7.47. But here it is at the top, so it is 7.48. Then it is 5, 7.5, then 7.6. Got it? So in this way, you have to understand it. Now, take this as an example and let me know what exactly this reading. It's very simple. See, 1.3 meter is here. This is my 1.3 meter. So this is 1.3 meter here. 3.1, 3.2, 3.3. Got it? Up to here it is 1.33. If I go here at the top, it has to be 1.34. I'll write it here. See. So it is 1.3. We'll write in this way. It is 1.3. If I go here, it is 1.34. 31. Yeah, sorry. It has to be 1.31, 1.32, 1.33, 1.34, and this will be 1.35. Got it? Good. So now where is that showing? It is showing at the bottom. This is the reading what we are supposed to look. So how much it will be? Up to here it is 1.33, and this, if it is at the top, it would have been 1.34. We know that because you see here, this even numbers will be at the top, odd numbers will be at the bottom. So 1.33. So next is 1.335. Okay. So if it was at the top, it would have been 1.34. Got it? So that is how it is showing 1.335 here. Got it? Yeah. So this is how it looks practically. Look at this guy. He has fixed the tripod here, and from here he is going to project it here. Whatever reading he is going to get, no, that is going to note down. For example, let us consider from here I objected it here, I've seen it here, and let us say I got a reading. Through this you have to check, and I got a reading of 1260, let us say 1.260 meter. So that is how you have to understand it. Got it? Yeah. Now how do you take all this level? We'll try to understand. Usually when we work in a bigger projects, in the drawing itself, all these things will be mentioned. That is, you can see reference level from the ground level, that RL is 99.80. That means wherever you're standing, that is a ground level, that RL reduced level is 99.80. From where we got this? Again, we got all this level from the inspection bungalow, or let us say from the road we have taken. From the road, with reference to the road, I established this particular 99.80 on the ground level. It depends from place to place. Whatever is RL in your particular area, based on that, they have taken this. Again, the surveyor is going to give this. Got it? So this much is clear for us. And now this is a GFL level. GFL level in the sense, see, let us say this is my ground level. This is my ground level. Okay. This is a ground where I have. And above this, I want to construct a house. Above this, I want to construct a house. Above this, I want to construct, let us say this is my footing. Okay. Got it? Above this, I want to construct my house. Now, this 99.80, what you can see, that is this level. 99.80 is the top of your ground. Normal soil, what we have, that is your 99.80. And what is this 100.425? This 100.25 is a plinth top, the top of your plinth. See, usually we don't construct our house at the ground level or at the road level. We construct at certain height. So that certain height, what they have taken is this much. From here to the top of your plinth, this height is 450 mm. So it is 450 GL plus 450 they have taken, no, 450 mm, or it is 0.45 meter. Got it? Or it is 0.45 meter. Done, right? So this is that level what they have given. This level they have given it here, that is 100.25. So this RL will be 100.25 here. I hope this much things are clear for you. So all these things will be mentioned in your structural drawings. If you're working in a bigger project, smaller projects, we don't do all these things. Okay. So if I show you the smaller project, this is a smaller project. Here you can see nothing will be mentioned that this is a level and all. For smaller projects, all these things are not required. Only for the bigger projects, we want all these things because we have to carry it, because we will be having a surveyor for this. So that is why we want. For smaller projects and all these things we don't require. Normally, the contractor, the labor, or the site engineer can take care of this. Yeah. So that site engineer will take care of that, and you don't have to worry about it. Got it? Yeah. So now we'll see the practical application of this, how it has to be understood. Yeah. Now you see it here. This guy has fixed that auto level here, and this is the level. This on the top of this curb stone, you can see, this is a curb, what we call that. RL is 98.25. Let us consider how did we get it. So this surveyor might have transferred the level, or usually on the road they are going to write all these things. Okay. Now it is 98.25. That is the top of this bund. Now, as a surveyor or as a site engineer, how do you take the level? we always HI stand for height of the instrument. So what this height of the instrument I want to find now. So height of the instrument will be RL plus staff reading. That means RL is already known to us 98.25. That will be written here. Okay. And why I have taken 98.25 here? Because if I go back, so here we had taken 98.25, isn't it? This temporary benchmark what we had set up in our particular project. So that is why I consider 98.25. You can consider anything, whatever is there on your side. But here for our understanding, I've taken this top has 98.25. Let us consider. Okay. Then right. So which is equal to RL, it is 98.25. This will be given plus staff reading. Now let us say I am seeing through this and I got a reading on the staff which is 2.2 meter, which reads 2.2 meter. So height of the instrument will be 98.25 plus 2.2. It is going to give me 100.45 meter. So this is my height of the instrument which I require to take my level in the next part. Now I want to find the excavation depth level with the help of Autolevel. How do I do that? So usually whenever we work in the construction project, no, they are going to give us something called as floor finish level. That is the finishing level where you are going to get. Again, this thing will be mentioned in the structural drawing. If I show you again, you can see it here, no? GL plus 450 we have taken, no? That is 100.25. So from this level only, I'm going to take all my reference. That is why I consider this as 100.25. In some other project, this may be like 100.56 or let us say 101.60, whatever it may be. We are going to take this GFL level. That is a ground finish level that we are going to take. It is 100.25, right? I hope this much things are clear for you. So that is the level what I have written it here. So FFL level 100.25. Now let us say from here to here, that is a depth of excavation in the structural drawing. They have given it as 3.2 meter. In our drawing, for example, here in this particular drawing, how much they had given for us? They had given it as 1.5 meter, isn't it? 1.5 meter. Let us consider it is not 1.5 meter for time being. I'll make this as 3200 mm. Yeah, 3200 mm. Okay, got it. Now let us say for this particular footing only I'm doing from here natural ground level to the bottom of the PCC, it is 3200 mm. Okay. Now what I'm supposed to do? I've taken the same thing here. So it is 3.2 meter from here to here 3 point. And this is the thickness of a PCC, which is 75 mm. Okay. This much you have to understand. This is the thickness of a PCC. Again, it will be mentioned in the drawing, which is 75 mm. And let us say the depth of the foundation is 450 mm. The depth of the foundation is 450 mm. So the excavation level, I want to find this bottom level of the excavation. How do I find this? I know this is 100.25. This red line is 100.25 minus 3.2 is going to give me this bottom level. Minus 3.2 is going to give me this bottom level. You can see this bottom level. Yeah, this bottom level I'm going to get 97.05. That is 100.25 minus 3.2 will give me 97.05. This much I have understood. This much is understood. Next, height of the instrument we already got from the previous slide. That is RL plus staff reading 98.25 plus 2.2 meter, which comes out to be 100.45 meter. Got it? This much is clear. Now, just to get the staff reading, what I'm supposed to do, this 100.45, this 100.45 minus 97.05 is going to give me 3.4 meter. Now, this is a staff reading that I'm supposed to get when I keep my instrument. What I'm trying to tell is, let us consider I was standing here. Let us consider I'm standing here. Okay, and I fix my instrument here. This is my instrument. Okay, and this is my instrument here. So I want to get a 3.4 meter. When I do the excavation, I'm going to make use of the leveling staff. Anyhow, in the next lecture, I'll explain you in a more better way. So when I keep my staff reading, when I keep my staff, okay, leveling staff here, when I keep my leveling staff at this bottom, and when I try to see through this auto level here, the staff reading has to read 3.4 meter, 3.4 meter. If the staff reading reads 3.4 meter, then I can say that I have done excavation of exactly 3.2 meter. Just in case if my staff reading is not 3.4 meter, let us say if my staff reading is coming 3.2 meter, that means I have done a little less excavation because I wanted 3.4. I'm down by 200 mm. I'm less by 200 mm. So again, I have to do another 200 mm of excavation and then I have to test it again, right? So I hope you understood up to here, at least the basic part, what it has to be done and all. So in the next lecture, I'll explain you how this has to be practically applied on the site. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. In this lecture, we will see how a depth of the excavation is measured manually or how it is done in a local construction practices. We'll try to see a video of this. Also, we'll see how the excavation is done, and then we'll understand a bit about the Autolevel, how it has to be practically applied on the construction site. So I'll take you to one of the video now. Yeah. So I'll play this video. So you can see they are doing the excavation now. Now you should know, right, what is the depth of the excavation you are doing. So in the local construction, what they do, they make use of a small rebar, that is a reinforcement bar, okay, and the height of that will be the depth of your excavation. Let us say you want to do an excavation of, let us say, 5 feet, or let us say 6 feet. Now we are going to cut a rebar of 6 feet, and of course we are going to take it and keep it inserted into this pit. So you see that how it is being done now. So all these are the footings that we have excavated now. I'll go a bit forward. So you can see this guy, isn't it? You can see this particular rebar. The height of this rebar is, let us say, 6 feet or 5 feet based on the structural drawing that is given. If it is mentioned 6 feet, then we'll cut a rebar of 6 feet and we'll try to insert and we'll check, okay, where exactly we want. Then he is going to insert the excavator driver. Now you have to go another 100 mm or 200 mm extra, and based on that, this is how we do. So you don't require any Autolevel and all, but again, all these things will work out in a small project. In a bigger project, it's a bit difficult, but still, even the previous project where I worked, it was MNC company, there also we followed the same method. We wanted to do an excavation of around, let us say, 2 meter, that is around 6 feet. We did the same thing. We took a rebar of 6 feet and we inserted it, and this is how we did it, right? So this is how the excavation has to be done, and this is how we are going to get the level. The last few mm you can cut it off and you can measure it accordingly, right? Yeah. So this is a project what we were speaking of, like if you remember, it was a basement plus ground plus 4-story building. Here also we have done the excavation. So this particular building is somewhere close to the coastal region, so we are getting a water here. You can see whenever we did excavation we got water. It's very simple. You have to do the dewatering of this and nothing much to worry here. So here they have excavated completely, okay, it's complete. They have excavated this like a kind of a trench here, and they are going to excavate, and with the help of the tipper they are going to take the soil. Now you know what is the soil that has been excavated. Very simple, we have understood through the Excel sheets. And also if I ask you how do you find the quantity of soil that is being excavated, it will be very simple for you to answer. What you are supposed to do, you should ask me, tell me this length, tell me the breadth of this, and tell me the depth of this. If I multiply all the three quantities, I'm going to get the total soil that has been excavated from this particular site, right? So very simple mathematics. Length, breadth and depth will give me the total soil that has been excavated from here. Right? So this is how it has to be done. Now I'll show you how you practically do the leveling of this Autolevel instrument. Since we were discussing on this, this is called as tripod. You can see one tripod, second and third, and you have a leveling instrument inside this, and this is a leveling stuff. First you have to open the 3 legs of the tripod and try to keep it as far as horizontal. Now this guy is doing the same thing, okay, and this is how you have to fix it here, okay, with the help of this with the help of your foot you try to insert it inside. And now this is the Autolevel what we have. So this is we have a clamp here. Under this we have a clamp, and you can see here with this clamp we'll try to fix it. Got it? So once you fix it, now this auto level is not exactly horizontal. It's not exactly horizontal. We'll have a small bubble here. So these are the two knobs what we have. We have to rotate it. We have to take two knobs together, either rotate it clockwise or anti-clockwise, so that this bubble is going to come at the center. Now you see here how it is being done. So this guy is rotating it. He's taking it outside. Okay. And now you can see that bubble is rotating. This bubble, this has to come exactly at the center first. Then you can make use of the third one and then try to push it inside. First this two will try to level it, and from here you try to make small minor adjustment so that exactly it will come at the center. Yeah, got it? So this is how the leveling instrument has to be leveled. So once this is leveled, what we are supposed to do is we have to take a level from this. Okay, I'll show here, but this is not okay. Now from here he is going to measure the level. Okay, now we can consider this as a top. This is your benchmark. You can take in RL level whatever is mentioned. Let us say, I'll explain here a bit. Or the top of this, let us say it is 98.25. okay, and over this is 98.25. wherever the hard concrete surface you are able to see, isn't it? This is 98.25, and he has kept a staff over this. Now from here he has to take a reading. Let us say he has got some reading. I mean, you have to look through this. Now how do you look through this? Actually what happens, if you see this auto level, in the inside the machine you will be having this circular eyepiece, and in this circular eyepiece you will be written, there will be two one horizontal and one vertical line. Okay, one horizontal and one vertical line. So whenever you try to object it, what will happen, at this particular center you are going to get one reading, and that reading we need to pick. Okay, this exactly at the center you are going to get one reading, and that reading we are supposed to pick. So this guy is doing the same thing now. Okay, he will note it down. So what is noting down, it's the same thing what I explained, that is height of the instrument will be equal to whatever is the RL level plus staff reading. We call this a staff reading. So that means height of the instrument will be equal to, let us say reduced level I got 98.25 plus staff reading, let us say I got some 1.25. add it, you are going to get the height of the instrument. Got it? If I do it manually, 98.25 plus 1.25, I'm getting 99.5. so 99.50 is the height of your instrument. Got it? So this is how we are supposed to do it practically on the site. Okay, I hope this much is clear. So after this is not required for us. I'll directly go to the other video. Yeah, so here they have taken this is another video, same thing again. Let us say this is the top of your curb stone, and this RL is something, let us say it is a temporary benchmark. Okay, so let us say this is somewhere, let us consider it to be 100.35. so this one is 100.35. okay, now what you are supposed to do, from here you are going to see, you are going to get the one reading. So 100.35 plus whatever reading you got, no, that you have to add, you are going to get the height of the instrument, right? So I hope this much things are clear for you. Now with this understanding, we'll try to apply the same logic to our particular building, right? Now for this building, try to apply the same logic. I'll explain you what it has to be done. I want to find this depth from this top. This is my top, okay, from that is FFL level. From here I want to find the depth of this, from here to, okay, here, this is the depth. Okay, and this depth, let us consider it is 3.2 meter. I'll write it here, it is 3.2 meter. Okay, this much is understood. Now the top of this top whatever I have, no, that is my FFL level, floor finished level, and let us consider the RL what is given there, it is 100.25, that you are going to get from the structural drawing. Let me make use of a different color. Yeah, 100.25, this is a FFL level, floor finished level. Got it? This much is clear. This is that level. Okay, I'll mark it here. This is that level, top. From there you have to do a excavation of 3.2 meter. Now how do you take care of all these things? Very simple. So this is me or you standing here. I've set up my auto level. You have to set up like I showed how you have to level it. Now you can see a small stone kept here. Let us say this is my temporary benchmark which I have set up in my site. So the first thing is that once you level your instrument, take a staff, ask one of your assistant to go and keep the staff over this. Okay, and let us say once you keep the staff, you have to see through the auto level, and through the auto level you have to read a reading which is written here. Got it? So now let us consider the reading what I have got, it is 2.2 meter. 2.2 meter. Got it? Yeah, it is 2.2 meter. Done. This much is clear. Now how do I do the calculation? Same thing here. Now observe here, height of the instrument is equal to RL plus staff reading. RL is 98.25, reduced level is 98.25. you can see this is temporary benchmark. Okay, over this only I have kept, no, over this I have kept my staff. So I have to take this 98.25 will be written over this. It is not constant, depends from side to side, but here I have taken 98.25. got it? So 98.25 plus the staff reading, 98.25 plus 2.2 comes out to be 100.45 meter. This much is clear for us. Now excavation level, this top level is 100.25. 100.25 minus 3.25 will give me the bottom level. That the bottom level is, you can see, 97.05. this bottom level is 97.05. now I need to get a staff reading of how much? 3.4. that means it's 100.45 whatever I got, height of the instrument 100.45 minus 97.05. this is what I'm supposed to do. Okay, so how do I do that? Next I'll take this out. Yeah, this I'm going to take it out. Now what I'm going to do, also I'll delete all these things. Now what I'm supposed to do, I'll tell the same guy who helped me here to go and keep the staff here. He's going to go down and is going to keep a staff here. I'm not going to change my position. This is my fixed position. Throughout this process you have to be standing here only, and your auto level has to be here only. Now what I'm going to do, from here I'm going to see, from here I'm going to see here at this particular point, and when I see at this particular point I should get a staff reading of 3 point, how much I have written it here, 3.4 meter. I should get a staff reading of 3.4 meter here, right? When my staff is touching the bottom, this bottom, okay, if I'm getting a staff reading of 3.4 meter, that means whatever excavation I have done from here to here, that is of 3.2 meter, exact excavation I have done. I've done exact excavation of 3.2 meter, and that is the right thing what I've done. Got it? This much is clear. Just in case if you have not got 3.2 meter, let us consider, just in case, let us say instead of 3.2 meter you have got, yeah, let us write 3.2 meter here. Okay, yeah, now let us say instead of 3.4 meter you got the reading as 3.6 meter. You got the reading as 3.6 meter. So what does it mean? We were supposed to get 3.4. You are supposed to get 3.4, but you got 3.6 meter. That means you excavated through 200 mm more. Because see, to put it in a better way, the staff reading you have to understand how what exactly I'm trying to tell. The moment you are going up, I'll draw one line here. Okay, this is 1. Let us say this is 2. This is 3. And this is 4. I'll erase the other part. Yeah, now understand the staff reading. This is 1 meter. Okay, this is 2 meter, this is 3 meter, and this is 4 meter. Okay, so if I'm getting a staff reading of 3.6 meter, 3.6 is somewhere here. So if this reading has to come, that means this should have gone again little down. That means I've excavated 200 mm more. Got it? So if I'm getting exactly 3.4 meter, that means I'm exactly here, right? Because 3.4 will come somewhere here. 3 point, if this is 3, 3.4 will come somewhere here, and 3.6 will come somewhere here. If I want to get 3.6, that means this has to go down. This bottom should have gone down. If this has gone down, that means we have excavated another 200 mm extra, right? So that is why whenever you do the excavation, try to do 100 or 200 mm little less, so that you can verify it. Because if you excavate 200 mm more, again backfilling will be problem for you, right? So that is why the best idea is like I showed, no? You take a rebar, fix a rebar here of 3.2 meter and try to verify. That is how you can do. Otherwise you can make use of this auto level, and then also you can give the level. Now let me tell you one more thing. Now tell me, instead of 3.4 meter, let us say you got 3.2 meter. Let us say you got the staff reading of 3.2 meter. What does it indicate? I was supposed to get, I'll write it here. Yeah, this is 3. Let us consider this is 3.2, and let us consider this is 3.4 meter. Okay, and we'll erase this out. Not required. Not required. Okay, not required. Not required. Yeah. So what does it indicate? That means I was supposed to get a staff reading of 3.4, but I got 3.2. So 3 is here, 3.2 is here. This should have been 3.4. That means whatever excavation I have done so far, I have done the excavation of 3 meter. Again I'm supposed to do another 200 mm extra. You getting my point? So that means if you do another 200 mm extra excavation, and then what will happen, this particular stuff, what I able to see it here, isn't it? This particular stuff, it will go again down. It will go down by another 200 mm. Let me do in this way. Yeah, I'll change the color. Understand? This extra is 200 mm. So if this extra 200 mm goes down, then of course when you see from here the reading will go up, isn't it? 3.2. If it goes down, this much part, if it goes down, obviously when you project from here, it will be 3.4 meter reading. That means you have done 200 mm less excavation. Do another 200 mm excavation, and from here you have to see the reading again, right? So I hope I was able to convey most of the things to you. Just in case if you understood, it's well and good. If not, try to watch the video once again. You'll be in a position to understand. If not, you can put it in the comment box. I'll be there to answer your queries, right? Good. So other than that, rest all things remains the same. Only the thing is you have to understand the logic what we are trying to do. If you are finding it difficult, you can make use of that rebar like I mentioned. You can take a you can take a reinforcement bar of, let us say, 3.2 meter and try to excavate in this way, so that you get an idea what excavation you have exactly done. Yeah, so I hope you have enjoyed the lecture up to here. In the next lecture we'll try to see what we have to do, whether we have to do the PCC or whether we have to do the footing, and what is the sequence of construction we are supposed to follow. So we'll see you back in the next lecture. Thank you.
Hello, my dear students. Welcome back to the lecture. In this lecture, we will see how the soil has to be prepared for taking the PCC. And before that, we need to understand one more thing. That is, see, whenever we do the excavation, isn't it? We have to take care of that. That is keeping the safety in mind. See, if you're doing an excavation of, let us say, 3 feet or 4 feet, it's not a huge depth. So we don't have issue with that. Imagine you're doing an excavation for, let us say, 6 feet and 7 feet. In that case, we need to take care of the safety measures. So that is why we are looking at here. Look here how they have done the excavation. In this case, for example, let us consider we are supposed to do an excavation of, let us say, 10 feet. So directly this 10 feet excavation, yeah, directly you're not going to do the 10 feet excavation in this way, right? From here, you're not going to do a 10 feet excavation. Okay. Again, what will happen if you straight away cut the soil? There's a chances that if it's a loose soil, it's going to collapse from here. So that is why we are going to make, in case has a step. So that is why you can see it here. See, from here we have done excavation. After that, we are given this a kind of a step, and then again we are going to do the excavation. So especially in cases of trenches and all, this is how we are supposed to do. Other than that, this is how the shoring is done. So these are called as shoring. So if there is a loose soil and all, what will happen if you don't give this shoring? Then again, there's a chances of all the soil
falling from here. If it is a loose soil, then whatever soil you excavated, no, it will come back into the pit. So I don't want that to happen. So that is why we give a support, and which we call it as a shoring. You can see it here. So these are called as shoring. Again, this is how it is to be done: shoring for stable soil, shoring for loose soil, and shoring for long trenches. So in this way we have to do. But again, as I mentioned, if it is a smaller projects, you don't have to do. Okay. And also, where I used to work in the previous company, since it's a multinational company, so whenever we were doing excavation, let us say it's a 2 meter or 3 meter excavation, we used to do a barricading something like this. You can see it here. It's an excavation what we have done, and then we are going to erect four poles here, and then with the help of this barricading tape, you have to barricade in this way, so that a person who goes closer to this, he knows that excavation has been done, so he has to take care of himself. So what will happen if he falls in the pit? Again, that may lead into some problem. Again, it's a bad name to the company, and also if there is some accidents and all, which we don't want to happen in the construction side. So proper safety measures has to be taken. And also, when we work in a bigger projects, we have a separate engineer called as a safety engineer, who takes care of all these things. Again, you can see here, they have done the excavation and they are doing a barricading here. Okay, so this is how it has to be done. So I hope you have understood up to here. So that is why, if you can relate this with the previous example, so when we did the excavation here, you can see we did not straight away did the excavation here. Straight away we did not do the excavation. What we did, we gave a small, of course we gave a small stepping here. From here we have done the excavation, a small stepping. You can see it, isn't it? So straight away we have excavation, a small step we are given, and then we have done the excavation. So that is to make the soil stable. Otherwise, if you straight away cut it, there's a chances of collapse of your soil, which is not advisable, right? Yeah. So having said this, we'll go back to the main thing now. Next is about the preparation of the soil. So what exactly is this preparation of the soil? We'll see. So whenever we have done the excavation, with the help of an excavator we have done, so this excavator cannot give you a complete good surface. In the sides, what will happen, it will be something like this. Even the bottom is not, won't be very exactly horizontal. There may be up and down, right? So that you have to prepare it properly, so that you can keep the PCC over that. So you can see it here. Once we have done the excavation in this way, it's not a proper surface. Once the excavation is done with the excavator or a JCB, the soil is leveled with the help of a laborers, since the excavator cannot give a uniform surface. Two laborers are deployed at the excavation pit, and with the help of a pickaxe and an earth rammer, the soil is leveled uniformly. So what you usually do, see, now you can see the sides, no, they're not properly dressed up, right? You have to properly remove this excess soil. Even you can see the bottom, it's not uniform here. A lot of stones you can see. So with the help of two laborers, we'll deploy the two laborers, and with the help of a pickaxe, they're going to remove that excess, let us say 50 or 100 mm, and then they're going to do the ramming over that. So you can see this is a rammer what we have, and in this way they are going to do a ramming, so that you are going to get a horizontal surface. So you can see with the help of pickaxe, whatever extra soil is there, you'll try to take it out. And these are called as earth rammers, what you usually get in the market. With this you are going to do the compaction to that. So this is the kind of a earth rammer. So finally we want a surface something like this. Now you can see, look at the sides, how it has been cut. It is properly uniform, isn't it? And even look at the bottom, it is very good. So this is what we require. And you can see it here also. Look at the sides, how it is properly dressed. They're properly done the dressing of this. And then finally, this is also very good. And then we can lay the PCC. Now, why this has to be done? Who has to do that? The contractor has to do that. Again, if I go back to the BOQ, what was written in the BOQ, if you had observed it properly, what they have mentioned it here, earthwork excavation, all type of soil for foundation of buildings, culverts, water supply, sanitary lines, and electrical conduit, either in the pits or trenches in 1.5 meter and above. So what they have written in ordinary soil, including the dressing. You just concentrate on this particular line, including dressing the bottom, including dressing the bottom and the sides of the pits and the trenches, and stacking the excavated soil clear, right? That means all these things is written by the written in the BOQ. So that when the contractor does that, no, he has to do everything. He cannot say that I've only done the excavation, the sites I'm not going to do. No, it's written in the BOQ. According to that, he has taken up the contract, and based on that, he has to do the execution. So all these things, as an engineer, we have to make sure it is being implemented on our site. So once this is done, next what we are supposed to do? Next is, this is done to get a uniform surface, that is compaction of the soil by the compactor or preparation of the PCC. This is done to get a uniform surface, and if any loose soil is present, By compaction, it will be compacted. The soil before the excavation will be in an undisturbed state. That means, see, whenever we did an excavation, what happened? We had that initially the soil was very stiff, right? It was a undisturbed soil. So when we did a excavation, we actually disturbed the soil, right? Now finally we want a uniform surface. So either you can make use of the earth hammer and you can do the compaction. Otherwise, in the bigger construction project, what we do, we get an instrument or we get a machine called as plate compactor or a monkey rammer. With the help of that, we'll try to run that over the bottom layer so that it will get compacted and you're going to get a uniform surface. So this instrument, what you can see here, right? So this is called as plate compactor. And in the same way, this is also plate compactor. So this is a plate compactor and you can see a kind of an instrument here. So this one is called as monkey rammer. So I'll show you why it is called as monkey rammer, because when you start to when this machine starts to operate, it will jump like a monkey. So the moment it starts to jump, it's going to put a lot of vibration, and because of that, whatever excess soil you have which is not compacted, it will get compacted. So hence, once you start, it will start to run. Okay, this is called as monkey rammer and this is called as plate compactor. You can use anyone. Always a monkey rammer is better compared to the plate compactor. In plate compactor, you will not get that much energy whatever you get in the monkey rammer, but it depends which one you want to use. Okay, this is a plate compactor and a monkey rammer. So let me play a video of this. So try to see. I hope the video plays well. So look at this guy. This is how he's making use of this plate compactor. So you're going to get a uniform surface. So this has to be done in each of the pit. Let us say you're done 20 footing excavation. In all the 20 footing, you have to take this machine, put it inside the pit and try to run over this. Okay. Again, this usually we use in the bigger construction project. Smaller construction project, with the help of the earth rammer, you can do the compaction. It is okay. Bigger construction project, we want better quality, and that is how the standard operating procedure is all about. So that is why we have to use that. Now this is monkey rammer. You can see, look how it's jumping here. So hence it is called as monkey. So monkey keeps on jumping. The same it will do here, and a better compaction is achieved here, right? So I hope you have got an idea about how a PCC, this thing, how a earth has to be excavated and how a proper compaction has to be done. So in the next lecture, we'll try to see what is PCC, how a PCC has to be done. Before that, we need to understand one more concept. We'll see that in the next lecture. I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. In this lecture, we will see how the PCC has to be laid and what is quality check, how it has to be done. So before that, a small thing we'll try to understand. Now, see, all these are the footings that were excavated, isn't it? Now, how many footings are there? There are more than 10 footings here. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Almost 12 footings are there. So while working in a bigger projects, more than 100 footings will be there to be excavated. Of course, it's a very small house project. When we start to work on the industrial projects, when it's a very big apartments, or let us say it's a huge industrial structure, in that case, we'll be having a lot of foundations to be done. So as a site engineer, we need to do the planning accordingly so as to achieve the target and see to it that no vehicle movement is hindered. So we'll come to this point. What exactly do I mean by this? So now let us consider, I'll show you one of the drawing and then we'll come back to this. Okay. So what exactly I'm trying to tell you is, for example, let us consider I'm working on a project and this is a footing what I have. So try to count how many footings are there. So hardly there are like 20 or 22 footings, not more than that. So in this case, we don't have any issue with this. But so what I'm going to do, how I'm going to plan. So let us say tomorrow I'm starting with my excavation. I'm going to do the excavation up to this part. Okay. After 2 days, I'm going to do the excavation of the remaining footings up to here. Then I'm going to do the excavation of this another 3 footings. Then I'm going to do the excavation here, right? So it's a small project and overall we have a good area so that if you want to bring in your vehicle and all, it can pass. Because why I'm trying to tell, once we do the excavation, it's very difficult for the movement of your vehicle, isn't it? So to plan accordingly. Now, since it's a small project, it's okay. We can manage somehow. But now imagine a situation that you have been working, okay, that you're working on such a big project. Let me show you the big project. So you can see a lot of footings here. Everything is a footing here. So just try to understand. See, so this is C6 footing, C7. I mean, this is a F25, F26, F25, F26. Everywhere there's a footing. Now you can't keep on excavating the way you like. Let us say Today you excavated this much part, tomorrow you're going to excavate here, again if you're going to excavate here, then what will happen, it's difficult since it's a very big project. A lot of vehicle will come and go, right? For different items, different vehicles is going to come, so we cannot do excavation in that. For that we have to do proper planning. So how do you do the planning? I'll explain you that, right? Yeah, so we'll understand this through a small animation. Let us say this is a one excavation you have done, second, third, and whatever excavation you have done, whatever soil you have got, no, you have stored it here itself. Okay. In the same way, you have done the excavation for the next three footings, and also you have stored the soil here. So next again, what you did on the next day, let us say this is day one, this is your day two. On the day three, again you did the excavation here. Again you stored the soil here itself. Then again on the fourth day, you did three footing excavation. You stored the soil here itself. Again next you did excavation up to here, and you stored the soil here itself, right? Yeah. Now let us say once you've done the excavation, you want the RMC truck, that is a transit mixer, to come and place the concrete. Let us say on this particular footing here itself, you want to place the concrete. Now, once you call this RMC truck, what will happen? It will come up to here. After that, you already stored the soil here. Now, what will happen? This vehicle we cannot go from here. Again, here it will be a problem for you to place the concrete. Again, here it will be a problem for you to place the concrete. In the same way, here also, if you bring in the RMC truck, that is a transit mixer, it can place the concrete here, it can place the concrete here, but again it cannot go here because you already stored the soil. So you have done the excavation what you were supposed to do, but you did not plan it properly, because when the transit mixer came, it was very difficult for the transit mixer to make a movement. So you didn't plan it properly. Now what is the right way of planning? So this is wrong planning. The right way would have been, so you do the excavation and then you don't store it immediately here. Instead of storing the soil immediately here, what you do, you try to give certain gap between that, let us say at least a 1 meter or 1.5 meter gap, and you store the soil here. Okay. Then again on next day you did a excavation for the next three footings, you store the soil here. After that I won't be doing any excavation here. I'll go to the last footings here, that is I'll do the excavation of this three footing, and I'll store the soil here. I'll do the excavation of this three footing, and I'm going to store the soil here. Now we have done less excavation, but that is okay. But now what will happen, if I want to place a concrete, or let us say a PCC, to this particular concrete, I mean to this particular pit, I can call in the transit mixer and it can go easily throughout, right? In the same way, if I want to do the PCC for this six footings, easily my transit mixer can come and it can place the concrete. So here there is no hindrance to the movement of the vehicle. That is why I told in the beginning of the lecture, right? So this is the right way of planning. So why did I tell that? If it is a small project, something like this, here we hardly have 23 footings. So how do you plan? Okay, today you will say we'll do the excavation of this four footing. Next we'll do the excavation of this four footing. Then we'll do the excavation of this four footing. Then we'll do here. Again, it's a small project. We'll be not calling the transit mixer and all. Normal laborers can do the PCC or other activities, and there is no much problem with the movement of the vehicle. But as I mentioned, I show you one of the very large project. I'll show you one more project. Now imagine you have been working, you have started to work on this project. Again, you see here, how many footings are there? A lot of footings, isn't it? Everything is a footing here. So you can see it. So you can see the footings here. Everywhere it is a footing. So in this way, again, how you are going to plan? So what you're supposed to do is, let us say today you are going to do the excavation of this, all these footings. Let us say these five footings you are going to do the excavation. You'll store the soil somewhere here. Okay. After that, next day, tomorrow, let us say you have done the excavation of this five footings. Got it? So the middle portion, you are not going to excavate it. Now, in the middle portion, you can make the movement of your vehicle and other activities you can carry out here. So once you do the excavation, you'll put the PCC, you're going to put the concreting for the footing, then the column concreting will be done, then the backfilling will be done. Once the backfilling is done, that means once the soil goes back into the pit, next what you can do after that, that will take around 10 days process. It's a complete 10-day process. And from there again, what you're supposed to do, next you're going to do the excavation of these footings, right? Now what will happen, you'll be having a space here for the movement of a vehicle and all. Next you're going to start from here, right? So in this way you have to do the planning of your excavation, right? Yeah. So yeah, That is why always you have to plan your project. So failing to plan is planning to fail, right? So always whenever you take up any projects, you are supposed to do the planning, right? Otherwise, what will happen if you don't plan in this way? Let us say whenever we take up any projects, we'll be given a start date and we'll be given an end date, right? So we have to hand over the project within the end date. If you delay the project, then the client is going to impose the fine on you. All those things will be written in the contract document. Now let us say you took a project and you didn't plan all these things, like per day how many footings you are going to do the excavation, after how many days of excavation you are going to do the PCC one, after how many days of PCC you are going to do the footing reinforcement. And if you don't plan which day what footing has to be done, if you try to execute everything at once, later what will happen, you will be in a trouble. So always you have to plan a project. Now since I'm telling a word called as planning, I'll come a bit later, not now, maybe after one or two lectures. I'll tell you how this planning has to be done, at least a baseline schedule on a MSP, or sorry, on a Microsoft Excel, and we'll try to understand how it has to be done. So to make you more curious, I'll give you a small outline. So this is called as planning. In the planning, we'll try to write when my earthquake excavation will happen, when my PCC is going to happen, when the reinforcement is going to happen. I'm going to write a start date. I'm going to give an end date to that, right? All these things we'll try to understand in the upcoming lectures. Right now, we'll stop up to here, and next we'll go to the next process, that is about the laying of PCC. So we'll see what is laying of PCC. So next is PCC stand for plain cement concrete, which you already understood. And usually the grade of a concrete that we're supposed to use for the PCCs, it is M10. M10 most of the case. We know where M is a mix and 10 is a characteristic compressive strength of that particular concrete. A layer of PCC is usually 75 to 100 mm, which is laid on the ground to get a uniform surface, and the area where footing, rebar or mesh to be laid is free from dust and debris. Second, imagine PCC layer is like a blanket. Most of the times when we sit down, we spread a cloth or a blanket so that no dust gets collected on our clothes or body. That means, see, you have done the excavation and you have done that proper ramming. Now what we are supposed to do, we are going to put the PCC. Now the first question is that why this PCC has to be put. See, whenever we do the excavation, even we do the ramming activity, there's a slight variation in the level of your ground. That means your in that the soil will not be uniform. There might be slight variation. If there is a slight variation, when we keep the reinforcement mesh over that, when the mesh also there will be slight variation. I don't want that to happen. To get a uniform surface, I'm going to put a PCC. That is the first objective. Second is that, let us say you're not putting a PCC. Directly, if I keep the reinforcement bar of the footing here, then what will happen? Yeah, so if I directly keep the reinforcement mesh, so if you don't know what is mesh, a mesh will look something like this. Let me do that. So once you place the reinforcement mesh, you're going to keep the reinforcement mesh in this way for the footing. Okay. So if you don't put the PCC, what is happening? This reinforcement mesh, that is a rebar, you're directly exposing it on the soil. And in the soil, there may be some foreign materials, or let us say there may be sulfates, chlorides, and all. Again, that will come in contact with the rebar. That will come in contact with the concrete, right? Again, there may be a reaction between them. As a result of that, there might be a corrosion in the rebar, and if there is a corrosion in the rebar, the durability aspects is going to come down. So I don't want all that to happen. So that is why I'm going to give a certain layer of a concrete, which we call it as plain cement concrete. Hence PCC is given. Now in the PCC, you are not going to put any reinforcement. Hence we call it as PCC. If you're putting a reinforcement in that, we call it as a RCC, right? Yeah. So in the same way, whenever we sit down, isn't it? We don't want the dust to get collected on our cloth. We just put a, we just spread a cloth, and over that we try to sit. So that cloth, what we put, no, it's like, it will act like a blanket for us. In the same way, in a building construction, it is called as PCC. Okay. Yeah. So once you put the PCC, you can see we have put the concrete here. This is how your PCC bed is. We call this as a PCC bed. So you can see 1, 2, 3. In this way, 4 PCC bed we have put. Okay, you can see it here. So you have prepared this form work. All this form work you can see, and then you are going to place the concrete over that. So this PCC, sometimes we call it as a plumb concrete. So write it here. So remember, plumb concrete. So why it is called as plumb concrete? Because the ratio is somewhere close to 1 is to 4 is to 8. So here this aggregate, the last one is 8 is aggregate. The coarse aggregate content will be more here. So it will be a kind of a lean mix for us. Okay. So that is why we call it as a plumb concrete. The second thing which is very important, only in the PCC, The coarse aggregate what we are going to use, no, we are going to use it as 40 mm size. 40 mm, that is a bigger stones we are going to use here. You can see a lot of bigger stones here. If you just observe here, you can see a kind of a bigger stones here that are coarse grade. You can see here also, right? So that the size of that is 40 mm. Whereas in the normal RCC structure for a footing, for column, for slab, we use M20. So they may ask you in the interview sometime, what is the size of the aggregate that you're going to use in a PCC. So you can tell 40 mm is the size of the aggregate what we try to use. But in the normal footing and other RCC work, we are going to use only 20 mm aggregate and not more than that. Yeah. Right, finally you can see this guy how he has put the PCC, and finally this is a finished PCC how it looks once you do all the finishing activity. This is your PCC. So for the same project, you can see the one where we had understood the total station, they have done the excavation here. Okay, and once the excavation is done, they are preparing the coarse aggregate, they have a sand ready here, and then they are going to place in the PCC here. So in the same way, it's the same thing here. Now what should be the thickness of the PCC, from where we are going to get, again that will be mentioned in the structural drawing. I've taken one particular image of that. Don't try to concentrate anywhere, you just concentrate here. What is written here? 75 mm lean concrete. Again, lean concrete and PCC both are one and the same. Few people call it as plumb concrete. All three means same thing. Some people call this as bed concrete. Again, it's the same thing. You can call it as PCC, you can call it as lean concrete, you can call it as plumb concrete, you can call it as bed concrete. All are one and the same. So what is written? 75 mm you have to give. That is a thickness of that. 75 mm comes out to be 3 inches. So when we arrange the formwork, if you can see the formwork here, so this formwork, no, whatever we have arranged, so this is 3 inches. The height will be 3 inches, and whatever height we have maintained, throughout that we are going to pour in the concrete. You can see it here, right? It's written 75 mm lean concrete is written here, right? Yeah. So now you can see here, this is how they have prepared it, and now you can see everywhere. This is at 75 mm. This is at 75 mm. Everywhere they are going to keep, and this is how the 75 mm is prepared on the ground, right? Now one more thing you need to understand. See, now this is a very big area, isn't it? This area, what you can see, it's a very big area. So but you want to get a very uniform surface. Then how do you make it in a proper or a uniform shape? So you can see a lot of rebar has been pegged here. There's one rebar pegged here. One rebar they have pegged it here. Then they have another rebar which is pegged here, right? So on all the rebar, they have done the small marking of that 3 inches. And through that, they'll come to a conclusion. Okay, they have to stop the concreting up to that level, isn't it? So that means what I'm trying to tell is, you can see here, they are going to, you can see a kind of a small thread here. So this thread, they have marked it everywhere. And whenever the mason tries to do the leveling, no, he'll come to a conclusion that this is a 3 inch and this is where I have to do the finished surface. Similarly, I'll show you one more. So see it here, this guy is fixing that. Okay, you can see this guy is fixing that 75 mm height what you require in the PCC. Everywhere you can see. Again, auto level we know how to do. Anyhow, I'll explain you how to take the PCC top level. We already understood the excavation level, how it has to be understood. Once you pour the PCC, the top level also you're supposed to check. We'll see how it has to be checked. So this guy is holding auto level and is giving that top of that level. That's the one way out. Second way is that how you can do. The second way is that what you're supposed to do, you have to mark this 75 mm somewhere. Like let us say I'm marking it here. Okay. So this level is my 75 mm. So once you mark it here, if you don't have a total station, we get something called as water tube. Okay, water tube in the sense whatever tube you have to fill in the water, and through that you can transfer the level. So what you're supposed to do, once you get the tube level, you have to place one end of a tube level here, and wherever you want to transfer it, let us say I want to transfer the level here, then the other end of the tube you have to hold it here. So one end will be here, the other end will somewhere here, and here whatever bubble you are going to get, no, that is your 75 mm, and the same bubble you are going to get here also. So wherever that bubble stops, no, that itself is a level. So in this way, with reference to this red color, we'll try to, after that, once you transfer it here, here also you have to, here also you are going to get that red color, here also you're going to get that red color, right? Now again, let us say I want to transfer the level here. Again, what I'm supposed to do, again, I'll be holding the one end of the tube here, I'll bring the other end of the tube somewhere here, and I'll stop it. So once I stop it, the bubble will try to go and up and down, and at one particular state it's going to stop somewhere. The place where it's going to stop, that itself will make 75 mm marking. maybe that yeah, let us consider it has stopped somewhere here, and that itself is a level of a PCC. So in this way, throughout that formwork, we are going to transfer the level so that we are going to get a uniform surface, right? Anyhow, how to transfer the tube level, all these things we'll be seeing in the upcoming lectures. Since PCC is not that very good, I mean, we don't have to concentrate so much on the PCC, so we'll not do it here, but I've explained you how it has to be done. Yeah. So now once everything is done, next is we have to place the concrete, because we have seen how the formwork is done. So before placing the concrete, we have something called as quality check. You might have seen on any of the products and all, you can see it is written QC passed, quality control passed, right? In the same way, when we work in the bigger construction project, we have a person called as quality engineer. So before we do the concreting, he is going to come and check whether the work we have done is correct or not. So that is why we have certain checklist for that. We'll try to see what exactly our checklist is, and then we'll proceed further. So I'll show you one of the checklist now. So you can see here what is written: checklist for laying plain cement concrete. So this is a description. Check for the completion of preceding activities for the area to be correct, concreted. Check for the formwork and dimension. Is it okay? That means he's asking us whether the formwork what you have put for the PCC, whether it is according to the dimension or not. So we know the dimension from the structural drawing. If I go back here, let us say, this was the dimension what we wanted. Okay, inner to inner dimension, and this inner to inner dimension. I'll take some random value. Let us say this was 3 meter here, and this was 4 meter here, right? So that you have to do exactly. Then once it is done, you have to check the diagonal also, because now how you check the diagonal, you should check from this end to this diagonal how much you should get. We know that it is 3 4, and this has to be 5. So that also, as a site engineer, you need to check. So our quality engineer will come and check all these things. Only then he's going to allow you to pour the concrete, because when we work in bigger construction companies, we want quality standards to be maintained. So that is how it has to be done. So everything, all the alignment you have to check, and after that, this 3 4 5 method also we are going to check to make sure whatever sizes we have given, that is exactly correct or not. You're getting my point? So in this way, we'll be having a checklist. So that is why in the checklist they have written it here. Check for the formwork and dimension, is it okay or not? If it is okay, you are a site engineer, then what you're going to do, you're going to mark it here. Okay, all right. Here also everything is right. Next is again what is written: provision for the working condition of the concrete, whether you're making use of the vibrator or not, whether the needle of a vibrator is correct or not, whether you're making use of a mixer machine. Like for example, if you check here, these people are using a mixer machine, isn't it? So this is through a mixer machine they are going to place in the concrete. Now you have to check whether mixer machine is okay or not, right? All those things will be mentioned in the mentioned in the checklist, and based on that we are going to do. Next is during the, now this is before concreting. Even before you're placing the concreting, this is the checklist you need to check. Next is at the time of concreting, once you're placing the PCC, what are the check for the mixed proportion? What is a mixed proportion? It was given in the structural drawing that we have to provide 1:4:8. That means if I take you one of the drawing, see here. So this is a typical cross section. It is written 75 mm lean concrete. What is written here? 1:4:8. This is a ratio that you are supposed to maintain. In the same way, if I take you to one more structural drawing, so this is one more here, and what is written here? You can see PCC is written. The grade is 1:4:8, and what is the thickness? It is again 4-inch thickness. So all those things will be written in a structural drawing. So again, based on that, you have to say, okay, whatever check mix ratio was written in the structural drawing, the same is being executed on the side. Check for the placement and compaction. Is it okay? That is at the time of concreting, they're going to place the concrete, isn't it? You have to check whether properly it has been placed or not, whether they are properly compacted or not. So you can see it in one of the image how they are doing the compaction. See, this guy is doing this compaction, isn't it? So properly you have to compact it, because there the cement content will be very less. It's a lean concrete, and lot of coarse aggregate will be there. So properly you have to do the compaction there. Okay. Next is what is written again. Yeah, check for the finished level. Is it specified? Check for the surface finish. Is it acceptable? That means once you finish the concreting for the PCC, you have to check the top surface. Whatever marking you have done with the help of tube level or water level, whether the same level you have got or not. That also you have to check it here. And also the finished surface. The finished surface should be very good. Not too much good, since it's a PCC. At least it should be uniform. The main intention of putting up PCC was to get a uniform surface, right? If the PCC itself is non-uniform, there's no, that doesn't make any sense. So once you finish the PCC, you have to see whether the top surface is exactly horizontal or not. Again, that is mentioned in the checklist. You can see it here. Yeah, check for the surface finish, check for the finished level. So once this is done, after the concreting, we are supposed to do the curing. So what is curing? We'll see all that thing at the time of footing, but just understand curing is nothing but we have to we have to pour the water over the concrete once the concreting is done. So that is called as curing. So again, after concreting, like today if I have done the PCC, tomorrow I'll take out the shuttering, whatever formwork I had kept, and I'm going to pour in the water. So that is called as curing. And why it has to be done, all those things we'll try to see in the upcoming lectures. Yeah, so I hope the concepts are clear up to here. So we have understood what is PCC, how it has to be applied, what are the quality checklists that we are supposed to look in. Now finally, this is how your PCC looks. This is the next day. You can see these people had kept the runners. Okay, I'm showing you different images, don't get confused. See, these people had kept one runner here, they had kept another runner here, then he had kept another one here, then another one. So once you placed in the PCC, next day once the concrete gets set, they came and they removed all this PCC. You can see this PCC has been removed, and also they have done the watering. You can see this much portion is wet here, isn't it? They have done the curing of this, right? Yeah, similarly you can see it here. Now don't get confused about this A1 1 dash FP7 and all. We'll come to that a bit later. Just concentrate on the PCC, right? So this is a PCC that we wanted, and this is how we have got a PCC. Again, we know whenever we put a PCC, make sure we are taking the extra space, isn't it? If, for example, if you concentrate here, this was the size of the footing what we actually wanted. This one, this one, this one, and this one. But where we have done that casting, we have taken the excess, that is a PCC offset. This is 75, this is 75, 75 here, and 75 here. Got it? So that is why your PCC is looking big, but once you put the footing, your footing will be exactly on this marking, whatever marking they have done. We'll see that how that marking has to be done later. Yeah. So this is that PCC. Once it is removed, you can see a good PCC has come here. Here the finish surface is not that great, isn't it? See here a lot of core security you can see, but you should do it properly. Yeah. So this is that particular project we were looking at. Now these people also have placed a concrete here. Again, you see here, these people also have placed the concrete here. With this, they are going to do the ramming. And finally, this is how it is done. And finally, once it is done for that particular project, this is how it looks completely. They have done the PCC everywhere. You can see here also they have done the PCC completely. Got it? So in this way, you have to understand how it has to be done. Now we missed one thing, that is this checklist what I'm speaking, right? Actually, we were supposed to look the checklist even for the excavation. Checklist for the excavation in the soil. But I did not explain you. Quickly, we'll go through this. What is written? Is the excavation plan prepared? Is the layout, alignment, and size of the excavation marked on the ground as per the excavation plan? We had already marked it. This is the center line. We had taken the PCC offset. We had taken the working space. Everything we had marked according to the quality. Then, as a site engineer, what you're supposed to do? You're going to check it here. You say everything is correct. We have done it. Okay. Are there any underground utilities like sewers, water lines, cables, etc.? Okay, that is when you work in a bigger construction project and all, sometimes what will happen, there will be underground pipes of government projects and all. So you need to make sure that you're not damaging that. Is the area to be excavated clean and cleared of bushes, vegetation? Of course we did it, because in the first itself what we had done the cleaning of the trees and small plants and all. We already done that. So according to the quality of working. Next, check whether the barricading and caution signs are provided for deep excavation. Of course we are done. If you remember, in the beginning itself I told you, once we do the excavation, we are supposed to do the barricading and all. That also we have done. Then again, what the checklist reads, we'll try to quickly finish it. Okay, are the danger signs provided near the excavated? Of course we have seen that deep excavation, and that board sign also we are going to keep it there. Okay, after that, yeah, check for dewatering arrangement of waterlogged area. Is it okay? So I'll tell you one practical example of this. So for this particular footing, right, for this particular project, when we were doing the excavation, a lot of water was coming, because this particular project was very close to the sea. So what we used to do, we used to get in the pump, and whatever water you can see here, right, we were trying to take the water out with the help of a pump. This is what we had done. So that is why in the checklist they know all those things, that certain things will happen in a construction project. That is why they're asking, uh, uh, check for dewatering arrangements of waterlogged area, is it okay or not. So that is why when we did the final PCC for this particular work, so here you can see everything, the water has been dewatered, isn't it? Initially there was water, but there is no water, and slight water is there, but we'll try to dewater all these things. We did dewatering for that complete project, right? So when we were pouring the concrete, there was no water. This much water is enough, not an issue. Okay, finally we had removed all the water. Got it? So in this way, all the checklist will be given. I'll upload the checklist of this. And finally, you have to write this control lines, soil tap at the foundation level. That will be mentioned in the geotechnical report. What is NGL level? What is the foundation level? What is the depth of excavation? For our project, what is the depth of excavation? For that particular project, we had an excavation of, let us say, 3.2 meter. I'll write 3.2. And if I refer one more drawing, for example, we had this particular drawing. So in this particular drawing, the depth of excavation was how much? 1.5 meter. From here to here, the depth of excavation was 1.5 meter. So as a site engineer, I'll write it here that the depth of excavation was 1.5 meter for me. Okay, all these are the checklist that you different companies will have their different checklist. I'm showing you one checklist of out of it. Then the foundation level, what is the foundation level that you are supposed to write? Natural ground level and soil tap at the foundation level. Got it? So in this way, all this checklist you have to do, whichever is whichever is associated with your project, you have to just tick here. Something which is not associated, you can say not applicable. For example, let us say um, yeah, our joint inspection records complete, not this. We'll take something. Yeah, for example, let us say, are there any underground utilities like sewers, water pipes, cables, etc.? If yes, then bring to the notice of the site in charge and take adequate measures while excavation. Let us say this is not applicable to our area. We don't have any sewer lines or water pipes. In that case, I'll say NA, that is not applicable, right? So I hope in this way, we are supposed to do all the work, right? We are supposed to do the work in this way. And finally, this is how your PCC is going to look. So I hope you enjoyed the lecture up to here. So we'll see you back in the next lecture. Thank you. Hello, my dear students. In this lecture, we will see how the PCC is being done for this particular building, right? So you see here, these people are preparing this mixed design. What is that? It is a M10 grade of concrete, and the ratio is how much? 1:4:8. It is M7.5. M10 comes out to be 1:3:6. It is 1:4:8 here. It's a M7.5 grade. Okay, and now actually what they're doing, see here, we have done the dewatering, but still there was slight water left. Now directly we will not put the PCC over this. What will happen if I directly put the PCC over this? So let us consider, yeah, so let us consider, if I directly put the PCC over this, what will happen? No, so once we put the PCC, I'm supposed to do a small compaction over that, with the help of that earth rammer. So the moment I do a compaction, what will happen? This water will go up. Again, the cement particles will try to go down. So there won't be a good bonding between them. So that is why, to avoid that, what we are doing, we are going to put hard stones here first. You can see that, okay? So you can see rocks kept here. These are big kind of a boulders. So these boulders we are going to put first, and after that we are going to insert this. This is dust powder what we have brought. Okay, so what will happen by doing that? Now you can see we have put the boulders. Now once you put the PCC here, no, and once you do the ramming activity, it won't come up, like the water won't splash up, and also there will be proper compaction to the PCC. If you don't do in this way, directly if you put the PCC over this, what will happen? This water will, you can see how it is splashing, no? When you do the ramming also, same thing will happen. Again, you will not get a hard strata there. I mean, it won't be a uniform then. That is why we are doing this activity. Okay, now you can see. Now once we fill the dust into this, no, you'll get some a kind of a hard strata here, and then if you put the PCC, nothing is going to happen. So that is why, this is why we are putting the boulders now. Since we have that water, that water cannot be removed. Even if you pump, no, pump will not come. I mean, through the pump the water will not come. Hence we are using that. Now you can see here, they kept the inclined chute here. Okay, and now as an engineer, you know what all are the quality checks you're supposed to do. Okay, everything you have to look into the checklist, and through the checklist you will do the execution. The concrete mixer is ready here. They have kept they have this rammer here. Okay, and sides also they have put a kind of a small form work, that is okay. And you can see they have done a marking here. If you observe it correctly, you can see a small line thread which is being put here. So this indicates that up to this height you are to do, you are supposed to do the PCC, that will be 75 mm or 100 mm, whatever is mentioned. So all these are a nominal mix. We have seen, no, what is nominal mix. With the help of a mixer, this is how we are, everything is volumetric batching here. See, water also through a bucket is putting this coarse aggregate, fine aggregate through that butti. We call that a butti in the local language. So everything is based on the volume. There is no way batching here. You're not measuring any of the materials, right? So that is why it is called as volumetric batching. And here, since it is a PCC, we know what should be the size of the coarse aggregate. It has to be 40 mm. Okay, yeah. So we'll go forward now. Similarly, there they have done that again. A little bit of stone you have to put over there, and finally, once you now if you pour the concrete, no, now if you pour the concrete here, that is a PCC, and if you do the compaction, then what will happen? It is not in contact with the water this much area, so this water won't splash up, and you are going to get a uniform layer. Otherwise, if you put directly PCC here, see here you don't have stones, no, then water will splash up. Again, you will not get a uniform. That compaction will not happen. Okay, that means see this water. What will happen? Once you pour the concrete here, okay, and once you do the tramming, the water will come up in this way. It is going to splash. So I don't want that to happen, no? So I'm putting a bigger stones here and dust particles into that. Now if I place a concrete here, then this thing splashing will not happen. That is why we are putting the boulders here, since we have water in that region. Yeah, so I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture. Thank you.